The Meaning of Relativity, Lecture 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Amelia, Chesley. The Meaning of Relativity, Lecture 1. Space and Time in Pre-Relativity Physics. The theory of relativity is intimately connected with the theory of space and time. I shall therefore begin with a brief investigation of the origin of our ideas of space and time, although in doing so I know that I introduce a controversial subject. The object of all science, whether natural science or psychology, is to coordinate our experiences and to bring them into a logical system. How are our customary ideas of space and time related to the character of our experiences? The experiences of an individual appear to us arranged in a series of events. In this series, the single events which we remember appear to be ordered according to the criterion of earlier and later, which cannot be analyzed further. There exists, therefore, for the individual, an I-time, or subjective time. This in itself is not measurable. I can indeed associate numbers with the events in such a way that a greater number is associated with the later event than with an earlier one, but the nature of this association may be quite arbitrary. This association I can define by means of a clock, by comparing the order of events furnished by the clock with the order of the given series of events. We understand by a clock something which provides a series of events which can be counted, and which has other properties of which we shall speak later. By the aid of speech, different individuals can, to a certain extent, compare their experiences. In this way it is shown that certain sense perceptions of different individuals correspond to each other, while for other sense perceptions no such correspondence can be established. We are accustomed to regard as real those sense perceptions which are common to different individuals, and which therefore are, in a measure, impersonal. The natural sciences, and in particular the most fundamental of them, physics, deal with such sense perceptions. The conception of physical bodies, in particular of rigid bodies, is a relatively constant complex of such sense perceptions. A clock is also a body, or a system, in the same sense, with the additional property that the series of events which it counts is formed of elements, all of which can be regarded as equal. The only justification for our concepts and system of concepts is that they serve to represent the complex of our experiences. Beyond this, they have no legitimacy. I am convinced that the philosophers have had a harmful effect upon the progress of scientific thinking in removing certain fundamental concepts from the domain of empiricism, where they are under our control, to the intangible heights of the a priori. For even if it should appear that the universe of ideas cannot be deduced from experience by logical means, but is, in a sense, a creation of the human mind, without which no science is possible, nevertheless, this universe of ideas is just as little independent of the nature of our experiences as clothes are of the form of the human body. This is particularly true of our concepts of time and space, which physicists have been obliged by the facts to bring down from the Olympus of the a priori in order to adjust them and put them in a serviceable condition. We now come to our concepts and judgments of space. It is essential here also to pay strict attention to the relation of experience to our concepts. It seems to me that Poincaré clearly recognized the truth in the account he gave in his book, La Science et l'Hypothèse. Among all the changes which we can perceive in a rigid body, those are marked by their simplicity, which can be made reversibly by an arbitrary motion of the body. Poincaré calls these changes in position. By means of simple changes in position, we can bring two bodies into contact. The theorems of congruence, fundamental in geometry, have to do with the laws that govern such changes in position. For the concept of space, the following seems essential. We can form new bodies by bringing bodies B, C, up to body A. We see that we continue body A. We can continue body A in such a way that it comes into contact with any other body, X. The ensemble of all continuations of body A we can designate as the space of the body A. Then it is true that all bodies are in the space of the arbitrarily chosen body A. In this sense, we cannot speak of space in the abstract, but only of the space belonging to a body A. The Earth's crust plays such a dominant role in our daily life, in judging the relative positions of bodies, that it has led to an abstract conception of space, which certainly cannot be defended. In order to free ourselves from this fatal error, we shall speak only of bodies of reference, or space of reference. It was only through the theory of general relativity that refinement of these concepts became necessary, as we shall see later. I shall not go into detail concerning those properties of the space of reference which led to our conceiving points as elements of space, and space as a continuum. Nor shall I attempt to analyze further the properties of space which justify the conception of continuous series of points or lines. If these concepts are assumed, together with their relation to the solid bodies of experience, then it is easy to say what we mean by the three-dimensionality of space. To each point, three numbers, x1, x2, x3, coordinates, may be associated in such a way that this association is uniquely reciprocal, and that x1, x2, and x3 vary continuously when the point describes a continuous series of points, a line. It is assumed in pre-relativity physics that the laws of the orientation of ideal rigid bodies are consistent with Euclidean geometry. What this means may be expressed as follows. 2 points marked on a rigid body form an interval. Such an interval can be oriented at rest, relatively to our space of reference, in a multiplicity of ways. If now the points of this space can be referred to coordinates x1, x2, x3 in such a way that the differences of the coordinates delta x1, delta x2, delta x3 of the two ends of the interval furnish the same sum of squares. S squared equals delta x1 squared plus delta x2 squared plus delta x3 squared. For every orientation of the interval, then the space of reference is called Euclidean, and the coordinates Cartesian. It is sufficient, indeed, to make this assumption in the limit for an infinitely small interval. Involved in this assumption there are some which are rather less special, to which we must call attention on account of their fundamental significance. In the first place, it is assumed that one can move an ideal rigid body in an arbitrary manner. In the second place, it is assumed that the behavior of ideal rigid bodies towards orientation is independent of the material of the bodies and their changes of position, in the sense that if two intervals can once be brought into coincidence, they can always and everywhere be brought into coincidence. Both of these assumptions, which are of fundamental importance for geometry, and especially for physical measurements, naturally arise from experience. In the theory of general relativity, their validity needs to be assumed only for bodies and spaces of reference which are infinitely small compared to astronomical dimensions. The quantity S we call the length of the interval. In order that this may be uniquely determined, it is necessary to fix arbitrarily the length of a definite interval. For example, we can put it equal to 1 unit of length. Then the lengths of all other intervals may be determined. If we make the xv linearly dependent upon parameter lambda, xv equals AV plus lambda BV. We obtain a line which has all the properties of the straight lines of Euclidean geometry. In particular, it easily follows that by laying off n times the interval s upon a straight line, an interval length of n times s is obtained. A length, therefore, means the result of a measurement carried out along a straight line by means of a unit measuring rod. It has significance which is as independent of the system of coordinates as that of a straight line, as will appear in the sequel. We come now to a train of thought which plays an analogous role in the theories of special and general relativity. We ask the question, besides the Cartesian coordinates which we have used, are there other equivalent coordinates? An interval has a physical meaning which is independent of the choice of coordinates, and so has the spherical surface which we obtain as the locus of the endpoints of all equal intervals that we lay off from an arbitrary point of our space of reference. If xv, as well as x prime v, v from 1 to 3, are Cartesian coordinates of our space of reference, then the spherical surface will be expressed in our two systems of coordinates by the equations sum delta xv squared equals constant, sum delta x prime v squared equals constant. How must the x prime v be expressed in terms of the xv in order that equations 2 and 2a may be equivalent to each other? Regarding the x prime v expressed as functions of the xv, we can write by Taylor's theorem for small values of the delta xv. Delta x prime v equals the summation of dou x prime v over dou x alpha times delta x alpha plus 1/2 the summation of dou squared x prime v over dou x alpha dou x beta times delta x alpha delta x beta, and so forth. If we substitute 2a in this equation and compare with equation 1, we see that the x prime v must be linear functions of the xv. If we therefore put x prime v equals alpha v plus the summation of bv alpha times x alpha, or delta x prime v equals the summation bv alpha delta x alpha, then the equivalence of equations 2 and 2a is expressed in the form sum delta x prime v squared equals lambda sum delta xv squared, lambda being independent of delta xv. It therefore follows that lambda must be a constant. If we put lambda equal to 1, 2b and 3a furnish the conditions sum b v alpha b v beta equals dou alpha beta, in which dou alpha beta equals 1 or dou alpha beta equals 0, according as alpha equals beta or alpha does not equal beta. The conditions are called the conditions of orthogonality, and the transformations, 3 and 4, linear orthogonal transformations. If we stipulate that s squared equals the sum of delta xv squared shall be equal to the square of the length in every system of coordinates, and if we always measure with the same unit scale, then lambda must be equal to 1. Therefore, the linear orthogonal transformations are the only ones by means of which we can pass from one Cartesian system of coordinates in our space of reference to another. We see that in applying such transformations, the equations of a straight line become equations of a straight line, reversing equation 3a by multiplying both sides by b v beta, and summing for all the v's, we obtain sum b v beta delta x prime v equals sum b v alpha b v beta delta x alpha equals sum dou alpha beta delta x alpha equals delta x beta. The same coefficients, b, also determine the inverse substitution of delta xv. Geometrically, b v alpha is the cosine of the angle between the x prime v axis and the x alpha axis. To sum up, we can say that in the Euclidean geometry there are, in a given space of reference, preferred systems of coordinates, the Cartesian systems, which transform into each other by linear orthogonal transformations. The distance s between 2 points of our space of reference, measured by a measuring rod, is expressed in such coordinates in a particularly simple manner. The whole of geometry may be founded upon this conception of distance. In the present treatment, geometry is related to actual things, rigid bodies, and its theorems are statements concerning the behavior of these things, which may prove to be true or false. One is ordinarily accustomed to study geometry divorced from any relation between its concepts and experience. There are advantages in isolating that which is purely logical and independent of what is, in principle, incomplete empiricism. This is satisfactory to the pure mathematician. He is satisfied if he can deduce his theorems from axioms correctly, that is, without errors of logic. The question as to whether Euclidean geometry is true or not does not concern him, but for our purpose it is necessary to associate the fundamental concepts of geometry with natural objects. Without such an association, geometry is worthless for the physicist. The physicist is concerned with the question as to whether the theorems of geometry are true or not. That Euclidean geometry, from this point of view, affirms something more than the mere deductions derived logically from definitions, may be seen from the following simple consideration. Between n points of space there are n times n minus 1, all divided by 2, distances, s mu v. Between these and the 3 n coordinates, we have the relations s mu v squared equals x1 mu minus x1 v all squared plus x2 mu minus x2 v all squared plus, and so on. From these n minus 1 all over 2 equations, the 3 n coordinates may be eliminated, and from this elimination, at least n times n minus 1 all over 2 minus 3n equations in the S mu v will result. Footnote. In reality, there are n times n minus 1 all over 2 minus 3n plus 6 equations. End of footnote. Since the S mu v are measurable quantities, and by definition are independent of each other, these relations between S mu v are not necessary a priori. From the foregoing, it is evident that the equations of transformation 3 and 4 have a fundamental significance in Euclidean geometry, in that they govern the transformation from one Cartesian system of coordinates to another. The Cartesian systems of coordinates are characterized by the property that in them the measurable distance between 2 points, s, is expressed by the equation s squared equals the sum of delta xv squared. If k xv and k prime xv are 2 Cartesian systems of coordinates, then the sum of delta x v squared equals the sum of delta x prime v squared. The right-hand side is identically equal to the left-hand side on account of the equations of the linear orthogonal transformation, and the right-hand side differs from the left-hand side only in that the xv are replaced by the x prime v. This is expressed by the statement that sum delta x v squared is an invariant with respect to linear orthogonal transformations. It is evident that in the Euclidean geometry, only such and all such quantities have an objective significance, independent of the particular choice of the Cartesian coordinates, as can be expressed by an invariant with respect to linear orthogonal transformations. This is the reason that the theory of invariance, which has to do with the laws that govern the form of invariance, is so important for analytical geometry. As a second example of geometrical invariant, consider a volume. This is expressed by v equals integral dx1, dx2, dx3. By means of Jacobi's theorem, we may write integral dx prime 1, dx prime 2, dx prime 3 equals the integral of dou x prime 1, x prime 2, x prime 3 all over dou x1, x2, x3 times dx1, dx2, dx3, where the integrand in the last integral is the functional determinant of the x prime v with respect to the xv, and this, by equation 3, is equal to the determinant b mu v of the coefficients of substitution b v alpha. If we form the determinant of the dou mu alpha from equation 4, we obtain by means of the theorem of multiplication of determinants 1 equals the absolute value of dou alpha beta equals the absolute value of the sum b v alpha b v beta equals the absolute value of b mu v squared, and b mu v equals plus or minus 1. If we limit ourselves to those transformations which have the determinant plus 1, and only these arise from the continuous variations of the systems of coordinates, then v is an invariant. Footnote: there are thus two kinds of Cartesian systems which are designated as right-handed and left-handed systems. The difference between these is familiar to every physicist and engineer. It is interesting to note that these two kinds of systems cannot be defined geometrically, but only the contrast between them. Invariants, however, are not the only forms by means of which we can give expression to the independence of the particular choice of the Cartesian coordinates. Vectors and tensors are other forms of expression. Let us express the fact that the point with the current coordinates xv lies upon a straight line. We have xv minus av equals lambda bv, v from 1 to 3. Without limiting the generality, we can put sum of bv squared equals 1. If we multiply the equations by b beta v, compare equation 3a and equation 5, and sum for all the v's, we get x prime beta minus a prime beta equals lambda b prime beta, where we have written b prime beta equals the sum of b beta v, bv, and a prime beta equals the sum of b beta v, av. These are the equations of straight lines with respect to a second Cartesian systems of coordinates, k prime. they have the same form as the equations with respect to the original system of coordinates. It is therefore evident that straight lines have a significance which is independent of the system of coordinates. Formally, this depends upon the fact that the quantities xv minus av, all minus lambda bv, are transformed as the components of an interval, delta xv. The ensemble of three quantities defined for every system of Cartesian coordinates, and which transform as the components of an interval, is called a vector. If the three components of a vector vanish for one system of Cartesian coordinates, they vanish for all systems, because the equations of transformation are homogeneous. We can thus get the meaning of the concept of a vector without referring to a geometrical representation. This behavior of the equations of a straight line can be expressed by saying that the equation of a straight line is covariant with respect to linear orthogonal transformations. We shall now show briefly that there are geometrical entities which lead to the concept of tensors. Let P0 be the center of a surface of the second degree, P any point on the surface, and xi v the projections of the interval P0, P upon the coordinate axes. Then the equation of the surface is sum A mu v chi mu chi v equals 1. In this and in analogous cases we shall omit the sign of summation and understand that the summation is to be carried out for those indices that appear twice. We thus write the equation of the surface A mu v chi mu chi v equals 1. The quantities A mu v determine the surface completely for a given position of the center with respect to the chosen system of Cartesian coordinates. From the known law of transformation for the chi v for linear orthogonal transformations, we easily find the law of transformation for the A mu v. A prime o rho b o mu b rho v A mu v. This transformation is homogeneous and of the first degree in the A mu v. On account of this transformation, the A mu v are called components of a tensor of the second rank, the latter on account of the double index. If all the components A mu v of a tensor with respect to any system of Cartesian coordinates vanish, they vanish with respect to every other Cartesian system. The form and the position of the surface of the second degree is described by this tensor, A. Analytic tensors of higher rank, number of indices, may be defined. It is possible and advantageous to regard vectors as tensors of rank 1 and invariants, scalars, as tensors of rank 0. In this respect, the problem of the theory of invariance may be so formulated. According to what laws may new tensors be formed from given tensors? We shall consider these laws now in order to be able to apply them later. We shall deal first only with the properties of tensors with respect to the transformation from one Cartesian system to another in the same space of reference, by means of linear orthogonal transformations. As the laws are wholly independent of the number of dimensions, we shall leave this number n indefinite at first. Definition. If a figure is defined with respect to every system of Cartesian coordinates in a space of reference of n dimensions by the n to the alpha numbers, a, mu, v, p, alpha equaling the number of indices, then these numbers are the components of a tensor of rank alpha if the transformation law is a prime, mu prime, v prime, pho prime, and so forth, equals b mu prime mu, b v prime v, b pho prime pho, and so forth, a mu v pho, and so forth. Remark. From this definition it follows that a mu v pho, and so forth, equals B mu C V D fo, and so forth, is an invariant, provided that B, C, D, and so forth are vectors. Conversely, the tensor character of A may be inferred if it is known that the expression 8 leads to an invariant for an arbitrary choice of the vectors B, C, etc. Addition and subtraction. By addition and subtraction of the corresponding components of tensors of the same rank, a tensor of equal rank results A mu v fo, etc., plus or minus B mu v fo, etc., equals C mu v fo, etc. The proof follows from the definition of a tensor given above. Multiplication. From a tensor of rank alpha and a tensor of rank beta, we may obtain a tensor of rank alpha plus beta by multiplying all the components of the first tensor by all the components of the second tensor. T mu v fo, etc., alpha beta, etc., equals A mu v fo, etc., B alpha beta lambda, etc. Contraction. A tensor of rank alpha minus 2 may be obtained from the rank of alpha by putting two definite indices equal to each other and then summing for this single index. T fo, and so forth, equals A mu mu fo, and so forth, equals the sum of A mu mu fo, and so forth. The proof is A alpha mu mu fo, and so forth, equals B mu alpha, B mu beta, B fo lambda, and so forth. A alpha beta lambda equals do alpha beta, B fo lambda, and so forth. A alpha beta lambda, and so forth, equals B fo lambda, and so forth. A alpha alpha lambda, and so forth. In addition to these elementary rules of operation, there is also the formation of tensors by differentiation, Erweiterung. T mu v fo, etc., alpha equals do A mu v fo, and so forth, all over do x alpha. New tensors in respect to linear orthogonal transformations may be formed from tensors according to these rules of operation. Symmetrical properties of tensors. Tensors are called symmetrical or skew-symmetrical in respect to two of their indices, mu and v. If both the components which result from interchanging the indices mu and v are equal to each other, or equal with opposite signs. Condition for symmetry: A mu v fo equals A v mu fo. Condition for skew symmetry: A mu v fo equals negative A v mu fo. Theorem. The character of symmetry or skew symmetry exists independently of the choice of coordinates, and in this lies its importance. The proof follows from the equation defining tensors. Special tensors. 1. The quantities do, pho, sigma are tensor components, fundamental tensor. Proof. If in the right-hand side of the equation of transformation A prime mu v equals B mu alpha, B v beta, A alpha beta, we substitute for A alpha beta the quantities do alpha beta, which are equal to 1 or 0 according as alpha equals beta or alpha does not equal beta. We get A prime mu v equals B mu alpha, B v alpha equals do mu v. The justification for the last sign of equality becomes evident if one applies equation 4 to the inverse substitution, equation 5. 2. There is a tensor do mu v fo and so forth skew symmetrical with respect to all pairs of indices whose rank is equal to the number of dimensions n, and whose components are equal to +1 or -1, according as mu, v, pho, etc. is an even or odd permutation of 1, 2, 3, etc. The proof follows with the aid of the theorem proved above. The absolute value of b pho sigma equals 1. These few simple theorems form the apparatus from the theory of invariance for building the equations of pre-relativity physics and the theory of special relativity. We have seen that in pre-relativity physics, in order to specify relations in space, a body of reference or a space of reference is required, and in addition a Cartesian system of coordinates. We can fuse both these concepts into a single one by thinking of a Cartesian system of coordinates as a cubical framework formed of rods each of unit length. The coordinates of the lattice points of this frame are integral numbers. It follows from the fundamental relation s squared equals delta x1 squared plus delta x2 squared plus delta x3 squared that the members of such a space lattice are all of unit length. To specify relations in time, we require in addition a standard clock placed at the origin of our Cartesian system of coordinates or frame of reference. If an event takes place anywhere, we can assign it to 3 coordinates, x, v, and a time t, as soon as we have specified the time of the clock at the origin, which is simultaneous with the event. We therefore give an objective significance to the statement of the simultaneity of distant events, while previously we have been concerned only with the simultaneity of 2 experiences of an individual. The time so specified is at all events independent of the position of the system of coordinates in our space of reference, and is therefore an invariant with respect to the transformation. It is postulated that the system of equations expressing the laws of pre-relativity physics is covariant with respect to the transformation 3, as are the relations of Euclidean geometry. The isotropy and homogeneity of space is expressed in this way. Footnote: the laws of physics could be expressed even in case there were a unique direction in space, in such a way as to be covariant with respect to the transformation 3. But such an expression would in this case be unsuitable. If there were a unique direction in space, it would simplify the description of natural phenomena to orient the system of coordinates in a definite way in this direction. But if, on the other hand, there is no unique direction in space, it is not logical to formulate the laws of nature in such a way as to conceal the equivalence of systems of coordinates that are oriented differently. We shall meet with this point of view again in the theories of special and general relativity. End footnote. We shall now consider some of the more important equations of physics from this point of view. The equations of motion of a material particle are m d squared xv over dt squared equal xv. dxv is a vector. dt, and therefore also 1 over dt, an invariant. Thus, dxv over dt is a vector. In the same way, it may be shown that d squared xv over dt squared is a vector. In general, the operation of differentiation with respect to time does not alter the tensor character. Since m is an invariant tensor of rank 0, m d squared xv over dt squared is a vector, or tensor of rank 1, by the theorem of the multiplication of tensors. If the force, xv, has a vector character, the same holds for the difference m times d squared xv over dt squared minus xv. These equations of motion are therefore valid in every other system of Cartesian coordinates in the space of reference. In the case where the forces are conservative, we can easily recognize the vector character of xv. For a potential energy phi exists, which depends only upon the mutual distances of the particles and is therefore an invariant. The vector character of the force xv equals negative dou phi all over dou xv is then a consequence of our general theorem about the derivative of a tensor of rank 0. Multiplying by the velocity a tensor of rank 1, we obtain the tensor equation m times d squared xv over dt squared minus xv, all multiplied by dxv over dt, equals 0. By contraction and multiplication by the scalar dt, we obtain the equation of kinetic energy, d times mq squared over 2 equals xv dxv. If chi v denotes the difference of the coordinates of the material particle and a point fixed in space, then the chi v have the character of vectors. We evidently have d squared xv over dt squared equals d squared chi v over dt squared, so that the equations of motion of the particle may be written m times d squared chi v over dt squared minus xv equals 0. Multiplying this equation by chi mu, we obtain a tensor equation m d squared chi v over dt squared minus xv, all multiplied by chi mu, equals 0. Contracting the tensor on the left and taking the time average, we obtain the varial theorem, which we shall not consider further. By interchanging the indices and subsequent subtraction, we obtain, after a simple transformation, the theorem of moments. D over dt times m times chi mu times d chi v over dt minus chi v times d chi mu over dt equals chi mu xv minus chi v x mu. It is evident in this way that the moment of a vector is not a vector, but a tensor. On account of their skew-symmetrical character, there are not 9, but only 3 independent equations of this system. The possibility of replacing skew-symmetrical tensors of the second rank in space of 3 dimensions by vectors depends upon the formation of the vector a mu equals 1/2 a sigma rho dou sigma rho mu. If we multiply the skew-symmetrical tensor of rank 2 by the special skew-symmetrical tensor dou introduced above, and contract twice, a vector results whose components are numerically equal to those of the tensor. These are the so-called axial vectors, which transform differently from a right-handed system to a left-handed system from the delta xv. There is a gain in picturesqueness in regarding a skew-symmetrical tensor of rank 2 as a vector in space of 3 dimensions, but it does not represent the exact nature of the corresponding quantity so well as considering it a tensor. We consider next the equations of motion as a continuous medium. Let phi be the density, u, v the velocity components considered as functions of the coordinates, and the time xv the volume forces per unit of mass, and p v sigma the stresses upon a surface perpendicular to the sigma axis in the direction of increasing xv. Then the equations of motion are, by Newton's law, phi du v over dt equals negative dou p v sigma over dou x sigma plus phi xv, in which duv over dt is the acceleration of the particle which at time t has the coordinates xv. If we express this acceleration by partial differential coefficients, we obtain, after dividing by phi, dou uv over dt plus dou uv over dx sigma times u sigma equals negative 1 over phi times dou p v sigma over dou x sigma plus xv. We must show that this equation holds independently of the special choice of the Cartesian system of coordinates. uv is a vector, and therefore dou uv over dou t is also a vector. Dou uv over dou x sigma is a tensor of rank 2. Dou uv over dou x sigma times u rho is a tensor of rank 3. The second term on the left results from a contraction of the indices sigma and rho. The vector character of the second term on the right is obvious. In order that the first term on the right may also be a vector, it is necessary for p v sigma to be a tensor. Then, by differentiation and contraction, dou p v sigma over dou x sigma results, and is therefore a vector, as it also is after multiplication by the reciprocal scalar 1 over pho. That p v sigma is a tensor, and therefore transforms according to the equation p prime mu v equals b mu alpha b v beta p alpha beta, is proved in mechanics by integrating this equation over an infinitely small tetrahedron. It is also proved there by application of the theorem of moments to an infinitely small parallelopedion, that p v sigma equals p sigma v, and hence that the tensor of the stress is a symmetrical tensor. From what has been said, it follows that with the aid of the rules given above, the equation is covariant with respect to orthogonal transformations in space, rotational transformations, and the rules according to which the quantities in the equation must be transformed in order that the equation may be covariant also become evident. The covariance of the equation of continuity, dou pho over dou t plus dou pho uv over dou xv equals 0, requires from the foregoing no particular discussion. We shall also test for covariance the equations which express the dependence of the stress components upon the properties of the matter, and set up these equations for the case of a compressible, viscous fluid with the aid of the conditions of covariance. If we neglect the viscosity, the pressure P will be a scalar and will depend only upon the density and the temperature of the fluid. The contribution to the stress tensor is then evidently P dou mu v, in which dou mu v is the special symmetrical tensor. This term will also be present in the case of a viscous fluid, but in this case there will also be pressure terms which depend upon the space derivatives of the uv. We shall assume that this dependence is a linear one. Since these terms must be symmetrical tensors, the only ones which enter will be alpha multiplied by dou u mu over dou xv plus dou uv over dou x mu plus beta dou mu v times dou u alpha over dou x alpha. For dou u alpha over dou x alpha is a scalar. For physical reasons, no slipping, it is assumed that for symmetrical dilations in all directions, for example when dou u1 over dou x1 equals dou u2 over dou x2 equals dou u3 over dou x3, dou u1 over dou x2, etc. equals 0. There are no frictional forces present, from which it follows that beta equals negative 2/3 alpha. If only dou u1 over dou x3 is different from 0, let P31 equal negative alpha multiplied by dou u1 over dou x3, by which A is determined. We then obtain for the complete stress tensor P mu v equals P dou mu v minus alpha multiplied by dou u mu over dou xv plus dou uv over dou x mu minus 2/3 multiplied by dou u1 over dou x1 plus dou u2 over dou x2 plus dou u3 over dou x3 multiplied by dou mu v. The heuristic value of the theory of invariance, which arises from the isotropy of space, equivalence of all directions, becomes evident from this example. We consider finally Maxwell's equations in the form which are the foundation of the electron theory of Lorentz. Dou h3 over dou x2 minus dou h2 over dou x3 equals 1 over c dou e1 over dou t plus 1 over c I1. Dou h1 over dou x3 minus dou h3 over dou x1 equals 1 over c times dou e2 over dou t plus 1 over c I2. Dou h2 over dou x1 minus dou h1 over dou x2 equals 1 over c times dou e3 over dou t plus 1 over c I3. Dou e1 over dou x1 plus dou e2 over dou x2 plus dou e3 over dou x3 equals 4. Dou e3 over dou x2 minus dou e2 over dou x3 equals negative 1 over c times dou h1 over dou t. Dou e1 over dou x3 minus dou e3 over dou x1 equals negative 1 over c dou h2 over dou t. Dou e2 over dou x1 minus dou e1 over dou x2 equals negative 1 over c times dou h3 over dou t. Dou h1 over dou x1 plus dou h2 over dou x2 plus dou h3 over dou x3 equals 0. I is a vector because the current density is defined as the density of electricity multiplied by the vector velocity of the electricity. According to the first three equations, it is evident that E is also to be regarded as a vector. Then H cannot be regarded as a vector. Footnote: these considerations will make the reader familiar with tensor operations, without the special difficulties of the four-dimensional treatment. Corresponding considerations in the theory of special relativity, Minkowski's interpretation of the field, will then offer fewer difficulties. End footnote. The equations may, however, easily be interpreted if H is regarded as a skew-symmetrical tensor of the second rank. In this sense, we write H23, H31, H12 in place of H1, H2, and H3 respectively. Paying attention to the skew symmetry of H mu v, the first three equations of 19 and 20 may be written in the form of dou H mu v over dou xv equals 1 over c times dou E mu over dou t plus 1 over c I mu. Dou E mu over dou xv minus dou EV over dou x mu equals 1 over c times dou H mu v over dou t. In contrast to E, H appears as a quantity which has the same type of symmetry as an angular velocity. The divergence equations then take the form dou EV over dou xv equals pho. Dou H mu v over dou x pho plus dou H v pho over dou x mu plus dou H pho mu over dou xv equals 0. The last equation is a skew-symmetrical tensor equation of the third rank. The skew symmetry of the left-hand side with respect to every pair of indices may easily be proved if attention is paid to the skew symmetry of H mu v. This notation is more natural than the usual one because, in contrast to the latter, it is applicable to Cartesian left-handed systems as well as to right-handed systems without change of sign. End of the Meaning of Relativity, Lecture 1.
Excerpt from Chapter 4, Names and Sentences of the First Fleeters, from Convict Life in New South Wales and Van Diemen's Land. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Excerpt from Chapter 4, Names and Sentences of the First Fleeters, by Charles White. A correct list. The lifers, 14 and 7 years convicts. A prophetic song. Story of the last survivor. The following is a correct list of the convicts who were sent out in the First Fleet, showing the periods for which they were transported. Transported for life. George Barbsby, Robert Bales, Thomas Barrett, William Blatherhorn, James Cox, William Davis, Joseph Donnage, Thomas Eccles, Thomas Gearing, John Harris, Joseph Hall, James Heading, John Hill, William Hilt, John Kellen, alias Keeling, David Kilpack, George List, Thomas Limpus, Mary Long, Mary Marshall, Hannah Mullins, Richard Partridge, Sarah Perry, Charles Peat, John Ponty, Anne Reed, Thomas Risdale, alias Crowder, John Rugglass, John Ruffler, James Shears, Joseph Tusso, John Welsh, Edward Whitten, Charles Wilson, Samuel Woodham, and John Wolcott. Transported for 14 years. Samuel Day, Francis Davis, William Hogg, Margaret Jones, John Jones, Thomas Jones, Jeremiah Leahy, Joseph Long, Anne Lynch, Joseph Marshall, Betty Mason, Lydia Monroe, Joseph Owen, Isaac Rogers, Daniel Spencer, John Stogdell, James Underwood, Mary Wade, alias Cacklane, and Mary Wickham. Transported for 7 years. Robert Abel, Henry Abrams, Esther Abrahams, Mary Abel, alias Tilly, Thomas Akers, John Adams, Mary Adams, Richard Agley, John Allen, William Allen, Charles Allen, Susanna Allen, Mary Allen, Jasmine Allen, alias Boddington, Mary Allen, alias Connor, John Anderson, Eliza Anderson, John Anderson, Fanny Anderson, John Archer, John Arscott, George Alkinson, Sarah Alt, John Einers, alias Agnew, John Iris, James Bartlett, Henry Barnett, alias Bernard, alias Burton, Stephen Barnes, George Bannister, John Bursard, George Barland, James Balding, alias William, Elizabeth Basin, James Bailey, John Baisley, Thomas Baker, Catton Batley, Samuel Barbsby, John Ball, John Barry, Daniel Barrett, Elizabeth Barber, Ruth Baldwin, alias Bowyer, Martha Baker, William Bell, Samuel Benier, Jacob Bellet, Anne Beardsley, John Best, Elizabeth Beckford, Thomas Bellamy, James Bird, Samuel Bird, Joseph Bishop, John Bingham, alias Bangham, Eliza Bingham, alias Mooring, Eliza Bird, alias Winifred, William Blackall, William Blunt, Francis Blake, James Bloodworth, Susanna Blanchett, Peter Bond, John Boyle, William Boggis, William Bond, Mary Bond, Rebecca Bolton, Jane Bonner, Mary Bolton, James Brown, William Brown, John Bringley, John Brindley, Richard Brown, William Brogue, James Bradley, James Bradley, Thomas Brown, William Bradbury, Thomas Bryant, William Bryant, Thomas Brown, John Bradford, James Brannigan, Robert Bruce, William Brown, John Bryant, William Brewer, William Bryce, Curtis Brand, Michael Bryant, Lucy Brand, alias Wood, Mary Branham, Elizabeth Bruce, James Burleigh, Peter Byrne, Patrick Byrne, Simon Byrne, John Busley, Margaret Byrne, Mary Burkitt, Sarah Burdo, Joseph Carver, James Castle, James Campbell, alias George, James Campbell, John Carney, Francis Carty, Anne Carey, Richard Carter, alias Michael Cartwright, Henry Cable, Mary Coral, John Sesser, William Shields, Thomas Shattuck, William Church, William Chaff, Samuel Chinnery, Edward Channin, Richard Clow, Thomas Clements, John Clark, alias Hoser, William Clark, John Clark, Mary Cleaver, George Clear, Elizabeth Clark, William Connolly, Edward McCormick, James Corden, Joseph Colling, William Cole, John Matthew Cox, Richard Collier, William Connolly, Cornelius Connolly, Ishmael Coleman, John Coffin, Elizabeth Cole, James Cope, Anne Combs, Elizabeth Cole, Elizabeth Coley, Charlotte Cook, Mary Cooper, Anne Colpitts, John Cross, John Cropper, William Cross, John Creamer, Jane Creek, Edward Cunningham, James Bryan Cullen, John Cullyhorn, Jacob Cudlip, alias Norris, John Cuss, alias Hannaboy William Cucko, Aaron Davis, Richard Day, Edward Davies, Samuel Davis, William Davis, James Davis, Daniel Daniels, James Daly, John Davidson, Richard Davis, Anne Daly, alias Anne Warburton, Margaret Darnell, Anne Davis, Elizabeth Dalton, Rebecca Davidson, Margaret Davidson, Sarah Davies, Mary Davies, Michael Dennison, Barnaby Dennison, Patrick Delaney, Thomas Dixon, alias Ralph Call, Timothy Diskel, Mary Dixon, Mary Dickinson, William Douglas, Ferdinand Dowland, James Dodding, alias Doring, William Dring, Elizabeth Dudgeons, Jane Dundas, Anne Dutton, Leonard Dare, Mary Dykes, William Earl, William Eagleton, alias Bones, Mary Eaton, alias Shepherd, Rachel Early, Martha Eaton, William Edmonds, William Edwards, George Eggleston, Peter Elam, William Elliot, Joseph Elliot, Deborah Elam, Nicholas English, John Everett, Matthew Irvingham, William Evans, Elizabeth Evans, Philip Farrell, William Farley, Anne Farmer, Benjamin Fenton, John Ferguson, Thomas Fellesi, Jane Fitzgerald, alias Phillips, William Field, John Finlow, alias Hervey, Jane Field, Elizabeth Fitzgerald, Edward Flynn, Phoebe Flaherty, Francis Focus, Robert Forrester, William Foyle, Anne Fowles, Margaret Fownes, Anne Forbes, James Freeman, Robert Freeman, William Francis, George Francisco, George Fry, Catherine Fryer, alias Pryor, William Fraser, Ellen Fraser, John Fuller, Francis Gardner, Edward Garth, Francis Garland, Susanna Garth, Mary Gable, Olive Gascoigne, George Guess, Annie George, Thomas Glenton, Daniel Gordon, Edward Goodwin, Andrew Goodwin, John Gould, Charles Gray, Samuel Griffles, alias Briscoe, alias Butcher, Nicholas Greenwell, John Green, Thomas Griffiths, Charles Granger, James Grace, Hannah Green, Mary Gloves, Mary Green, Anne Green, Mary Greenwood, William Gunter, John Handford, John Hatcher, William Hawfield, Richard Hawkes, William Harris, John Hatch, John Hartley, John Hart, Joseph Haynes, Henry Hathaway, Dennis Hayes, Samuel Hall, Joseph Harbine, Joshua Harper, George Hayton, alias Clayton, Joseph Harrison, John Hart, John Hayes, Joseph Hattem, Joseph Harrison, William Hamlin, John Hall, John Haddon, William Harris, Cooper Handy, William Haynes, Elizabeth Hervey, Margaret Hall, Francis Hart, Mary Harrison, Thomas Headington, John Herbert, Catherine Hart, John Herbert, Dorothy Hanland, alias Gray, Sarah Hall, Maria Hamilton, Mary Harrison, Esther Harwood, alias Howard, Elizabeth Hayward, Elizabeth Hall, Jane Herbert, alias Rose, alias Jenny Russell, Catherine Henry, William Hindley, alias Platt, Ottawell Hindle, John Hill, Thomas Hill, Thomas Hill, Elizabeth Hipsley, Mary Hill, Job Hollister, Thomas Howell, William Holmes, James Holloway, Thomas Howard, John Howard, James Hortop, William Holland, Susanna Holmes, Elizabeth Hollogen, Hugh Hughes, Edward Humphrey, William Husband, John Hughes, Jeremiah Hurley, William Hubbard, Henry Humphreys, Thomas Hughes, James Hussey, John Hudson, Frances Ann Hughes, Susanna Huffwell, Mary Humphreys, Thomas Hylids, James Ignam, John Irving, Anne Annette, William Jackson, David Jacobs, John Jacobs, Hannah Jackson, James Jameson, Jane Jackson, alias Esther Roberts, Mary Jackson, Robert Jeffries, John Jeffries, Robert Jenkins, alias Brown, John Jepp, William Jenkins, Francis Joseph, Thomas Jones, Charles Johnson, Edward Jones, Thomas Joseph, William Johnson, Stephen Johns, Edward Johnson, Richard Jones, William Jones, Catherine Johnson, Mary Johnson, Thomas Kelly, Martha Kennedy, Thomas Kidney, Wilhelm Kilby, John King, Edward Kimberly, John Noller, Andrew Noland, David Lanke, Richard Lane, John Laurel, William Lane, James Larne, John Lambeth, Henry Lavelle, Flora Lara, Caroline Laycock, John Leary, Stephen Legrove, George Legg, Elizabeth Lee, Isaac Lemon, Elizabeth Leonard, Joseph Levy, Amelia Levy, Sophia Lewis, Samuel Lightfoot, John Limeburner, Elizabeth Locke, John Lockley, Joseph Longstreet, Mary Love, Nathaniel Lucas, Humphrey Lynch, John Lyde, John Law, James Macri, John Macintyre, John Mansfield, Stephen Martin, John Martin, Abraham Martin, Thomas Martin, Anne Martin, James Martin, Will Marney, William Mariner, John Merritt, Jane Marriott, Mary Marshall, Joseph Marshall, Susanna Mason, Anne Mather, Thomas Matten, Richard May, Sarah McCormick, Mary McCormick, Eleanor McCabe, Richard McDeed, Alexander MacDonald, James McDonagh, Redman McGrath, Francis McLean, Thomas McLean, Edward McLean, Charles McLaughlin, William McNamar, Jane Meach, William Meach, Jacob Messiah, John Maynow, Samuel Midgley, Richard Middleton, Charles Milton, Matthew Mills, Mary Mitchcraft, Nathaniel Mitchell, Mary Mitchell, Samuel Mobbs, John Mullins, Charles Mood, John Moodin, William Moore, William Morgan, Robert Morgan, Richard Morgan, John Morley, Joseph Morley, John Morisby, John Morris, Mary Morton, John Mortimer, John Mowbray, Edward Moyle, Jesse Mullick, Stephen Mullis, John Monroe, James Murphy, William Murphy, John Neal, James Neal, Elizabeth Needham, Robert Nettleton, John Newland, John Nicholas, Phoebe Norton, Robert Nunn, John O'Craft, James Ogden, William Oakey, Thomas Oldfield, Isabella Oldfield, Peter Opley, Thomas Orford, Elizabeth Osborne, Thomas Osborne, John Owen, John Owls, Paul Page, Joseph Paget, John Henry Palmer, William Payne, Elizabeth Parker, Mary Parker, John Parker, William Parr, Edward Perry, William Parrish, Peter Paris, Jane Parkinson, Anne Parsley, Sarah Partridge, John Pierce, James Poulette, Joshua Peck, John Penny, Edward Perkins, Richard Percival, Edward Bearcroft Perrett, John Petrie, John Petit, John Petherick, William Phillimore, Mary Phillips, Richard Phillips, Roger Fifield, Mary Fine, Samuel Pigott, Mary Piles, Mary Pinder, Elizabeth Pipkin, William Platt, Jane Poole, David Pope, John Power, William Power, Anne Powell, Elizabeth Powley, John Price, James Price, Thomas Price, Thomas Pritchard, John Ramsey, William Radford, John Randall, William Reed, Bartholomew Reardon, Charles Repeat, George Raymond, John Rice, James Richard, James Richard, David Richard, Hardwick Richardson, John Richardson, James Richardson, Samuel Richardson, William Richardson, John Richards, William Rickson, Edward Risby, Henry Roach, John Robert, William Roberts, William Roberts, William Robinson, George Robinson, George Robinson, Thomas Robinson, John Robbins, Daniel Rogers, Mary Rolt, John Romaine, Anthony Rope, Isabella Rawson, Walton Roos, John Rowe, William Rowe, James Roos, or Roos, John Russell, Robert Ruth, Jenny Rose, or Russell, John Ryan, William Saltmash, Peter Sampson, William Sands, Thomas Sanderson, Anne Sandelin, Robert Scattergood, Elizabeth Scott, Samuel Selfhire, John Seymour, George Sharp, Joseph Shaw, William Shearman, Robert Shepherd, William Shore, John Shore, Robert Sidaway, John Silverthorne, Sarah Slater, John Small, Richard Smart, Daniel Smart, Anne Smith, Anne Smith, Anne Smith, Catherine Smith, Catherine Smith, Edward Smith, Edward Smith, Hannah Smith, James Smith, John Smith, John Smith, Mary Smith, Thomas Smith, Thomas Smith, William Smith, William Smith, William Smith, William Smith, William Smith, William Snallham, Henry Sparks, John Spencer, Mary Spence, Charlotte Sprigmore, Mary Springham, James Squires, William Stanley, Thomas Stanton, John Morris Steffens, Robert Steffens, Margaret Stewart, John Stoke, Martin Stone, Charles Stone, Henry Stone, James Stowe, Thomas Stretch, James Strong, John Summers, Joshua Taylor, Henry Taylor, Sarah Taylor, Cornelius Teague, Thomas Hilton Tennant, James Tenshaw, Elizabeth Thackeray, John Thomas, John Thomas, James Thomas, Elizabeth Thomas, William Thompson, William Thompson, James Thompson, Anne Thornton, James Towdy, Thomas Till, Thomas Tilley, Nicholas Todd, John Trace, Susanna Trippett, Joseph Trotter, Moses Tucker, Thomas Tummins, John Turner, John Turner, Ralph Turner, Mary Turner, Thomas Turner, Anne Twyfield, William Twinham, William Terrell, John Usher, Edward Vandell, William Vickery, Henry Vincent, Richard Waddicombe, Mary Wade, Benjamin Wager, Ellen Wainwright, James Wauburn, John Walker, William Wall, William Walsh, John Ward, Anne Ward, Charlotte Ware, William Waterhouse, Mary Watkins, John Watson, Thomas Watson, John Welsh, Benjamin West, John Westwood, Edward Westlale, Samuel Wheeler, George Whittaker, William Whiting, John Wifehammer, Samuel Wilcox, John Wilding, Charles Williams, John Williams, John Williams, James Williams, Peter Williams, Robert Williams, Daniel Williams, Francis Williams, Mary Williams, Peter Wilson, William Wilton, George Wood, Mark Wood, Peter Woodcock, Francis Woodcock, William Worsdale, Anne Wright, Benjamin Wright, James Wright, Joseph Wright, Thomas Wright, William Wright, Lucy Wood, Thomas Yardsley, Nancy Yates, John Young, Simon Young, Elizabeth Youngson, George Youngson. This list is given not for the purpose of gratifying any morbid curiosity, but simply to preserve the names of those who were the real pioneers of the colony. To many of these men, with others who were not marked with the felon's brand, belonged the credit of making the initial movements in that work of colonization which has spread so widely and with such marvelous rapidity through this vast continent. They toiled and suffered to an extent which the mind fails to compass, and from their toil and suffering there sprang the first shoots of that industrial and commercial life which today is throbbing with a vigor not exceeded by any nation upon the face of the earth. End of excerpt from Chapter 4, Names and Sentences of the First Fleeters, by Charles White.
Rules of the Road at Sea, by the U.S. Coast and Geodetic Survey. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Rules of the Road at Sea and in harbors, rivers, and inland waters, except the Great Lakes and their connecting and tributary waters, as far east as Montreal, by the United States Coast and Geodetic Survey, August 1895. Regulations for Preventing Collisions, compiled from the Revised Statutes of the United States, the Treasury Department Circulars of the Commissioner of Navigation, and from the General Rules and Regulations prescribed by the Board of Supervising Inspectors of Steam Vessels, 1895, for insertion in volumes of the United States Coast Pilot, Atlantic Coast. An Act in regard to collision at sea. Be it enacted by the Senate and House of Representatives of the United States of America in Congress assembled, that in every case of collision between two vessels, it shall be the duty of the master or person in charge of each vessel, if and so far as he can do so, without serious danger to his own vessel, crew, and passengers, if any, to stay by the other vessel until he has ascertained that she has no need of further assistance, and to render to the other vessel, her master, crew, and passengers, if any, such assistance as may be practicable, and as may be necessary, in order to save them from any danger caused by the collision, and also to give the master or person in charge of the other vessel the name of his own vessel and her port of registry, or the port or place to which she belongs, and also the names of the ports and places from which and to which she is bound. If he fails so to do, and no reasonable cause for such failure is shown, the collision shall, in the absence of proof to the contrary, be deemed to have been caused by his wrongful act, neglect, or default. Section 2. That every master or person in charge of a United States vessel who fails, without reasonable cause, to render such assistance or give such information as aforesaid, shall be deemed guilty of a misdemeanor, and shall be liable to a penalty of $1,000, or imprisonment for a term not exceeding 2 years, and for the above sum the vessel shall be liable, and may be seized and proceeded against by process in any district court of the United States by any person, 1/2 such sum to be payable to the informer, and the other half to the United States. Section 3. That this act shall take effect at a time to be fixed by the President by proclamation issued for that purpose. Approved September 4th, 1890. Proclamation dated November 18th, 1890. To take effect December 15th, 1890. Rules of the road at sea adopted by all important maritime nations. The following Act of Congress to adopt the revised international regulations for preventing collisions at sea was approved March 3rd, 1885. Some foreign governments have not adopted paragraphs A and C of Article 10 in the form here given, but these paragraphs apply only to fishing vessels and boats when in the sea off the coast of Europe lying north of Cape Finisterre. An act to adopt the revised international regulations for preventing collisions at sea. Be it enacted by the Senate and House of Representatives of the United States of America in Congress assembled, that the following revised international rules and regulations for preventing collisions at sea shall be followed in the navigation of all public and private vessels of the United States, upon the high seas and in all coast waters of the United States, except such as are otherwise provided for, namely, Article 1. In the following rules, every steamship which is under sail and not under steam is to be considered a sailing ship, and every steamship which is under steam, whether under sail or not, is to be considered a ship under steam. Rules concerning lights. Article 2. The lights mentioned in the following articles, numbered 3, 4, 5, 6, 7, 8, 9, 10, and 11, and no others, shall be carried in all weathers from sunset to sunrise. Article 3. A sea-going steamship, when under way, shall carry a. on or in front of the foremast, at a height above the hull of not less than 20 feet, and if the breadth of the ship exceeds 20 feet, then at a height above the hull not less than such breadth, a bright white light so constructed as to show a uniform and unbroken light over an arc of the horizon of 20 points of the compass, so fixed as to throw the light 10 points on each side of the ship, namely, from right ahead to 2 points abaft the beam on either side, and of such a character as to be visible on a dark night with a clear atmosphere at a distance of at least 5 miles. B. On the starboard side, a green light, so constructed as to show a uniform and unbroken light over an arc of the horizon of 10 points of the compass, so fixed as to throw the light from right ahead to 2 points abaft the beam on the starboard side, and of such a character as to be visible on a dark night with a clear atmosphere at a distance of at least 2 miles. C. On the port side, a red light, so constructed as to show a uniform and unbroken light over an arc of the horizon of 10 points of the compass, so fixed as to throw the light from right ahead to 2 points abaft the beam on the port side, and of such a character as to be visible on a dark night with a clear atmosphere at a distance of at least 2 miles. D. The said green and red side lights shall be fitted with inboard screens projecting at least 3 feet forward from the light, so as to prevent these lights from being seen across the bow. Article 4. A steamship, when towing another ship, shall, in addition to her side lights, carry 2 bright white lights in a vertical line, one over the other, not less than 3 feet apart, so as to distinguish her from other steamships. Each of these lights shall be of the same construction and character, and shall be carried in the same position as the white light which other steamships are required to carry. Article 5. A. A ship, whether a steamship or a sailing ship, which from any accident is not under command, shall at night carry in the same position as the white light which steamships are required to carry, and if a steamship, in place of that light, 3 red lights in globular lanterns, each not less than 10 inches in diameter, in a vertical line, one over the other, not less than 3 feet apart, and of such a character as to be visible on a dark night with a clear atmosphere at a distance of at least 2 miles, and shall by day carry in a vertical line, one over the other, not less than 3 feet apart, in front of, but not lower than, her foremast head, 3 black balls or shapes, each 2 feet in diameter. B. A ship, whether a steamship or a sailing ship, employed in laying or picking up a telegraph cable, shall at night carry in the same position as the white light which steamships are required to carry, and, if a steamship, in place of that light, 3 lights in globular lanterns, each not less than 10 inches in diameter, in a vertical line, one over another, not less than 6 feet apart. The highest and lowest of these lights shall be red, and the middle light shall be white, and they shall be of such a character that the red lights shall be visible at the same distance as the white light. By day she shall carry in a vertical line, one over the other, not less than 6 feet apart, in front of, but not lower than, her foremast head, 3 shapes not less than 2 feet in diameter, of which the top and bottom shall be globular in shape and red in color, and the middle one diamond in shape and white. C. The ships referred to in this article, when not making any way through the water, shall not carry the side lights, but when making way shall carry them. D. The lights and shapes required to be shown by this article are to be taken by other ships as signals that the ship showing them is not under command, and cannot therefore get out of the way. The signals to be made by ships in distress and requiring assistance are contained in Article 27. Article 6. A sailing ship under way or being towed shall carry the same lights as are provided by Article 3 for a steamship under way, with the exception of the white light, which she shall never carry. Article 7. Whenever, as in the case of small vessels during bad weather, the green and red side lights cannot be fixed, these lights shall be kept on deck, on their respective sides of the vessel, ready for use, and shall, on the approach of or to other vessels, be exhibited on their respective sides in sufficient time to prevent a collision, in such a manner as to make them most visible, and so that the green lights shall not be seen on the port side, nor the red light on the starboard side. To make the use of these portable lights more certain and easy, the lanterns containing them shall each be painted outside with the color of the light they respectively contain, and shall be provided with proper screens. Article 8. A ship, whether a steamship or a sailing ship, when at anchor, shall carry, where it can best be seen, but at a height not exceeding 20 feet above the hull, a white light in a globular lantern of not less than 8 inches in diameter, and so constructed as to show a clear, uniform, and unbroken light, visible all around the horizon at a distance of at least 1 mile. Article 9. A pilot vessel, when engaged on her station on pilotage duty, shall not carry the lights required for other vessels, but shall carry a white light at the masthead, visible all around the horizon, and shall also exhibit a flare-up light or flare-up lights at short intervals, which shall never exceed 15 minutes. A pilot vessel, when not engaged on her station on pilotage duty, shall carry lights similar to those of other ships. Article 10. Open boats and fishing vessels of less than 20 tons net registered tonnage, when under way, and when not having their nets, trawls, dredges, or lines in the water, shall not be obliged to carry the colored side lights. But every such boat and vessel shall, in lieu thereof, have ready at hand a lantern with a green glass on the one side, and a red glass on the other side, and on approaching to, or being approached by another vessel, such lantern shall be exhibited in sufficient time to prevent collision, so that the green light shall not be seen on the port side, nor the red light on the starboard side. The following portion of this article applies only to fishing vessels and boats when in the sea off the coast of Europe, lying north of Cape Finisterre. A. All fishing vessels and fishing boats of 20 tons net registered tonnage or upward, when under way, and when not having their nets, trawls, dredges, or lines in the water, shall carry and show the same lights as other vessels under way. B. All vessels, when engaged in fishing with drift nets, shall exhibit 2 white lights from any part of the vessel where they can best be seen. Such lights shall be placed so that the vertical distance between them shall be not less than 6 feet, and not more than 10 feet, and so that the horizontal distance between them, measured in a line with the keel of the vessel, shall be not less than 5 feet, and not more than 10 feet. The lower of these 2 lights shall be the more forward, and both of them shall be of such a character, and contained in lanterns of such construction, as to show all round the horizon on a dark night with a clear atmosphere, for a distance of not less than 3 miles. C. All vessels, when trawling, dredging, or fishing with any kind of drag nets, shall exhibit from some part of the vessel where they can be best seen 2 lights. One of these lights shall be red, and the other shall be white. The red light shall be above the white light, and shall be at a vertical distance from it of not less than 6 feet, and not more than 12 feet, and the horizontal distance between them, if any, shall not be more than 10 feet. These 2 lights shall be of such a character, and contained in lanterns of such construction, as to be visible all round the horizon on a dark night with a clear atmosphere, the white light to a distance of not less than 3 miles, and the red light of not less than 2 miles. D. A vessel employed in line fishing with her lines out shall carry the same lights as a vessel when engaged in fishing with drift nets. E. If a vessel, when fishing with a trawl, dredge, or any kind of drag net, becomes stationary in consequence of her gear getting fast to a rock or other obstruction, she shall show the light and make the fog signal for a vessel at anchor. F. Fishing vessels and open boats may at any time use a flare-up in addition to the lights which they are by this article required to carry and show. All flare-up lights exhibited by a vessel when trawling, dredging, or fishing with any kind of drag net shall be shown at the after part of the vessel, excepting that if the vessel is hanging by the stern to her trawl, dredge, or drag net, they shall be exhibited from the bow. G. Every fishing vessel and every open boat, when at anchor between sunset and sunrise, shall exhibit a white light, visible all round the horizon at a distance of at least 1 mile. H. In a fog, a drift net vessel attached to her nets, and a vessel when trawling, dredging, or fishing with any kind of drag net, and a vessel employed in line fishing with her lines out, shall, at intervals of not more than 2 minutes, make a blast with her foghorn and ring her bell alternately. Article 11. A ship which is being overtaken by another shall show from her stern to such last-mentioned ship a white light or a flare-up light. Sound signals for fog and so forth. Article 12. A steamship shall be provided with a steam whistle or other efficient steam sound signals, so placed that the sound may not be intercepted by any obstructions, and with an efficient fog horn to be sounded by a bellows or other mechanical means, and also with an efficient bell. In all cases where the regulations require a bell to be used, a drum will be substituted on board Turkish vessels. A sailing ship shall be provided with a similar fog horn and bell. In fog, mist, or falling snow, whether by day or night, the signals described in this article shall be used as follows. That is to say, A. A steamship under way shall make with her steam whistle or other steam sound signal at intervals of not more than 2 minutes a prolonged blast. B. A sailing ship under way shall make with her foghorn at intervals of not more than 2 minutes, when on the starboard tack, 1 blast, when on the port tack, 2 blasts in succession, and when with the wind abaft the beam, 3 blasts in succession. C. A steamship and a sailing ship, when not under way, shall at intervals of not more than 2 minutes ring the bell. Speed of ships to be moderate in fog and so forth. Article 13. Every ship, whether a sailing ship or a steamship, shall in a fog, mist, or falling snow go at moderate speed. Steering and sailing rules. Article 14. When 2 sailing ships are approaching one another so as to involve risk of collision, one of them shall keep out of the way of the other as follows, namely, A. A ship which is running free shall keep out of the way of a ship which is close hauled. B. A ship which is close hauled on the port tack shall keep out of the way of a ship which is close hauled on the starboard tack. C. When both are running free, with the wind on different sides, the ship which has the wind on the port side shall keep out of the way of the other. D. When both are running free, with the wind on the same side, the ship which is to windward shall keep out of the way of the ship which is to leeward. E. A ship which has the wind aft shall keep out of the way of the other ship. Article 15. If two ships under steam are meeting end on or nearly end on, so as to involve risk of collision, each shall alter her course to starboard, so that each may pass on the port side of the other. This article only applies to cases where ships are meeting end on or nearly end on, in such a manner as to involve risk of collision, and does not apply to two ships which must, if both keep on their respective courses, pass clear of each other. The only cases to which it does apply are when each of the two ships is end on or nearly end on to the other. In other words, to cases in which by day each ship sees the masts of the other in a line or nearly in a line with her own, and by night to cases in which each ship is in such a position as to see both the side lights of the other. It does not apply by day to cases in which a ship sees another ahead crossing her own course, or by night to cases where the red light of one ship is opposed to the red light of the other, or where the green light of one ship is opposed to the green light of the other, or where a red light without a green light, or a green light without a red light is seen ahead, or where both green and red lights are seen anywhere but ahead. Article 16. If two ships under steam are crossing so as to involve risk of collision, the ship which has the other on her own starboard side shall keep out of the way of the other. Article 17. If two ships, one of which is a sailing ship and the other a steamship, are proceeding in such directions as to involve risk of collision, the steamship shall keep out of the way of the sailing ship. Article 18. Every steamship, when approaching another ship so as to involve risk of collision, shall slacken her speed or stop and reverse if necessary. Article 19. In taking any course authorized or required by these regulations, a steamship under way may indicate that course to any other ship which she has in sight by the following signals on her steam whistle, namely: 1 short blast to mean I am directing my course to starboard. 2 short blasts to mean I am directing my course to port. 3 short blasts to mean I am going full speed astern. The use of these signals is optional, but if they are used, the course of the ship must be in accordance with the signal made. Article 20. Notwithstanding anything contained in any preceding article, every ship, whether a sailing ship or a steamship, overtaking any other, shall keep out of the way of the overtaken ship. Article 21. In narrow channels, every steamship shall, when it is safe and practicable, keep to that side of the fairway or mid-channel which lies on the starboard side of such ship. Article 22. Where by the above rules one of two ships are to keep out of the way, the other shall keep her course. Article 23. In obeying and construing these rules, due regard shall be had to all dangers of navigation, and to any special circumstances which may render a departure from the above rules necessary in order to avoid immediate danger. No ship, under any circumstances, to neglect proper precautions. Article 24. Nothing in these rules shall exonerate any ship, or the owner or master or crew thereof, from the consequences of any neglect to carry lights or signals, or of any neglect to keep a proper lookout, or of the neglect of any precaution which may be required by the ordinary practice of seamen, or by the special circumstances of the case. Reservation of rules for harbor and inland navigation. Article 25. Nothing in these rules shall interfere with the operation of a special rule duly made by local authority relative to the navigation of any harbor, river, or inland navigation. Special lights for squadrons and convoys. Article 26. Nothing in these rules shall interfere with the operation of any special rules made by the government of any nation with respect to additional station and signal lights for 2 or more ships of war, or for ships sailing under convoy. Article 27. When a ship is in distress and requires assistance from other ships or from the shore, the following shall be the signals to be used and displayed by her, either together or separately, that is to say, in the daytime, first, a gun fired at intervals of about 1 minute. Second, the International Code Signal of Distress indicated by NC. Third, the distant signal consisting of a square flag having either above or below it a ball or anything resembling a ball. At night, first, a gun fired at intervals of about a minute. Second, flames on the ship, as from a burning tar barrel, oil barrel, and so forth. Third, rockets or shells throwing stars of any color or description, fired one at a time at short intervals. Section 2. That all laws and parts of laws inconsistent with the foregoing revised international rules and regulations for the navigation of all public and private vessels of the United States upon the high seas and in all coast waters of the United States are hereby repealed, except as to the navigation of such vessels within the harbors, lakes, and inland waters of the United States, and that this act shall take effect and be in force from and after the 1st day of September, Anno Domini 1884. Approved March 3rd, 1885. Rules and regulations for the government of pilots of steamers navigating harbors, rivers, and inland waters, except the Great Lakes, the Red River of the North, and rivers emptying into the Gulf of Mexico and their tributaries, when meeting or approaching each other, whether by day or night, and as soon as fully within sound of the steam whistle. Adopted by the Board of Supervising Inspectors, June 1871, amended January 1875, January 1881, 1882, 1893, and 1895. Rule 1. When steamers are approaching each other head and head, or nearly so, it shall be the duty of each steamer to pass to the right or port side of the other, and the pilot of either steamer may be first in determining to pursue this course, and thereupon shall give, as a signal of his intention, one short and distinct blast of his steam whistle, which the pilot of the other steamer shall answer promptly by a similar blast of his steam whistle, and thereupon such steamers shall pass to the right or port side of each other. But if the course of such steamers is so far on the starboard of each other as not to be considered by pilots as meeting head to head, or nearly so, the pilots so first deciding shall immediately give 2 short and distinct blasts of his steam whistle, which the pilot of the other steamer shall answer promptly by 2 similar blasts of his steam whistle, and they shall pass to the left or on the starboard side of each other. In the night, steamers will be considered as meeting head and head, so long as both the colored lights of each are in view of the other. Rule 2. When steamers are approaching each other in an oblique direction, as shown in diagram of the 4th situation, they shall pass to the right of each other, as if meeting head and head, or nearly so, and the signals by whistle shall be given and answered promptly as in that case specified. Rule 3. If, when steamers are approaching each other, the pilot of either vessel fails to understand the course or intention of the other, whether from signals being given or answered erroneously, or from other causes, the pilot so in doubt shall immediately signify the same by giving several short and rapid blasts of the steam whistle, and if the vessels shall have approached within half a mile of each other, both shall be immediately slowed to a speed barely sufficient for steerage way, until the proper signals are given, answered, and understood, or until the vessels shall have passed each other. Vessels approaching each other from opposite directions are forbidden to use what has become technically known among pilots as cross signals, that is, answering one whistle with 2, and answering 2 whistles with 1. In all cases, and under all circumstances, a pilot receiving either of the whistle signals provided in the rules, which for any reason he deems injudicious to comply with, instead of answering it with a cross signal, must at once observe the provisions of this rule. Rule 4. When steamers are running in a fog or thick weather, it shall be the duty of the pilot to cause a long blast of the steam whistle to be sounded at intervals not exceeding 1 minute. Steamers, when drifting or at anchor in the fairway of other vessels in a fog or thick weather, shall ring their bells at intervals of not more than 2 minutes. Rule 5. Whenever a steamer is nearing a short bend or curve in the channel, where, from the height of the banks or other cause, a steamer approaching from the opposite direction cannot be seen for a distance of half a mile, the pilot of such steamer, when he shall have arrived within half a mile of such a curve or bend, shall give a signal by one long blast of the steam whistle, which signal shall be answered by a similar blast, given by the pilot of any approaching steamer that may be within hearing. Should such signal be so answered by a steamer upon the farther side of such bend, then the usual signals for meeting and passing shall immediately be given and answered. But if the first alarm signal of such pilot be not answered, he is to consider the channel clear and govern himself accordingly. When boats are moved from their docks or berths, and other boats are liable to pass from any direction toward them, they shall give the same signal as in the case of boats meeting at a bend, but immediately after clearing their berths, so as to be fully in sight, they shall be governed by Rule 1. Rule 6. The signals by the blowing of the steam whistle shall be given and answered by pilots in compliance with these rules, not only when meeting head and head or nearly so, but at all times when passing or meeting at a distance within half a mile of each other, and whether passing to starboard or port. Rule 7. When two steamers are approaching the narrows known as Hell Gate on the East River at New York, side by side or nearly so, running in the same direction, the steamer on the right or starboard hand of the other, when approaching from the west, when they shall have arrived abreast of the north end of Blackwell's Island, shall have the right of way, and the steamer on the left or port side shall check her way and drop astern. In like case, when two steamers are approaching from the east and are abreast of Negro Point, the steamer on the right or starboard hand of the other shall have the right of way, and shall proceed on her course without interference, and the steamer on the port side of the other shall keep at a safe distance astern, not less than 3 lengths, until both steamers have passed through the difficult channel. Rule 8. When steamers are running in the same direction, and the pilot of a steamer which is astern shall desire to pass on the right or starboard hand of the steamer ahead, he shall give one short blast of the steam whistle as a signal of such desire and intention, and shall put his helm to port. Or if he shall desire to pass on the left or port side of the steamer ahead, he shall give 2 short blasts of the steam whistle as a signal of such desire and intention, and shall put his helm to starboard, and the pilot of the steamer ahead shall answer by the same signals. Or, if he does not think it safe for the steamer astern to attempt to pass at that point, he shall immediately signify the same by giving several short and rapid blasts of the steam whistle, and under no circumstances shall the steamer astern attempt to pass the steamer ahead, until such time as they have reached a point where it can be safely done, when said steamer ahead shall signify her willingness by blowing the proper signals. The boat ahead shall in no case attempt to cross the bow or crowd upon the course of the passing steamer. Every vessel coming up with another vessel from any direction more than 2 points abaft her beam, that is, in such a position with reference to the vessel which she is overtaking, that at night she would be unable to see either of that vessel's side lights, shall be deemed to be an overtaking vessel, and no subsequent alteration of the bearing between the two vessels shall make the overtaking vessel a crossing vessel within the meaning of these rules, or relieve her of the duty of keeping clear of the overtaken vessel until she is finally passed and clear. Rule 9. All double-ended ferry boats on lakes and seaboard shall carry a central range of clear, bright white lights showing all around the horizon, placed at equal altitudes forward and aft, also such side lights as specified in Section 4233, Revised Statutes, Rule 3, paragraphs B and C. Local inspectors in districts having ferry boats shall, whenever the safety of navigation may require, designate for each line of such boats a certain light, white or colored, which shall show all around the horizon, to designate and distinguish such lines from each other, which light shall be carried on a flagstaff amidship 15 feet above the white range lights. The line dividing jurisdiction between pilot rules on western rivers and harbors, rivers and inland waters at New Orleans shall be the lower limits of that city. Lights for barges and canal boats in tow of steam vessels. Rule 10. On the inland rivers, bays, sounds, and harbors of the United States, except on the waters of the Hudson River and its tributaries from Troy to Sandy Hook, the waters of the East River and Long Island Sound, and the waters entering thereon and to the Atlantic Ocean, to and including Narragansett Bay, Rhode Island, and tributaries, and Lake Champlain, barges and canal boats towing astern of steam vessels, when towing singly, or what is known as tandem towing, shall each carry a green light on the starboard side and a red light on the port side. When 2 or more boats are abreast, the colored lights shall be carried at the outer sides of the bows of the outside boats. Barges or canal boats, towing alongside a steam vessel, shall, if the deck houses or cargo of the barge or canal boat be so high above water as to obscure the side lights of the towing steamer when being towed on the starboard side of the steamer, carry a green light upon the starboard side, and when towed on the port side of the steamer, a red light on the port side of the barge or canal boat. And if there is more than one barge or canal boat abreast, the colored lights shall be displayed from the outer side of the outside barges or canal boats. Barges and canal boats, when being towed by steam vessels on the waters of the Hudson River and its tributaries from Troy to Sandy Hook, the East River and Long Island Sound, and the waters entering thereon, and to the Atlantic Ocean, to and including Narragansett Bay, Rhode Island, and tributaries, and Lake Champlain, shall carry lights as follows. Barges and canal boats being towed astern of steam vessels, when towing singly, or what is known as tandem towing, shall each carry a white light on the bow and a white light on the stern. Barges and canal boats, when towed at a hawser, 2 or more abreast, when in one tier, shall carry a white light on the bow and a white light on the stern of each of the outside boats. When in more than one tier, each of the outside boats shall carry a white light on its bow, and the outside boats in the last tier shall each carry, in addition, a white light on the outer after part of the stern. Barges or canal boats towed alongside a steam vessel, if on the starboard side of said steam vessel, shall display a white light on her own starboard bow, and if on the port side of said steam vessel, shall display a white light on her own port bow, and if there is more than one barge or canal boat alongside, the white lights shall be displayed from the outboard side of the outside barge or canal boat. When barges or canal boats are massed in tiers and towed at a hawser, as is usual on the Hudson River, there shall be carried on the forward port side of the port boat of each tier a white light, and on the forward starboard side of the starboard boat in each tier a white light, and on the after port side of the port boat in the stern tier a white light, and on the after starboard side of the starboard boat in the stern tier a white light. The white lights for barges and canal boats referred to in the preceding rules shall be carried at least 10 feet and not more than 30 feet abaft the stem or extreme forward end of the vessel, above the deck rail of the vessel on single-decked vessels, and on the upper deck of double or three-decked barges or canal boats, and shall be of such a character as to be visible on a dark night with a clear atmosphere, at a distance of at least 5 miles. The colored side lights referred to in the foregoing rules must be fitted with inboard screens so as to prevent them from being seen across the bow, and of such a character as to be visible on a dark night with a clear atmosphere at a distance of at least 2 miles, and so constructed as to show a uniform and unbroken light over an arc of the horizon of 10 points of the compass, and so fixed as to throw the light from right ahead to 2 points abaft the beam on either side. The minimum size of glass globes used shall not be less than 6 inches in diameter and 5 1/2 inches high in the clear. Any barge or canal boat in tow of a steam vessel, when the last boat of a tow, and not required by these rules to carry a light on the stern, except upon rivers whose waters flow into the Gulf of Mexico, on being overtaken by another vessel, shall show from her stern to such last-mentioned vessel a flare-up light, or, in lieu thereof, a white light fixed and carried in a lantern, which shall be so constructed, fitted, and screened that it shall throw an unbroken light over an arc of the horizon of 12 points of the compass, namely, for 6 points from right aft on each side of the vessel, so as to be visible at a distance of at least 1 mile. These rules for lights on barges and canal boats shall take effect at sundown, May 1st, 1894, and the lights provided therein shall thereafter be carried from sunset to sunrise at all times when being navigated, provided that nothing in these rules shall be construed as compelling barges or canal boats in tow of steam vessels passing through any waters en route or directly to or from a port where lights for barges or canal boats are different from those of the waters whereon such vessels are usually employed, to change their lights from those required on the waters from which their trip begins or terminates. But should such vessels engage in local employment on waters requiring different lights from those where they are customarily employed, they shall comply with the local rules where employed. Decision of the Secretary of the Treasury, number 3838, dated January 8th, 1879. Note: this refers to Rule 7 on page 8. End note. When towing, the law will be complied with by having an additional light aft 2 or 3 feet below the proper after light, also showing around the horizon, and from a flagstaff of sufficient height put anywhere abaft the pilot house. Lights so displayed on towing vessels without masts are considered the equivalents of the 2 masthead lights required by Rule 4, Section 4233, Revised Statutes. End of Rules of the Road at Sea by the U.S. Coast and Geodetic Survey. Recording by Maria Kasper.
Selected Patterns from The Art of Bobbin Lace by Louisa and Rosa Tebbs. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Devorah Allen. Genoese Lace Edge. We will begin with the simplest of all bobbin laces, namely Genoese. And as the style of this lace does not offer much scope and variety of design, we will, after mastering this effective and useful little pattern, pass on to the more elaborate varieties. You will require 6 pairs of bobbins for this design, filled with number 1 thread, and tied together in pairs as described on page 7, and a packet of medium lace pins. Stick 3 pins in the dots indicated in the pattern. Hang 2 pairs of bobbins on the right-hand pin, and make a cloth stitch, which is done as follows with 4 bobbins. For greater clearness, we will number these bobbins 1, 2, 3, 4, counting from the right. Cross number 3 bobbin over number 2, number 1 over number 2, number 3 over number 4, and number 3 over number 2, assuming, of course, that the bobbins change their number as they move, that is, the pair nearest the right hand being always number 1, and so on. After this stitch is worked, leave the right-hand pair of bobbins, hang a new pair on the next pin, and work a cloth stitch with the left-hand pair and the new pair, and so on until the whole 6 pairs are worked, 2 pairs on each pin. Now make a picot as follows. Twist the outer pair of bobbins 3 times to the left. Put a pin under this thread, giving the pin an extra twist round the thread before pinning down. Make a cloth stitch with the 2 outside pairs, repeating the 4 movements exactly the same as before. Now twist each of these 2 pairs twice to the left. Asterisk. Leave the outside or left-hand pair, and work a cloth stitch with the inner pair and the next, and so on, until all except the last pair are worked. And before making this stitch, twist each of the 2 last pairs twice to the left. Stick a pin in front of both pairs of bobbins, making a cloth stitch at the back of the pin. Twist both pairs twice again, leave the outer or right-hand pair, and work across with the inner pair as before, until all except the last stitch is worked. See that both pairs are twisted twice before working this stitch. Then twist the outer pair only 3 times for the picot. Pin down as before, make a second cloth stitch, and twist each pair twice again to the left, and repeat from asterisk, and so on until you arrive at the first strand A, which you must throw out as follows, remembering that the picots only occur on the outline of the lace, and that the braid is worked both edges alike in the parts where the picots cease. After completing the row at point A, stick a pin in the opposite end of the strand B. Twist your outer pair of bobbins nearest the strand 8 times, hang this twisted thread round the pin and back again, making a cloth stitch with this pair and the next. Stick another pin in between these 2 pairs of bobbins, and work another cloth stitch round the pin. Twist each pair twice to the left and proceed as before, throwing out strand C in the same manner. These strands must be taken up into the lace at the other side. To do this, when you arrive at the pin on which the strand was made, take out the pin and insert a crochet hook through the strand. Pull the thread of the nearest bobbin through this strand until a large loop is formed, and pass the second bobbin through this loop. Pull tight, make a cloth stitch, put the pin back again, make another cloth stitch round the pin, twist each pair of bobbins twice, and proceed with the ordinary braid as before, connecting every row now on this side of the braid, which comes close to that already worked, by taking out the pin and drawing the thread of your nearest bobbin through the edge of the braid as for the strand. Note, the pins should be placed quite close together on the inner side of all curves, and the outer pins regulated to come as nearly opposite the inner pins as possible. When you have worked the length of your pattern, or as far as you conveniently can, on your cushion, leave all your working bobbins, taking the precaution to keep these in place by stretching a wide piece of elastic tightly over the bobbins, securing it to the cushion with large pins, and put in your fillings and strands with 4 separate bobbins tied together in pairs as previously described, and work as follows. Take out the pin at 1, insert a crochet hook where the pin has been, and draw the thread of 1 pair of bobbins through the edge of the braid into a large loop. Put one of the bobbins through this loop and pull tight. Insert another pair in the same place in the same manner, and work plait stitch, which is done as follows. Cross number 3 bobbin over number 2, 1 over 2, 3 over 4, 3 over 2, 1 over 2, 3 over 4, and so on, until you arrive at 2, where you take out the nearest pin and connect to the lace as described before. Continue the plait stitch to 3. Connect again to the lace and work across to 4, then to 5 and 6, 7 and 8. When you arrive at 8, Tie each pair of bobbins together in 4 tight knots, reversing the tie each time, and cut off close. The strands in space M are worked in the same way. The little picots that occur at intervals in all the plate stitch strands being formed by simply twisting a pin round the thread of the nearest bobbin and pinning it down whenever you arrive at a dot which indicates a picot. The spider webs that connect the bows together are also worked with 2 pairs of bobbins, each pair after being connected to the lace. 1 pair at J and a pair at K are twisted until they reach the middle, then hung over 2 pins, 1 at each corner of the little square. 3 bobbins are held in the left hand, the 4th bobbin being used as a shuttle weaving over and under the other threads until a square center is formed. A pin is stuck in each of the lower corners, and a pair of bobbins hung over each pin. The threads are then twisted up to the opposite side of the lace H and I, where they are connected, tied together, and cut off. Although, when once the knack is acquired, these effective little spider webs are very quickly and easily made, it requires a certain amount of practice to obtain this knack, and beginners must not be discouraged if at first they cannot get them perfect. The next step after completing the fillings and strands is to take out all the pins from the lace and remove it from the pattern, fitting the part you are working carefully on the beginning of the pattern at the top of the cushion. Secure with a few pins, straighten out your working bobbins, which will have become a little entangled in the process, and proceed. Doily in Point de Flandre. We will now attempt the next easiest branch of bobbin lace, commonly known as Point de Flandre. This fascinating lace is comparatively very easy of execution, and admits of much more variety of design. We should suggest the doily on page 21 for the first attempt, then the collar on page 28, or the lace edge on page 32, and lastly the more elaborate motifs on page 36. Have ready 8 pairs of bobbins filled with number 2 thread, each pair tied together and wound up to within 3 inches apart, as described on page 7. You will also require 1 bobbin filled with Bruges cord, the cord outline being one of the characteristics of this lace, and a packet of medium lace pins. To begin, stick 3 pins in the ring of one of the flowers as indicated by the black dots, and hang on 8 pairs of bobbins, 1 pair only at a time. Work cloth stitch right across, commencing from the inner side of the ring. Stick a pin on the outer edge of the ring in front of the 2 last pairs just worked. Twist each pair twice to the left. Now make a knot in your outline cord and pin it down about 1 inch away. Pass this cord through the second or inner pair of bobbins, over 1 bobbin, under the next, and leave it between this and the outside pair. Now work cloth stitch across with this same pair of bobbins until all except the last pair are worked. Twist this pair twice, also the working pair twice to the left. Stick a pin in front of these 4 bobbins, and make a cloth stitch at the back of the pin, which will now be on the inner side of the ring. Twist each pair twice again, and return with the inner pair, working cloth stitch right across, until you arrive at the cord. Pass this through your working pair, twist this pair twice, stick a pin in front, and make a cloth stitch with this and the outside pair at the back of the pin. Twist both pairs twice, work across with the inner pair the same as last row, repeating the directions given row for row. To connect the ring together at the finish, take out the inner starting pin, insert a fine crochet hook, and draw the thread of the nearest bobbin through the opening. Put the next bobbin right through the loop just formed and pull tight. work to the middle of ring and repeat. Also at the outer edge, so that the ring is connected together in all 3 places. Now work half stitch right across the petal. To do this, first cross every pair of bobbins once to the left. This being done, take up the first 2 pairs and cross the 2 inner bobbins once to the right. Cross each of these 2 pairs once to the left again. Drop the outer pair, take up the next pair, and repeat from *. Work all except the last pair, and before doing this, cross the working pair once to the left. Pass the cord through these crossed threads. Now stick a pin at the top of the petal, and with the 2 outer pairs of bobbins, work a cloth stitch round this pin, leave the outer pair, pass the cord through the inner pair, and work back in half stitch. Connect when you arrive at the ring of the flower. Make a cloth stitch after the connection to hold it firm, and then work half stitch across until all except the last pair is worked. Pass the cord through the last pair but one, previously crossed to the left. Twist both these outside pairs twice at the back of the pin. Stick a pin in front of these bobbins and make a cloth stitch. Twist each pair twice again, drop the outer pair, pass the cord through the inner pair, and work half stitch right across, including the last pair, remembering to connect again to the ring. Make a cloth stitch, and repeat these last 2 rows until all the 6 petals are worked, threading the cord down to the ring and back again at the division of each. These petals are connected together at the finish the same as the ring, working this last row in cloth stitch to hold the connections firm. The stalk of the leaves is worked exactly the same as the circle of the flower. The leaves are also worked in cloth stitch with the same open edge and cord all round the outside of the leaf. But to form the vein, work across to the dots up the middle of the leaf, with plain cloth stitch up to the very last pair. After this pair is worked, stick a pin in the vein. Take the outer pair of bobbins round this pin and twist this pair only twice before working back. This is done every row until the top of the vein is reached. Then work round the other side of the leaf, connecting the vein in the middle as follows. After the top of the vein is reached, continue to work the same stitch round the tip of the leaf, but without any pins or twistings on the inner side until you arrive opposite the top pin in the vein. Take this pin out and connect with the crochet hooks as described in the flower, remembering now to twist the outer pair of bobbins once before and once after these connections, to match the double twistings on the opposite side. Work round the second and third sections of the leaf in the same manner, when the bobbins must be fastened off. To do this, take the whole of the bobbins in the left hand except one. With this one bobbin, tie the others together in a tight buttonhole stitch. About 6 of these stitches are sufficient to make the fastening very secure. Now cut off the bobbins quite close and wind up in pairs as previously described. If the little extra precaution is taken at the finish of sewing these fastenings neatly down on the wrong side, the lace will never give way in cleaning, as is so often the case. For the small half-stitch circles round the doily, 2 cords are used, 1 on each side. The bobbins containing these cords are tied together and wound up like the others. And when commencing these circles, the pair of cord bobbins should be hung round the commencing pins after the others have all been worked on. These circles are worked in half stitch with the usual open edge, but at each division the cords are crossed as follows. After putting in your pin at this point, and twice twisting the 2 outer pairs of bobbins, before passing your cord through the inner pair as usual, thread this cord over and under all the other bobbins until it reaches the opposite cord, Leave it, and bring this opposite cord back in the same manner. Now pass it through the pair of bobbins you were about to work with and proceed as usual. After connecting the circles together at the finish, the bobbins must be fastened off and cut close as for the leaf, then wound up in pairs, ready for the inner circle of braid round the doily. This is worked exactly the same as the ring in the flower, using one cord only on the outer edge of the braid. Remember in working this lace to connect all parts of the design that come close to each other by simply inserting the crochet hook and drawing the nearest working bobbin through as described before. Collar in Point de Flandre. This pretty little collar might be attempted first instead of the doily if preferred. Work the flowers, leaves, etc. the same as the doily, also the connecting strands and the small woven spider webs in the center of the flowers. For the large spider webs, however, that connect the flowers and leaves, you will require 6 pairs of bobbins, 2 pairs for each of the 3 strands at the top of the web. Work these 3 strands as usual in plait stitch, with a picot in the middle of each. When the 3rd strand is finished, stick a pin at the corner of the solid square nearest this strand, and work a cloth stitch round the pin. Drop the outer pair of bobbins, and work another cloth stitch, taking up the nearest pair of bobbins from the next strand. Repeat with the next pair, and so on, until you have worked a row of cloth stitches right across. Stick a pin in the opposite corner to the first pin, and work a cloth stitch round this pin. Work cloth stitch across, repeat for about 6 rows, or until the little square is large enough. Then work the 2 outer pairs each side in plait stitch, and also the 2 middle pairs until they reach their destination, where connect, tie firmly together, and cut off close. Appliqué trimming in Flanders point. This handsome lace, 5 inches deep, is suitable for a great many purposes, and can be worked in fine or coarse thread accordingly. The specimen illustrated is worked in No. 2 thread. Commence with the flower nearest the long curved stem, arranging that you finish with the petal nearest to the stem. Continue to work the stem without cutting off the bobbins, but fasten on an extra cord here, as the stem is worked with a cord each side. This extra cord must be cut off on arriving at the leaf, which is also continued out of the stem with the same bobbins. But you will find it necessary to put on 2 extra pairs of bobbins for the leaf. To do this, work a few rows until you come to where the leaf slightly widens, and hang an extra pair of bobbins on the outer pin of the last row, before passing your cord. Make a cloth stitch with this new pair and the working pair. Pass the cord, twist twice, pin as usual, and the next time you arrive at this outer edge of the leaf, hang on another pair in the same manner, taking care to now lift the previous pair off the pin and pull up tight. The working of the pretty réseau filling in the circles formed by the stem is described on page 53. Motifs in Point de Flandre. Lover's knot, butterfly, fan, and conventional rose. These dainty little motifs form pretty ornaments for hats, blouses, etc., or, set quite close together, they make a handsome border for collars and various articles arranged as fancy dictates. To work the lover's knot, follow the direction given in the Italian insertion, except that 2 cords are used, 1 each side. Begin at the extreme point and work all the whole bow in one piece. Fasten off neatly and cut close. Tie the bobbins in pairs again, and work the little center in half stitch. For the butterfly, Work the body first, commencing where it joins the top wing. Work all round this, and continue the upper wings without leaving off. First one wing, then the other. Now continue the lower wing, which is worked 1/2 in cloth stitch, with a vein up the middle, as the leaf described in the doily, and the opposite side in half stitch, connecting each row to the vein as you proceed. For the fan motif, work the flower first, finishing at the petal nearest the braid on the left hand, and continue to work this braid all round, continuing the little open space between the fan and the ribbon, by wrapping all the other bobbins with the 2 outside bobbins, tying them tight, and connecting this tying pair to the edge of the flower. Repeat this 3 times, straighten out the bobbins, and proceed to work the ribbon. The flower motif should be commenced on the inside ring close to the stem. Work this and join together, continue round the whole of the 7 petals, working the 3 middle petals in half stitch. Also down the stem, then wrap and tie your bobbins together, connecting each tie until you reach the small scroll on the left-hand side of the stem. Continue to work this scroll, and when finished, fasten the bobbins off neatly, cut close, tie up in pairs, connect each pair to the stem, and work the little scroll opposite. After this second scroll is worked, the bobbins must be again cut off and tied up in pairs, ready for the leaf. The open petals of the flower are filled in with the little woven spider webs, and the middle of the ring with plaited filling. Full directions for working the rose, filling in the lover's knot, butterfly, and fan motifs, also an illustrated diagram showing all working details, will be found on pages 57 and 60. Guipure de Flandre. We come now to one of the handsomest guipure laces in existence, Guipure de Flandre, a lace that is comparatively very little known or taught in England, although at the same time one of the most fascinating laces to manufacture, on account of the variety of beautiful stitches or fillings introduced in this lace. The rich, heavy cord outline in this Guipure de Flandre differs also from the dentelle de Bruges in the respect that it appears on the right side of the lace only, and has therefore a different movement. As the little lace vest offers such opportunity for learning a great variety of fillings, and makes such a wonderful piece of adornment, I should suggest starting on this. By the way, the little collar band is worked on a separate pattern and attached to the vest later. Have ready 6 pairs of bobbins filled with number 3 thread, and 1 bobbin with guipure cord, also a packet of fine lace pins. Work the narrow braid first all round the vest, commencing at the top on 2 pins. Work the ordinary braid, with the straight open edge on the inside, and open edge with picots on the outer side, using the guipure cord as follows. Thread the cord through the other bobbins into position, and on working from right to left, pass this cord through the last pair of bobbins but 1, exactly the same as in the dentelle de Bruges, but on the return row, that is, from left to right, simply work over the cord instead of passing it through the bobbins as usual. Repeat this all through. You will notice that 2 cords are used on all the scrolls, 1 each side, and 1 cord for the flowers and leaves, the flowers being worked exactly the same as in the dentelle de Bruges, except that every alternate petal is half stitch. The cord is carried down to the ring of the flower and back again, at the division of each petal, in the same manner as in the dentelle de Bruges. The large leaves are also worked exactly the same, whilst the smaller leaves are worked in plain cloth stitch, like the braid, with the open edge each side, but no vein down the middle. 8 pairs of bobbins are required for the larger flowers and leaves, 6 pairs being sufficient for the smaller flowers and leaves, whilst 10 pairs are necessary for the large scrolls, besides the 2 cords. The fillings are put in separately at the finish, and comprise ressaut, festoon, spider, honeycomb, and plait stitches. Note: a certain amount of skill is necessary to keep the form of the design in making lace, and particularly is this noticeable round the curves of the scrolls. Commence these on 3 pins, placing the first pin at the bend on the inner line where the scroll curves completely round. Place the next pin in the center of this little round curve, and the last pin between the 2 other pins. Hang on your bobbins, a pair at a time, and work cloth stitch right across, commencing at the inner pin. Thread the cord, tied together on a pair of bobbins, through the other bobbins over one and under another, leaving it hanging each side in between the 2 last pairs, and work across every row to the middle of the scroll, using 1 cord only on the outer open edge of braid where the pins are placed, and working plain cloth stitch on the inside, without any open edge or pins. Continue this all round. When you reach the top, however, you should begin to connect the 2 inner sides together. Continue to do this every row until you get quite round the curve and arrive opposite to the first pin. Then take in the other cord, and work open edge each side for the straight portion of the scroll. And if it finishes in another round curve, as is often the case, then work this curve also in a circle as at the commencement. Yoke in Guipure de Flandre. This handsome yoke is worked in similar style to the vest, and the detailed instructions given for the latter will apply to this yoke in the main. Perhaps it would be as well to explain, however, that the large ornamental leaves at the outside points of the design are worked in 3 sections, the middle or inner section being worked as an ordinary Bruges leaf, in cloth stitch with 7 pairs of bobbins and 1 guipure cord, throwing out the vein of the leaf over a pin each time, as previously described. The extreme outer section is next worked, adding an extra pair of bobbins, as also an extra cord, the space between these 2 sections being filled in last with half stitch, connecting every row, on each side, to the parts already worked. The same braid border is worked round the smaller leaves, whilst the handsome double ressaut filling is described on page 60. The medallions are also worked in 3 sections, the inner and outer braid being worked first, and the middle space last. This is done in half stitch, connecting each row to this worked braid as previously described. The little circles round the neck of the yoke are worked in cloth stitch with 2 cords, 1 each side, crossing these cords as described on page 25 at the division of each circle. The ornamental line underneath the circles is worked in stem stitch, with 5 pairs of bobbins and 1 cord bobbin as follows. Work the cord on the outer edge of the stem, where also place the pins, making the usual open edge on this side by twice twisting the 2 outer pairs of bobbins before and after your last stitch. But on the inner side of the stem, no pins are used, and the twists must be omitted. Bolero in Guipure de Flandre. This handsome bolero, which by the way is worked in No. 2 thread and a heavy guipure cord, needs, after the vest and yoke, very little explanation. The very effective diamond filling described on page 59 shows here to great advantage, and the réseau filling, page 53, is worked in the middle of the flowers. The round little open holes in the petals of some of the flowers, etc., are worked as described in the Flemish Van Dyck collar, page 134. This bolero is a remarkably pretty shape, forming a pointed collar at the back, and is very quickly worked. Ornamental lace stitches. Number 1. Réseau. This réseau stitch forms a handsome background to a great many different kinds of lace, and is worked as follows. Connect 1 pair of bobbins at A, number 1 diagram, and 2 pairs at B, C, D, E, and F, also 1 pair at G. Twist the A pair twice to the left, also the nearest B pair. Make a cloth stitch with these 2 pairs. Stick a pin on the cross between these bobbins, and make another cloth stitch round this pin, twisting each pair once to the left before making the stitch. Drop these 2 pairs and repeat with the next 2, namely, the unworked B pair and the nearest C pair. Continue until all the bobbins are worked. Connect at the end of the row, and return in the same manner, noting that if the space you are filling increases in width, an extra pair of bobbins must be added at the end of each row, whilst if it decreases, a pair must be cut off each time. This, of course, refers to all fillings. Number 2. Honeycomb. This very pretty filling is worked in plate stitch, described on page 17. Connect 2 pairs of bobbins at A, number 2 diagram. Plait to B on the top line, making a picot in the middle. Place a pin at B, and work a cloth stitch round it. Plait to C on the lower line, and repeat. Plait to point D, and back again to C. Work a second cloth stitch round the pin at C. Plait from C to E on the top line, then from E to F on the lower line. Now plait from F to G, and back again to F, working a second cloth stitch round the pin at F. Plait to H on the top line, and H to I on the lower line. Connect at point I to the lace, and return on the remaining lines back to A, drawing the pins out at all the lettered points on this return row as you arrive at them, namely H, F, E, C, and B, and connecting through the plait here with the working bobbins. Continue the plait to J, connect again here, and work this row exactly the same as the last. Number 3. Festoon. This stitch, though remarkably easy, is most graceful and effective, and is worked as follows. Connect 5 pairs of bobbins at A, and work cloth stitch across to the lower line of the scallop, twisting the 2 last pairs twice before making the last stitch. Add a picot by twisting the outer pair 3 times. Pin down. Make another cloth stitch. Twist each pair twice again, and return with plain cloth stitch to the top of the row, omitting the twists and not placing any pins here. Work back again to the outer edge of the scallop, where repeat the open edge and picot. Number 4. Spiderweb stitch. One of the most popular fillings is the spiderweb, partly from its adaptability to all sized spaces, and partly from its bold, distinctive appearance, which seems to supply a character and effect to all these laces. Connect 2 pairs of bobbins at A, same at B, C, D, E, and F. Plait A bobbins across to the corner of the nearest little square, and leave them, making a picot in the middle of the strand as you plait. Do the same with B, and leave them at the opposite corner of the same little square. To avoid the bobbins becoming entangled here, simply hang them over a pin at each corner. Repeat the directions just given with C and D bobbins for the next web, and E and F for the last web on this row. Now return to A and B bobbins. Remove the pins over which the bobbins are hanging, and work cloth stitch with all 4 pairs of bobbins from left to right. Stick the pin back in again in the right-hand corner. Work a cloth stitch round the pin and right across to the left-hand corner. Place another pin here and repeat. Continue to work cloth stitch, placing pins at the end of each row as closely together as possible until the whole square is worked. Plait the strands across to the lower row and leave them hanging whilst you work C and D, also E and F. On the next row, you will require 2 more pairs of bobbins connecting on at the first web to work with A bobbins. B and C will work together in this row as D and E, whilst F will be connected to the lace and brought down at the back of the lace for the 3rd row. Number 5. Lead filling. The next is the famous Honiton lead filling, one of the most difficult, but at the same time one of the richest stitches in lace making, and the result is certainly well worth the time spent in acquiring the necessary knack and skill to accomplish this stitch successfully. Commence at the top of the space with 2 pairs of bobbins at A. Twist each pair twice to the left, and weave with the outer right-hand bobbin over and under the other 3 bobbins until you nearly reach the cross. Now drop these bobbins. Hang 2 pairs on at B and weave as with A bobbins until you arrive at the same cross. Now take the nearest pairs of A and B bobbins, twist each pair of bobbins twice to the left, work a cloth stitch, place a pin in the upper dot, and work another cloth stitch round the pin. Twist both pairs of bobbins twice. Work a cloth stitch, place a pin in the right-hand dot, and work another cloth stitch round this pin. Now do the same with A bobbins, placing the pin in the left-hand dot. And lastly, twist the 2 nearest pairs of A and B, and work a cloth stitch round a pin in the lower dot. Hang 2 more pairs of bobbins at B and 2 at C, and repeat. Number 6. Diamond stitch. This is a bold, handsome filling for large spaces. Connect 5 pairs of bobbins at A. Work cloth stitch across from left to right. Stick a pin on the right-hand line. Work a cloth stitch round the pin. Cloth stitch across, placing a pin on the left-hand line, where also work a stitch round this pin. Repeat until you reach B, where connect, wrap, and tie your bobbins together, and continue them at the back of the lace, which is the side you are working on. See illustration. Until you reach C. Connect here and work across to D. Repeat the connection here, also at E, and work across to F, then from G to H. Here the bobbins must be fastened off, cut close, and 5 fresh pairs connected at I. Work to J, connect again, and again at K. working across to L, and so on until all the lines are worked. Next, fill in all the diamond spaces with the woven spiders described on page 17. Number 7. Double Réseau. This extremely elaborate stitch is really not so complicated to work as it appears, and is very uncommon. Commence as for ordinary réseau, and follow the directions given for this stitch until you arrive at the first of the double parallel lines. Connect an extra pair of bobbins here, and work cloth stitch right across with these, taking in each of the hanging bobbins in turn, and twisting the working pair twice each time in between. Connect at the end of the row, and return in exactly the same manner, bringing this extra pair of bobbins down at the end of the row to the next double line, and leave them ready until you have worked the réseau in between. Number 8. Rose filling. This very lacy stitch is worked in a similar manner to the lead filling, except that the bars are plaited instead of woven, and consequently it is very much easier of execution. Connect 2 pairs of bobbins at E, and work plait stitch to the middle of the strand. Twist each of the outside threads round a separate pin, and pin down to form a small picot each side. Continue the plait until the cross is almost reached. Now hang 2 pairs of bobbins at B, and do the same, working the cross with all 4 pairs, placing a pin in each dot, as in the lead filling. End of selected patterns.
Selections from Culpeper's Complete Herbal by Nicholas Culpeper. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Louise J. Belle. Selections from Culpeper's Complete Herbal by Nicholas Culpeper. Lady's Mantle. Description: it has many leaves rising from the root, standing upon long hairy footstalks, being almost round, and a little cut on the edges into 8 or 10 parts, making it seem like a star, with so many corners and points, and dented round about, of a light green color, somewhat hard in handling, and as it were folded or plaited at first, and then crumpled in diverse places, and a little hairy, as the stalk is also, which rises up among them to the height of 2 or 3 feet, and being weak, is not able to stand upright, but bended to the ground, divided at the top into 2 or 3 small branches, with small yellowish green heads, and flowers of a whitish color, breaking out of them, which being passed, there comes a small yellowish seed like a poppy seed. The root is somewhat long and black, with many strings and fibers thereat. Place: it grows naturally in many pastures and woodsides in Hertfordshire, Wiltshire, and Kent, and other places of this land. Time: it flowers in May and June, abides after seed time, green all the winter. Government and virtues. Venus claims the herb as her own. Lady's Mantle is very proper for those wounds that have inflammations, and is very effectual to stay bleeding, vomitings, fluxes of all sorts, bruises by falls or otherwise, and helps ruptures, and such women as have large breasts, causing them to grow less and hard, being both drank and outwardly applied. The distilled water drank for 20 days together helps conception and to retain the birth. If the women do sometimes also sit in a bath made of the decoction of the herb. It is one of the most singular wound herbs that is, and therefore highly prized and praised by the Germans, who use it in all wounds inward and outward. To drink a decoction thereof, and wash the wounds therewith, or dip tents therein, and put them into the wounds, which wonderfully dries up all humidity of the sores, and abates inflammations therein. It quickly heals all green wounds, not suffering any corruption to remain behind, and cures all old sores, though fistulous and hollow. Lavender. Being an inhabitant almost in every garden, it is so well known that it needs no description. Time. It flowers about the end of June and beginning of July. Government and virtues. Mercury owns the herb, and it carries his effects very potently. Lavender is of a special good use for all the griefs and pains of the head and brain that proceed of a cold cause, as the apoplexy, falling sickness, the dropsy, or sluggish malady, cramps, convulsions, palsies, and often faintings. It strengthens the stomach and frees the liver and spleen from obstructions, provokes women's courses, and expels the dead child and afterbirth. The flowers of lavender steeped in wine helps them to make water that are stopped, or are troubled with the wind or colic, if the place be bathed therewith. A decoction made with the flowers of lavender, horehound, fennel and asparagus root, and a little cinnamon, is very profitably used to help the falling sickness and the giddiness or turning of the brain. To gargle the mouth with the decoction thereof is good against the toothache. 2 spoonfuls of the distilled water of the flowers taken helps them that have lost their voice, as also the tremblings and passions of the heart, and faintings and swooning, not only being drank, but applied to the temples or nostrils to be smelled unto. But it is not safe to use it where the body is replete with blood and humours, because of the hot and subtle spirits wherewith it is possessed. The chemical oil drawn from lavender, usually called oil of spike, is of so fierce and piercing a quality that it is cautiously to be used, some few drops being sufficient, to be given with other things, either for inward or outward griefs. Lavender cotton. It being a common garden herb, I shall forbear the description, only taking notice that it flowers in June and July. Government and virtues. It is under the dominion of Mercury. It resists poison, putrefaction, and heals the biting of venomous beasts. A dram of the powder of the dried leaves taken every morning, fasting, stops the running of the rains in men and whites in women. The seed, beaten into powder and taken as worm seed, kills the worms not only in children, but also in people of riper years. The like doth the herb itself, being steeped in milk, and the milk drank. The body bathed with the decoction of it helps scabs and itch. Lady's smock or cuckoo flower. This is a very pretty ornament to the sides of most meadows. Description. The root is composed of many small white threads, from whence spring up diverse long stalks of winged leaves, consisting of round, tender, dark, green leaves, set one against another upon a middle rib, the greatest being at the end, amongst which arise up diverse tender, weak, round, green stalks, somewhat streaked, with longer and smaller leaves upon them, on the tops of which stand flowers, almost like the stalk gilliflowers, but rounder and not so long, of a blushing white color. The seed is reddish and grows to small branches, being of a sharp biting taste, and so has the herb. Place. They grow in moist places and near to brooksides. Time. They flower in April and May, and the lower leaves continue green all the winter. Government and virtues. They are under the dominion of the moon, and very little inferior to watercresses in all their operations. They are excellently good for the scurvy. They provoke urine, and break the stone, and excellently warm a cold and weak stomach, restoring lost appetite, and help digestion. Water lily. Of these there are two principally noted kinds, viz., the white and the yellow. Description. The white lily has very large and thick dark green leaves lying on the water, sustained by long and thick footstalks that arise from a great, thick, round and long tuberous black root, spongy or loose, with many knobs thereon, green on the outside, but as white as snow within, consisting of diverse rows of long and somewhat thick and narrow leaves, smaller and thinner the more inward they be, encompassing a head with many yellow threads or thrums in the middle, where, after they are passed, stand round poppy-like heads full of broad, oily, and bitter seed. The yellow kind is little different from the former, save only that it has fewer leaves on the flowers, greater and more shining seed, and a whitish root, both within and without. The root of both is somewhat sweet in taste. Place. They are found growing in great pools and standing waters, and sometimes in slow-running rivers and lesser ditches of water in sundry places of this land. Time. They flower most commonly about the end of May, and their seed is ripe in August. Government and virtues. The herb is under the dominion of the moon, and therefore cools and moistens like the former. The leaves and flowers of the water lilies are cold and moist, but the roots and seeds are cold and dry. The leaves do cool all inflammations, both outward and inward heat of agues, and so doth the flowers also, either by the syrup or conserve. The syrup helps much to procure rest, and to settle the brain of frantic persons, by cooling the hot distemperature of the head. The seed, as well as the root, is effectual to stay fluxes of blood or humours, either of wounds or of the belly, but the roots are most used, and more effectual to cool, bind, and restrain all fluxes in man or woman. The root is likewise very good for those whose urine is hot and sharp, to be boiled in wine and water, and the decoction drank. The distilled water of the flowers is very effectual for all the diseases aforesaid, both inwardly taken and outwardly applied, and is much commended to take away freckles, spots, sunburn, and morphew from the face or other parts of the body. The oil made of the flowers, as oil of roses is made, is profitably used to cool hot tumors and to ease the pains and help the sores. Lily of the Valley, also called conval lily, male lily, and Lily Confancy. Description: the root is small and creeps far in the ground as grass roots do. The leaves are many, against which rises up a stalk 1/2 foot high, with many white flowers like little bells with turned edges, of a strong though pleasing smell. The berries are red, not much unlike those of asparagus. Place: they grow plentifully upon Hampstead Heath and many other places in this nation. Time: they flower in May, and the seed is ripe in September. Government and virtues: it is under the dominion of Mercury, and therefore it strengthens the brain, recruits a weak memory, and makes it strong again. The distilled water dropped into the eyes helps inflammations there, as also that infirmity which they call a pin and web. The spirit of the flowers distilled in wine restores lost speech, helps the palsy, and is excellently good in the apoplexy, comforts the heart and vital spirits. Gerard saith that the flowers being close stopped up in a glass, put into an ant-hill, and taken away again a month after, ye shall find a liquor in the glass, which, being outwardly applied, helps the gout. Juniper bush. For to give a description of a bush so commonly known is needless. Place: they grow plentifully in divers woods in Kent, Warney Common near Brentwood in Essex, upon Finchley Common without Highgate, hard by the new-found wells near Dulwich, upon a common between Mitcham and Croydon, in the Highgate near Amersham in Buckinghamshire, and many other places. Time: the berries are not ripe the first year, but continue green 2 summers and 1 winter before they are ripe, at which time they are all of a black color, and therefore you shall always find upon the bush green berries. The berries are ripe about the fall of the leaf. Government and virtues. This admirable solar shrub is scarce to be paralleled for its virtues. The berries are hot in the 3rd degree, and dry but in the 1st, being a most admirable counterpoison, and as great a resister of the pestilence as any grows. They are excellent good against the bitings of venomous beasts. They provoke urine exceedingly, and therefore are very available to dysuries and stranguries. It is so powerful a remedy against the dropsy that the very lye made of the ashes of the herb being drank cures the disease. It provokes the terms, helps the fits of the mother, strengthens the stomach exceedingly, and expels the wind. Indeed, there is scarce a better remedy for wind in any part of the body or the colic than the chemical oil drawn from the berries. Such country people as know not how to draw the chemical oil may content themselves by eating 10 or a dozen of the ripe berries every morning, fasting. They are admirably good for a cough, shortness of breath, and consumption, pains in the belly, ruptures, cramps, and convulsions. They give safe and speedy delivery to women with child. They strengthen the brain exceedingly, help the memory, and fortify the sight by strengthening the optic nerves, are excellently good in all sorts of agues, help the gout and sciatica, and strengthen the limbs of the body. The ashes of the wood is a speedy remedy to such as have the scurvy, to rub their gums with. The berries stay all fluxes, help the hemorrhoids or piles, and kill worms in children. A lye made of the ashes of the wood, and the body bathed with it, cures the itch, scabs, and leprosy. The berries break the stone, procure appetite when it is lost, and are excellently good for all palsies and falling sickness. The bay tree. This is so well known that it needs no description. I shall therefore only write the virtues thereof, which are many. Government and virtues. I shall but only add a word or two to what my friend has written, viz., that it is a tree of the sun, and under the celestial sign Leo, and resists witchcraft very potently, as also all the evils old Saturn can do to the body of man, and they are not a few. For it is the speech of one, and I am mistaken if it were not Mizaldus, that neither witch nor devil, thunder nor lightning will hurt a man in the place where a bay tree is. Galen said that the leaves or bark do dry and heal very much, and the berries more than the leaves. The bark of the root is less sharp and hot, but more bitter, and hath some astriction withal, whereby it is effectual to break the stone, and good to open obstructions of the liver, spleen, and other inward parts, which bring the jaundice, dropsy, etc. The leaves are very effectual against all poison of venomous creatures, and the sting of wasps and bees, as also against the pestilence or other infectious diseases, and therefore put into sundry treacles for that purpose. They likewise procure women's courses, and 7 of them, given to a woman in sore travail of childbirth, do cause a speedy delivery, and expel the afterbirth, and therefore not to be taken by such as have not gone out their time, lest they procure abortion or cause labor too soon. They wonderfully help all cold and rheumatic distillations from the brain to the eyes, lungs, or other parts, and being made into an electuary with honey, do help the consumption, old coughs, shortness of breath, and thin rheums, as also the megrim. They mightily expel the wind and provoke urine, help the mother, and kill the worms. The leaves also work the like effects. A bath of the decoction of the leaves and berries is singularly good for women to sit in that are troubled with the mother, or the diseases thereof, or the stoppings of their courses, or for the diseases of the bladder, pains in the bowels by wind and stopping of the urine. A decoction likewise of equal parts of bayberries, cumin seed, hyssop, origanum, and euphorbium, with some honey, and the head bathed therewith, wonderfully helps distillations and rheums, and settles the palate of the mouth into its place. The oil made of the berries is very comfortable in all cold griefs of the joints, nerves, arteries, stomach, belly, or womb, and helpeth palsies, convulsions, cramp, aches, tremblings, and numbness in any part, weariness also, and pains that come by sore traveling. All griefs and pains proceeding from wind, either in the head, stomach, back, belly, or womb, by anointing the parts affected therewith. And pains in the ears are also cured by dropping in some of the oil, or by receiving into the ears the fume of the decoction of the berries through a funnel. The oil takes away the marks of the skin and flesh by bruises, falls, etc., and dissolves the congealed blood in them. It helps also the itch, scabs, and wheals in the skin. Beans. Both the garden and field beans are so well known that it saveth me the labor of writing any description of them. The virtues follow. Government and virtues. They are plants of Venus, and the distilled water of the flower of garden beans is good to clean the face and skin from spots and wrinkles, and the meal or flour of them, or the small beans, doth the same. The water distilled from the green husks is held to be very effectual against the stone, and to provoke urine. Bean flour is used in poultices to assuage inflammations arising from wounds and the swelling of women's breasts caused by the curdling of their milk, and represseth their milk. Flour of beans and fenugreek mixed with honey and applied to felons, boils, bruises, or blue marks by blows, or the imposthumes in the kernels of the ears, helpeth them all. And with rose leaves, frankincense, and the white of an egg being applied to the eyes, helpeth them that are swollen, or do water, or have received any blow upon them, if used with wine. If a bean be parted in two, the skin being taken away, and laid on the place where the leech hath been set that bleedeth too much, stayeth the bleeding. Bean flour boiled to a poultice with wine and vinegar, and some oil put thereto, eases both pains and swelling of the cods. The husks, boiled in water to the consumption of a third part thereof, stayeth a lask, and the ashes of the husks, made up with old hog's grease, helps the old pains, contusions, and wounds of the sinews, the sciatica, and gout. The field beans have all the aforementioned virtues as the garden beans. Beans eaten are extremely windy meat, but if after the Dutch fashion, when they are half boiled, you husk them and then stew them, I cannot tell you how, for I never was cook in all my life, they are wholesome food. French beans. Description. This French or kidney bean ariseth at first but with one stalk, which afterwards divides itself into many arms or branches, but all so weak that if they be not sustained with sticks or poles, they will be fruitless upon the ground. At several places of these branches grow foot stalks, each with 3 broad, round, and pointed green leaves at the end of them. Towards the top comes forth divers flowers, made like to peas blossoms, of the same color for the most part that the fruit will be of, that is to say, white, yellow, red, blackish, or of a deeper purple, but white is the most usual. After which come long and slender flat cods, some crooked, some straight, with a string running down the back thereof, wherein is flattish round fruit made like a kidney. The root long spreads with many strings annexed to it, and perishes every year. There is another sort of French beans, commonly growing with us in this land, which is called the scarlet flower bean. This rises with sundry branches as the other, but runs higher, to the length of hop poles, about which they grow twining, but turn contrary to the sun, having footstalks with 3 leaves on each, as on the other. The flowers also are like the other, and of a most orient scarlet color. The beans are larger than the ordinary kind, of a dead purple color, turning black when ripe and dry. the root perishes in winter. Government and virtues. These also belong to Dame Venus, and being dried and beat to powder, are as great strengtheners of the kidneys as any are. Neither is there a better remedy than it. A dram at a time, taken in white wine to prevent the stone, or to cleanse the kidneys of gravel or stoppage. The ordinary French beans are of an easy digestion. They move the belly, provoke urine, enlarge the breast that is straitened with shortness of breath, engender sperm, and incite to venery. And the scarlet-colored beans, in regard of the glorious beauty of their color, being set near a quickset hedge, will bravely adorn the same by climbing up thereon, so that they may be discerned a great way, not without admiration of the beholders at a distance. But they will go near to kill the quicksets by clothing them in scarlet. Water betony, called also brownwort, and in Yorkshire, bishop's leaves. Description. First, of the water betony, which rises up with square, hard, greenish stalks, sometimes brown, set with broad, dark green leaves, dented about the edges with notches somewhat resembling the leaves of the wood betony, but much larger too, for the most part set at a joint. The flowers are many, set at the tops of the stalks and branches, being round-bellied and open at the brims, and divided into two parts, the uppermost being like a hood, and the lowermost like a hip hanging down, of a dark red color, which passing there comes in their places, small round heads with small points at the ends, wherein lie small and brownish seeds. The root is a thick bush of strings and shreds growing from the head. Place. It grows by the ditch side, brooks, and other watercourses, generally through this land, and is seldom found far from the waterside. Time. It flowers about July, and the seed is ripe in August. Government and virtues. Water betony is an herb of Jupiter in Cancer, and is appropriated more to wounds and hurts in the breasts than wood betony, which follows. It is an excellent remedy for sick hogs. It is of a cleansing quality. The leaves, bruised and applied, are effectual for all old and filthy ulcers, and especially if the juice of the leaves be boiled in a little honey, and dipped therein, and the sores dressed therewith, as also for bruises and hurts, whether inward or outward. The distilled water of the leaves is used for the same purpose, as also to bathe the face and hands spotted or blemished or discolored by sunburning. I confess I do not much fancy distilled waters. I mean such waters as are distilled cold. Some virtues of the herb they may haply have, it were a strange thing else. But this I am confident of, that being distilled in a pewter still, as the vulgar and apish fashion is, both chemical oil and salt is left behind, unless you burn them, and then all is spoiled, water and all, which was good for as little as can be by such a distillation. The beech tree. In treating of this tree, you must understand that I mean the green mast beech, which is by way of distinction from that other small, rough sort, called in Sussex the smaller beech, but in Essex hornbeam. I suppose it is needless to describe it, being already too well known to my countrymen. Place. It grows in woods amongst oaks and other trees, and in parks, forests, and chases to feed deer, and in other places to fatten swine. Time. It blooms in the end of April, or beginning of May for the most part, and the fruit is ripe in September. Government and virtues. It is a plant of Saturn, and therefore performs his qualities and proportion in these operations. The leaves of the beech tree are cooling and binding, and therefore good to be applied to hot swellings to discuss them. The nuts do much nourish such beasts as feed thereon. The water that is found in the hollow places of decaying beeches will cure both man and beast of any scurf or running tetters, if they be washed therewith. You may boil the leaves into a poultice, or make an ointment of them when time of year serves. End of Selections from Culpeper's Complete Herbal by Nicholas Culpeper. Recording by Louise J. Belle, Sebastopol, California.
Part 1 of A Short List of Scientific Books, published by E and FN Spawn Limited. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Chris Pyle. A Short List of Scientific Books, published by E and FN Spawn Limited. 57 Haymarket, London, S.W. Telephone 3450 Gerrard. Telegrams, Finspawn, Charles, London. Publication of Myron C. Clark, New York. Spawn and Chamberlain, New York. Business Code, Coy, New York. Established 1830. Agriculture. Hemp, a practical treatise on the culture for seed and fiber, by S.S. Boyce. 13 illustrations. 112 pages. Crown octavo. New York, 1912. 2 shillings 6 net. Farm Drainage by H. F. French, 100 illustrations, 284 pages. Crown octavo. New York, 1913. 4 shillings 6 net. Talks on Manures by J. Harris, new edition, 366 pages. Crown octavo. New York, 1902. 6 shillings 6 net. Coffee, Its Culture and Commerce in All Countries, by C. G. W. Locke. 11 plates, 274 pages. Crown octavo, 1888. 12 shillings 6. Sugar, A Handbook for Planters and Refiners, by the late J. A. R. Newlands and B. E. R. Newlands. 236 illustrations. 876 pages, octavo, 1909, £1 5 shillings net. Hops, Their Cultivation, Commerce, and Uses, by P. L. Simmons, 143 pages, Crown octavo, 1877, 4 shillings 6. Estate Fences, Their Choice, Construction, and Cost, by A. Vernon, reissue, 150 illustrations, 420 pages, octavo, 1909, 8 shillings 6 net. Architecture and Building. The Hydropathic Establishment and Its Baths, by R. O. Alsop. 8 plates, 107 pages, demi-octavo, 1891, 5 shillings. The Turkish Bath, Its Design and Construction, by R. O. Alsop. 27 illustrations, 152 pages. Demi-octavo, 1890, 6 shillings. The Builder's Clerk, by T. Bales, 2nd edition, 92 pages, foolscap octavo, 1904, 1 shilling 6pence. Glossary of Technical Terms Used in Architecture and the Building Trades, by G. J. Burns, 136 pages, Crown octavo, 1895, 3 shillings 6pence. Chimney Design and Theory, by W. W. Christie, 2nd edition, 54 illustrations, 200 pages, Crown octavo, New York, 1902, 12 shillings 6pence net. Approximate Estimates, by T. E. Coleman, 4th edition, 407 pages. Tricesimo Secondo, 1914, 5 shillings net. Stable Sanitation and Construction, by T. E. Coleman, 183 illustrations, 226 pages, Crown octavo, 1897, 3 shillings net. House Plans and Building Construction for General Contractors and House Builders, by M. M. Dustman, 511 illustrations, 236 pages, oblong folio, New York, 1912, 8 shillings 6pence net. Building Construction Drawing, by Richard B. Eaton, in 2 parts, Imperial octavo, limp, 1914. Part 1, 26 plates, 59 pages, 1 shilling 6pence net. Part 2, 26 plates, 64 pages, 1 shilling 6pence net. Parts 1 and 2 in 1 volume, 3 shillings net. Architectural Examples in Brick, Stone, Wood, and Iron, by W. Fullerton, 3rd edition, 245 plates, 254 pages, demi-octavo, 1914, 15 shillings net. Building Supervision, by George W. Gray, 10 plus 146 pages, Crown octavo, 1913, 2 shillings 6pence net. The Clerk of Works Vade Mecum, by G. G. Hoskins, 8th edition, 1914, 1 shilling 6pence net. A Handbook of Formulae, Tables, and Memoranda for Architectural Surveyors, by J. T. Hurst, 15th edition, new impression, 112 illustrations, 8 plus 512 pages. Royal Tricesimo Secondo, Rhone, 1915, 5 shillings net. Paint and Color Mixing, by A. S. Jennings, 5th edition, 14 color plates, 190 pages, octavo, 1915, 5 shillings net. Quantity Surveying, by J. Leaning, 5th edition, new impression, 936 pages, octavo, 1912, £1, 5 shillings net. Builder's Quantities, by H. M. Lewis, 6 illustrations, 44 pages, Crown octavo, S&C Series No. 40, 1911, 1 shilling 6pence net. Obstruction to Light, a graphic method of determining problems of ancient lights, by H. B. Molesworth, 9 folding plates. Quarto, 1902, 6 shillings net. Suburban Houses, a series of practical plans, by J. H. Pearson, 46 plates and 12 pages text. Crown quarto, 1905, 5 shillings net. Solid Bitumens, Their Physical and Chemical Properties, by S. F. Peckham, 23 illustrations, 324 pages, 8 volumes, New York, 1909, £1, 1 shilling. Roman Architecture, Sculpture, and Ornament, by G. B. Peronese, 200 plates, reproduced in facsimile from the original 2 volumes, Imperial Folio, in wrappers, 1900, £2, 2 shillings, net. The 7 Periods of English Architecture, defined and illustrated by E. Sharp. 3rd edition, 20 steel plates. Royal 8vo, 1888, 12 shillings, 6 pence. Our Factories, Workshops, and Warehouses, Their Sanitary and Fire-Resisting Arrangements, by B. H. Thwaite. 183 illustrations, 282 pages. Crown 8vo, 1882, 9 shillings. Elementary Principles of Carpentry, by T. Threadgold and J. T. Hurst. 11th edition, 48 plates, 517 pages. Crown 8vo, 1914, 7 shillings, 6 pence, net. Motor Bodybuilding in all its branches, by C. W. Terry, with additional matter by Arthur Hall. Medium 8vo, 256 pages, 15 illustrations, 50 plates, 1914, 10 shillings, 6 pence, net. Postage, inland 5 pence, abroad 10 pence. Practical Stair Building and Hand Railing by W. H. Wood. 32 plates, 91 pages, Crown 8vo, 1894, 10 shillings, 6 pence. Spawn's Architects and Builders Pocket Price Book, edited by Clyde Young, revised by Stanford M. Brooks. Sextodecimo, green leather cloth, size 6½ inches by 3 3/4 inches by ½ inch thick. 2 shillings, 6 pence net, revised and issued annually. Spawn's Practical Builder's Pocket Book, edited by Clyde Young and Stanford M. Brooks. 74 illustrations, 8 plus 456 pages. Sextodecimo, maroon leather cloth, 1915, 5 shillings net. Artillery, guns and gun-making material, by G. Eddy. 7 plus 74 pages, Crown 8vo, 1889, 6 shillings. Treatise on Application of Wire to Construction of Ordnance, by J. A. Longridge. 180 pages, 8 volumes, 1884. £1, 5 shillings. Aviation, The Atmosphere, Its Characteristics and Dynamics, by F. J. B. Cordiero. 35 illustrations, 129 pages. Small quarto, New York, 1910, 10 shillings, 6 pence, net. Theory and Practice of Model Airplaning, by V. E. Johnson. 61 illustrations, 16 plus 148 pages. Crown 8vo, 1910, 3 shillings, 6 pence, net. Natural Stability and the Parachute Principle in Airplanes, by W. Lemaitre. 34 illustrations, 48 pages, Crown 8vo, S&C Series number 39, 1911, 1 shilling, 6 pence, net. How to Build a 20-foot Biplane Glider, by A. P. Morgan. 31 illustrations, 60 pages, Crown 8vo, S&C Series number 14, New York, 1909, 1 shilling, 6 pence, net. Flight Velocity, by A. Samuelson. 4 plates, 42 pages, 8 volumes sewed, 1906, 2 shillings, net. Resistance of Air and the Question of Flying, by A. Samuelson. 23 illustrations, 36 pages, 8vo, sewed, 1905, 2 shillings, net. The Laws of Avanzini, Laws of Planes Moving at an Angle in Air and Water, by Lieutenant Colonel R. de Villamil. 2 folding plates, 3 illustrations, 23 pages, Super Royal 8vo, sewed, 1912, 2 shillings, net. Airplanes. Airplanes in Gusts, Soaring Flight, and Airplane Stability, by S. L. Walkden. 2nd edition, 4 plates, 47 illustrations, 16 plus 188 pages, 8vo, 1913, 12 shillings, 6 pence, net. Bridges, Arches, Roofs, and Structural Design. Strains in Ironwork, by Henry Adams. 4th edition, 8 plates, 65 pages, Crown octavo, 1904, 5 shillings. Designing Ironwork by Henry Adams, 2nd series, octavo, sewed. Part 1, a steel box girder, 1894, 9d, net. Part 2, build-up steel stanchions, 1901, 1 shilling, 3d, net. Part 3, cisterns and tanks, 1902, 1 shilling, net. Part 4, a fireproof floor, 1903, 1 shilling, net. Columns and struts, theory and design by William Alexander, 101 illustrations, 12 plus 265 pages, demi-octavo, 1912, 10 shillings, 6d, net. A Practical Treatise on Segmental and Elliptical Oblique or Skew Arches by G.J. Belle, 2nd edition, 17 plates, 125 pages, Royal Octavo, 1906, £1, 1 shilling, net. Economics of Construction in Relation to Frame Structures by R.H. Bow, 3rd thousand, 16 plates, 88 pages, Octavo, 1873, 5 shillings. Theory of Voussoir Arches by Professor W. Kane, 3rd edition, 201 pages, 18mo. Boards, New York, 1905, 2 shillings, net. Theory of Arches and Suspension Bridges by J. Mellon and D. B. Steinman, C.E., Ph.D., demi-octavo, 303 pages, 118 illustrations, New York, 1913, 15 shillings net, postage inland, 5d, abroad, 10d. New Formulae for the Loads and Deflections of Solid Beams and Girders by W. Donaldson, 2nd edition, 11 illustrations, 8 plus 56 pages, octavo, 1872, 4 shillings and 6d. Plate Girder Railway Bridges by M. Fitzmaurice, 4 plates, 104 pages, octavo, 1895, 6 shillings. Pocket Book of Calculations and Stresses by E. M. George, 66 illustrations, 140 pages, Royal Tresimo Secundo, half roan, 1895, 3 shillings 6d. Tables for Roof Framing by G. D. Inskip, 2nd edition, 451 pages, octavo, leather, New York, 1905, 12 shillings 6d, net. Stresses in Girder and Roof Frames for both dead and live loads by simple multiplication, etc. by F. R. Johnson, 28 plates, 215 pages, Crown octavo, 1894, 6 shillings. A Graphical Method for Swing Bridges by B. F. LaRue, 4 plates, 104 pages, 18mo. Boards, 2nd edition, New York, 1904, 2 shillings net. Notes on Cylinder Bridge Piers and the Well System of Foundations by J. Newman, 144 pages, octavo, 1893, 6 shillings. Calculation of Columns by T. Nielsen, 4 plates, 36 pages, octavo, 1911, 4 shillings 6d, net. A New Method of Graphic Statics Applied in the Construction of Wrought Iron Girders by E. Orlander, 16 plates, small folio, 1887, 10 shillings 6d. Steel bar and plate tables, giving weight and a lineal foot of all sizes of L and T bars, flat bars, plates, square, and round bars, by E. Reed, on large folding card, 1 shilling net. Reference Book for Statistical Calculations by F. Roof, with diagrams, 140 pages, Crown octavo, 1906, 5 shillings net. Suspension Bridges and Cantilevers by D. B. Steinman, 7 plus 185 pages, 18mo. Boards, Van Nostrand Series, number 127, New York, 1911, 2 shillings net. The Anatomy of Bridgework by W.H. Thorpe, 103 illustrations, 190 pages, Crown octavo, 1914, 6 shillings net. Cement and Concrete. Portland Cement, its manufacture, testing, and use by D.B. Butler, 3rd edition, 135 illustrations, including 17 plates, 12 plus 450 pages, octavo, 1913, 16 shillings net. Theory of Steel Concrete Arches and of Vaulted Structures by W. Kane, 5th edition, 27 illustrations, 212 pages, octodecimo. Boards, New York 1909, 2 shillings net. Reinforced Concrete Construction, Elementary Course by M. T. Cantrell, 65 illustrations, 135 pages, Crown octavo, 1911, 4 shillings, 6 net. Reinforced Concrete Construction, Advanced Course by M. T. Cantrell, 242 illustrations, 16 plus 240 pages, Super Royal octavo, 1912, 12 shillings, 6 net. Graphical Reinforced Concrete Design, a series of diagrams on sheets measuring 17.5 inches by 22.5 inches for designing and checking, with 48-page pamphlet by J. A. Davenport, complete in roll, 1911, 5 shillings net. Cement Users and Buyer's Guide by Calcare, 115 pages. Tricesimo Secondo, cloth, 1901, 1 shilling, 6 net. Diagrams for Designing Reinforced Concrete Structures by G. F. Dodge, 31 illustrations, 104 pages, oblong folio, New York 1910, 17 shillings net. Cements, Mortars, and Concretes, Their Physical Properties by M. S. Falk, 78 illustrations, 176 pages, octavo, New York 1904, 10 shillings, 6 net. Concrete Construction, Methods, and Cost by H. P. Gillette and C. S. Hill, 310 illustrations, 690 pages, octavo, New York 1908, £1, 1 shilling net. Works by A. A. Houghton. Practical Silo Construction, 18 illustrations, 69 pages, Crown octavo, S&C Series No. 27, New York 1911, 1 shilling, 6 net. Molding Concrete Chimneys, Slate, and Roof Tiles, 15 illustrations, 61 pages, Crown octavo, S&C Series No. 28, New York 1911, 1 shilling, 6 net. Molding and Curing Ornamental Concrete, 5 illustrations, 58 pages, Crown octavo, S&C Series No. 29, New York 1911, 1 shilling, 6 net. Concrete Wall Forms, 16 illustrations, 62 pages, Crown octavo, S&C Series No. 30, New York 1912, 1 shilling, 6 net. Concrete Monuments, Mausoleums, and Burial Vaults, 18 illustrations, 65 pages, Crown octavo, S&C Series No. 31, New York 1911, 1 shilling, 6 net. Concrete Floors and Sidewalks, 8 illustrations, 63 pages, Crown octavo, S&C Series No. 32, New York 1911, 1 shilling, 6 net. Molding Concrete Baths, Tubs, Aquariums, and Natatoriums, 16 illustrations, 64 pages, Crown octavo, S&C Series No. 33, New York 1911, 1 shilling, 6 net. Concrete Bridges, Culverts, and Sewers, 14 illustrations, 58 pages, Crown octavo, S&C Series No. 34, New York 1912, 1 shilling, 6 net. Constructing Concrete Porches, 18 illustrations, 62 pages, Crown octavo, S&C Series No. 35, 1 shilling, 6 net. Molding Concrete Flower Pots, Boxes, Jardinières, etc. 8 illustrations, 52 pages, Crown octavo, S&C Series number 36, New York, 1912. 1 shilling, 6 net. Molding concrete fountains and lawn ornaments. 14 illustrations, 56 pages, Crown octavo, S&C Series number 37, New York, 1912. 1 shilling, 6 net. Concrete and Reinforced Concrete by H.A. Reed. 715 illustrations, 884 pages, Royal octavo, New York, 1907. £1, 1 shilling net. Specifications for concrete flags issued by the Institution of Municipal and County Engineers. Folio, sewed, 1911, 2 shillings, 6 net. Civil Engineering, Canals, Surveying. See also Irrigation and Water Supply. Practical Hints to Young Engineers Employed on Indian Railways by A.W.C. Addis. 14 illustrations, 154 pages. Duodecimo, 1910. 3 shillings, 6 net. Leveling, Barometric, Trigonometric, and Spirit by I.O. Baker. 3rd edition, 15 illustrations, 145 pages. Octodecimo, Boards, New York, 1910. 2 shillings net. River and Canal Engineering by E.S. Belassus. 72 illustrations, 10 plus 222 pages. Octavo, 1913. 8 shillings, 6 net. Punjab Rivers and Works by E.S. Belassus. 2nd edition. 47 illustrations, 8 plus 64 pages. Folio, 1912. 8 shillings net. Notes on Instruments Best Suited for Engineering Fieldwork in India and the Colonies by W. G. Bly. 65 illustrations, 218 pages. Octavo, 1914. 5 shillings, 6. The Civil Engineer's Cost Book by Major T. E. Coleman, R.E. 12 plus 289 pages. Pocket size, 6.5 by 3 5/8 inches. Leather cloth, 2nd edition, 1915. 5 shillings net. Retaining Walls in Theory and Practice by T. E. Coleman. 104 illustrations, 160 pages. Crown octavo, 1914. 5 shillings net. On Curved Masonry Dams by W. B. Coventry. Octavo, sewed, 1894. 2 shillings. A Practical Method of Determining the Profile of a Masonry Dam by W. B. Coventry. Octavo, sewed, 1894. 2 shillings, 6. The Stresses on Masonry Dams, Oblique Sections by W. B. Coventry. Octavo, sewed, 1894. 2 shillings. Handbook of Cost Data for Contractors and Engineers by H. P. Gillette. 1,854 pages. Crown octavo, leather, gilt edges, 2nd edition. New York, 1914. £1, 1 shilling net. High Masonry Dams by E. S. Gould. 2nd edition, with illustrations. 88 pages. Octodecimo, boards. New York, 1905. 2 shillings net. Railway Tunneling in Heavy Ground by C. Gripper. 3 plates, 66 pages. Royal Octavo, 1879. 7 shillings, 6. Leveling in its General Application by Thomas Holloway. Revised by H. T. Tallock. Octavo, 71 illustrations, 149 pages. 3rd edition, 1914. 2 shillings, 6 net. Postage, inland, 4 abroad, 6. Waterways and Water Transport by J. S. Jeans. 55 illustrations, 520 pages. Octavo, 1890. 9 shillings net. Table of Barometric Heights to 20,000 feet by Lieutenant Colonel W. H. Mackesy. 1 plate, 24 pages. Royal Tricesimo Secondo. 3 shillings. Aid Book to Engineering Enterprise by E. Matheson. 3rd edition, illustrated, 916 pages. Medium octavo, Buckram, 1898. £1, 4 shillings. A Treatise on Surveying by R. E. Middleton and O. Chadwick. 3rd edition, Royal Octavo, 1911. Part 1, 11 plates, 162 illustrations, 285 pages. 10 shillings, 6pence. Part 2, 152 illustrations and 2 plates, 340 pages. 10 shillings, 6pence. A pocketbook of useful formulae and memoranda for civil and mechanical engineers by Sir G. L. Molesworth and H. B. Molesworth, with an electrical supplement by W. H. Molesworth. 27th edition, 800 illustrations, 8 plus 936 pages. Oblong, Tricesimo Secondo, leather, 1913, 5 shillings net. The Pocketbooks of Sir G. L. Molesworth and J. T. Hurst, printed on India paper and bound in 1 volume. Royal Tricesimo Secondo, Russia, gilt edges, 10 shillings, 6pence net. Metallic Structures, Corrosion and Fouling and Their Prevention by J. Newman, 38 illustrations, 12 plus 374 pages. Crown Octavo, 1896, 9 shillings. Scamping Tricks and Odd Knowledge occasionally practiced upon public works by J. Newman. New impression, 129 pages. Crown Octavo, 1908, 2 shillings net. Compensation Discharge in the Rivers and Streams of the West Riding, Yorkshire, England, by M. M. Patterson, 55 pages, octavo, 1896, 2 shillings net. Coordinate Geometry Applied to Land Surveying by W. Pilkington, 5 illustrations, 44 pages. Duodecimo, 1909, 1 shilling, 6pence net. Pioneering by F. Shelford, 14 illustrations, 88 pages. Crown Octavo, 1909, 3 shillings net. Topographical Surveying by G. J. Sprecht, 4th edition, 2 plates and 28 illustrations, 210 pages. Octodecimo, Boards, New York, 1910, 2 shillings net. Spahn's Dictionary of Engineering, Civil, Mechanical, Military and Naval, 10,000 illustrations, 4,300 pages. Super Royal Octavo, 1874, supplement issued in 1881, complete in 4 volumes. £3, 3 shillings net. Surveying and Leveling Instruments, Theoretically and Practically Described by W. F. Stanley, revised by H. T. Tallock, for construction, qualities, selection, preservation, adjustments, and uses, with other apparatus and appliances used by civil engineers and surveyors in the field. 4th edition, 433 illustrations, 606 pages, 1914. 7 shillings, 6pence net. Postage, inland, 5pence. Abroad, 10pence. Surveyor's Handbook by T. U. Taylor, 116 illustrations, 310 pages. Crown Octavo, leather, gilt edges, New York, 1908, 8 shillings, 6pence net. Logarithmic Land Measurement by J. Wallace, 32 pages, Royal Octavo, 1910, 5 shillings net. Land Drainage, a treatise on the design and construction of open and closed drains by J. L. Parsons, Associate M. W. Society of Engineers. Demi-octavo, 36 illustrations, 22 tables, 165 pages, New York, 1915, 7 shillings, 6pence net. Postage, inland, 4pence, abroad, 6pence. The Drainage of Fens and Lowlands by Gravitation and Steam Power by W. H. Wheeler, 8 plates, 175 pages, octavo, 1888, 12 shillings, 6pence. Stadia Surveying the Theory of Stadia Measurements by A. Winslow, 9th edition, 148 pages. Octodecimo, Boards, New York, 1913, 2 shillings net. Handbook on Tachyometrical Surveying by C. Zaitis. 55 illustrations, 3 plates, 63 pages, octavo, 1909, 6 shillings net. Curve Tables. Grace's Tables for Curves with Hints to Young Engineers. 8 figures, 43 pages. Oblong octavo, 1908, 5 shillings net. Data relating to railway curves and superelevation shown graphically by J. H. Haste on folding card for pocket use. 6 net. Tables for setting out railway curves by C. P. Hogg. A series of cards in neat cloth case. 4 shillings 6. Tables for setting out curves for railways, roads, canals, etc. by A. Kennedy and R. W. Hackwood. Tricesimo secondo. 2 shillings net. Spiral Tables by J. G. Sullivan. 47 pages. Duodecimo, leather. New York, 6 shillings 6 net. Tables for setting out curves from 101 to 5,000 feet radius. By H. A. Cutler and F. J. Edge. Royal Tricesimo Secondo, 2 shillings net. Tables of parabolic curves for the use of railway engineers and others by G. T. Allen. Foolscap Sextodecimo, 4 shillings. Transition Curves by W. G. Fox, 2nd edition, 80 pages, octodecimo, boards, New York, 2 shillings net. Dictionaries. Technological Dictionary in the English, Spanish, German, and French languages by D. Carlos Hulin E. Arsu. Crown Octavo, Volume 1, English, Spanish, German, French, 609 pages, 1906, 10 shillings 6 net. Volume 2, German, English, French, Spanish, 720 pages, 1908, 10 shillings 6 net. Volume 3, French, German, Spanish, English, in preparation. Volume 4, Spanish, French, English, German, 750 pages, 1910, 10 shillings 6 net. Dictionary of English and Spanish Technical and Commercial Terms by W. Jackson. 164 pages, foolscap octavo, 1911, 2 shillings 6 net. English-French and French-English Dictionary of the Motor Car, Cycle, and Boat by F. Lucas, 171 pages, Crown octavo, 1915, 2 shillings net. Spanish-English Dictionary of Mining Terms by F. Lucas, 78 pages, octavo, 1905, 5 shillings net. English-Russian and Russian-English Engineering Dictionary by L. Micliar, 100 pages, sextodecimo, 1909, 2 shillings 6 net. Domestic Economy. Food Alteration and Its Detection by J. T. Battershall. 12 plates, 328 pages. Demi-octavo, New York, 1887, 15 shillings. The Cooking Range, Its Failings and Remedies by F. Dye, 52 pages. Foolscap octavo, sewed, 1888, 6. Spices and How to Know Them by W. M. Gibbs, with 47 plates, including 14 in colors. 179 pages, octavo, New York, 1909, 15 shillings net. The Kitchen Boiler and Water Pipes by H. Grimshaw, octavo, sewed, 1887, 1 shilling net. Spawn's Household Manual, 250 illustrations, 1,043 pages, demi-octavo, 1902, 7 shillings 6. Ditto, half-bound French Morocco, 9 shillings. Drawing. The Ornamental Penman's Engravers and Sign Writers Pocket Book of Alphabets by B. Alexander, New Impression. Oblong duodecimo, sewed, 6 net. Slide Valve Diagrams, a French Method for Their Construction, by L. Bankson. Octodecimo, boards, New York 1892, 2 shillings net. A System of Easy Lettering by J.H. Cromwell, 12th edition, 39 plates, oblong octavo, New York 1912, 2 shillings 6 net. Key to the Theory and Methods of Linear Perspective by C.W. Diemen, F.S.A., 6 plates, 32 pages, crown octavo, S&C Series No. 20, 1910, 1 shilling 6 net. Plain Geometrical Drawing by R.C. Fowdry, illustrated, 185 pages, crown octavo, 1901, 3 shillings net. Hints on Architectural Draftsmanship by G.W.T. Hallett, 4th edition, 80 pages, octodecimo, 1906, 1 shilling 6 net. A First Course of Mechanical Drawing, Tracing, by G. Halliday. Oblong quarto, sewed, 2 shillings. A Textbook of Graphic Statics, by C.W. Malcolm, 155 illustrations, 316 pages, octavo, New York 1909, 12 shillings 6 net. Drawings for Medium-Sized Repetition Work by R.D. Spinney, 47 illustrations, 130 pages, octavo, 1909, 3 shillings 6 net. Mechanical Drawing Instruments by W.F. Stanley, 7th edition, 265 illustrations, 370 pages, crown octavo, 1900, 5 shillings. Earthwork. Tables for Computing the Contents of Earthwork in the Cuttings and Embankments of Railways by W. MacGregor, 1 plate, 59 pages, Royal octavo, 6 shillings. Tables for Facilitating the Calculation of Earthworks by D. Cunningham, 120 pages, Royal octavo, 10 shillings 6. Grace's Earthwork Tables, 36 double-page tables. Quarto, 12 shillings 6 net. Earthwork Slips and Subsidences on Public Works by J. Newman, 240 pages, crown octavo, 1890, 7 shillings 6. Electrical Engineering. Journal of the Institution of Electrical Engineers, edited by P. F. Rolls, Secretary. Issued in quarto parts. The number of parts are from 12 to 16 annually. Annual subscription, 46 shillings. Post-free, payable in advance. Single copies, 3 shillings 9. Post-free. Practical Electric Bell Fitting by F. C. Alsop, 10th edition, 186 illustrations, including 8 folding plates, 185 pages, crown octavo, 1914, 2 shillings 6. Telephones, Their Construction and Fitting by F. C. Alsop, 8th edition, new impression, 184 illustrations, 222 pages, crown octavo, 1914, 2 shillings 6 net. Electric Bell Construction by F. C. Alsop, new impression, 177 illustrations, 12 plus 131 pages, crown octavo, 1914, 2 shillings 6 net. Induction Coils and Coil Making by F. C. Alsop, 2nd edition, new impression, 125 illustrations, 12 plus 172 pages, crown octavo, 1914, 2 shillings 6 net. Auto Transformer Design by A. H. Avery, 25 illustrations, 60 pages, octavo, 1909, 2 shillings 6 net. Principles of Electric Power, Continuous Current, for Mechanical Engineers by A. H. Bate, 63 illustrations, 204 pages, crown octavo, 1914, Finsbury Technical Manual, 4 shillings 6 net. Practical Construction of Electric Tramways by W. R. Bowker, 93 illustrations, 119 pages, octavo, 1914, 6 net. Dynamo Lighting for Motor Cars by M. A. Codd, 2nd edition, 140 illustrations, 6 plus 107 pages, octavo, 1914, 2 shillings 6 net. Design and Construction of Induction Coils by A.F. Collins. 155 illustrations, 272 pages. Demi-octavo, New York, 1909. 12 shillings, 6 net. Switchboard Measuring Instruments for Continuous and Polyphase Currents by J.C. Connon. 117 illustrations, 150 pages. Octavo, 1914. 3 shillings, 6 net. Electric Cables, Their Construction and Cost by D. Coyle and F. J. O. Howe. With many diagrams and 216 tables, 466 pages. Crown octavo, leather, 1909. 15 shillings, net. Management of Electrical Machinery by F. B. Crocker and S. S. Wheeler. 8th edition, 131 illustrations, 223 pages. Crown octavo, New York, 1909. 4 shillings, 6 net. Electric Lighting, A Practical Exposition of the Art by F. B. Crocker. Royal Octavo, New York. Volume 1, The Generating Plant. 6th edition, 213 illustrations, 470 pages, 1904. 12 shillings, 6 net. Volume 2, New Edition in Preparation. The Care and Management of Ignition Accumulators by H. H. U. Cross. 12 illustrations, 75 pages, Crown octavo, S&C Series No. 19. 1910, 1 shilling, 6 net. Elements of Telephony by A. Crotch. 51 illustrations, 90 pages, Crown octavo, S&C Series No. 21. 1911, 1 shilling, 6 net. Elementary Telegraphy and Telephony by Arthur Crotch. New impression, 238 illustrations, 8 plus 223 pages, octavo, Finsbury Technical Manual, 1912, 4 shillings, 6 net. Electricity and Magnetism in Telephone Maintenance by G. W. Cummings, 45 illustrations, 137 pages, octavo, New York, 1908, 6 shillings, 6 net. Grouping of Electric Cells by W. F. Dunton, 4 illustrations, 50 pages, Foolscap octavo, 1914, 1 shilling, 6 net. Wireless Telegraphy for Intending Operators by C. K. P. Eden, 16 illustrations, 80 pages, Crown octavo, S&C Series No. 24, 1913, 1 shilling, 6 net. Magnets and Electric Currents by J. A. Fleming, M.A., D.Sc., F.R.S. An Elementary Treatise for the Use of Electrical Artisans and Science Teachers. Crown octavo, 136 illustrations, 408 pages, 3rd edition, 1914, 3 shillings, 6 net. Postage, inland, 4 abroad, 8 Notes on Design of Small Dynamo by George Halliday. 2nd edition, 8 plates, octavo, 1895, 2 shillings, 6 Practical Alternating Currents and Power Transmission by N. Harrison. 172 illustrations, 375 pages. Crown octavo, New York, 1906, 10 shillings, 6 net. Plans and Specification for Wireless Telegraph Sets by A. F. Collins. Crown octavo, S&C Series Numbers 41 and 42. New York, 1912. 1 shilling, 6 each, net. Part 1, an experimental set and a 1 to 5 mile set. 37 illustrations, 8 plus 45 pages. Part 2, a 5 to 10 mile set and a 10 to 20 mile set. 63 illustrations, 8 plus 72 pages. Practical and Experimental Wireless Telegraphy. A Handbook for Operators, Students, and Amateurs by W. J. Shaw, member of the Wireless Society of London. 42 illustrations, 102 pages, Crown octavo, 1914, 3 shillings, 6 net. Post free, 3 shillings, 10 Making Wireless Outfits by N. Harrison. 27 illustrations, 61 pages, Crown octavo, S&C Series No. 11, 2nd edition, New York, 1914, 1 shilling, 6 net. Wireless Telephone Construction by N. Harrison. 43 illustrations, 73 pages, Crown Octavo, S&C Series No. 12, New York, 1913. 1 shilling, 6 net. Wireless time signals, radio telegraphic time and weather signals, transmitted from the Eiffel Tower and their receipt. Authorized translation of the report of the Bureau of Longitudes with additional tables and data. Crown Octavo, 133 pages, 1 folding plate, 30 illustrations, 1915. 3 shillings, 6 net. Postage 4 pence. Testing Telegraph Cables by Colonel V. Hoskier. 3rd edition, 11 illustrations, 8 plus 75 pages, Crown Octavo, 1889, 4 shillings, 6 pence. Long Distance Electrical Power Transmission by R.W. Hutchison. 136 illustrations, 345 pages, Crown Octavo, New York, 1907. 12 shillings, 6 pence net. Theory and Practice of Electric Wiring by W.S. Ibbotson. 119 illustrations, 366 pages, Crown Octavo, 1914. 3 shillings, 6 pence net. Practical Electrical Engineering for Elementary Students by W.S. Ibbotson. 61 illustrations, 155 pages, Crown Octavo, 1914, 2 shillings, 6 pence net. Form of Model General Conditions recommended for use in connection with contracts for electrical works, issued by the Institution of Electrical Engineers. Foolscap, 19 pages, revised April 1914. 6 pence net, postage 1 pence. Telegraphy for Beginners by W. H. Jones. 19 illustrations, 58 pages, Crown Octavo, 2nd edition, New York, 1913. 2 shillings net. A Handbook of Electrical Testing by R. H. Kempe. 7th edition, 285 illustrations, 706 pages, Octavo, 1908, 18 shillings net. Electromagnets, Their Design and Construction by A. N. Mansfield. 36 illustrations, 155 pages, Octodecimo, Boards, 2nd edition, New York, 1908. 2 shillings net. Telephone Construction Methods and Cost by C. Mayer, with appendices on the cost of materials and labor by J. C. Slippy. 103 illustrations, 284 pages, Crown Octavo, New York, 1908, 12 shillings, 6 pence net. Practical Electrics, a Universal Handybook on Everyday Electrical Matters, 9th edition, 126 illustrations, 135 pages, Octavo, S&C Series No. 13, New York, 1909, 1 shilling, 6 pence net. Wiring Houses for the Electric Light by N. H. Schneider. 40 illustrations, 85 pages, Crown Octavo, S&C Series No. 25, New York, 1911, 1 shilling, 6 pence net. Induction Coils by N. H. Schneider. 79 illustrations, 285 pages, Crown Octavo, 2nd edition, New York, 1909, 4 shillings, 6 pence net. How to Install Electric Bells, Annunciators, and Alarms by N. H. Schneider. 2nd edition, 1913, 70 illustrations, 83 pages, Crown Octavo, S&C Series No. 2. Modern Primary Batteries, Their Construction, Use, and Maintenance by N. H. Schneider. 54 illustrations, 94 pages, Crown Octavo, S&C Series No. 1, New York, 1910, 1 shilling, 6 pence net. Practical Engineer's Handbook on the Care and Management of Electric Power Plants by N. H. Schneider. 203 illustrations, 274 pages, Crown Octavo, New York, 1906, 5 shillings net. Electrical Circuits and Diagrams, Illustrated and Explained by N. H. Schneider. Octavo, S&C Series Numbers 3 and 4, New York. Number 3, Part 1, 2nd edition. 217 illustrations, 72 pages, New York, 1914, 1 shilling, 6 pence net. Number 4, Part 2, 73 pages, 2nd edition, 1911, 1 shilling, 6 pence net. Electrical Instruments and Testing by N. H. Schneider and J. Hargrave. 4th edition, 133 illustrations. 24 plus 256 pages, Crown Octavo, New York, 1913, 4 shillings 6 net. Experimenting with Induction Coils by N.H. Schneider, 23 illustrations, 73 pages, Crown Octavo, S&C Series No. 5, New York, 1911, 1 shilling 6 net. Study of Electricity for Beginners by N.H. Schneider, 54 illustrations, 88 pages, Crown Octavo, S&C Series No. 6, New York, 1910, 1 shilling 6 net. Wiring Houses for the Electric Light, Low Voltage Battery Systems, 44 illustrations, 86 pages, Crown Octavo, S&C Series No. 25, New York, 1911, 1 shilling 6 net. Low Voltage Electric Lighting with the Storage Battery by N.H. Schneider, 23 illustrations, 85 pages, Crown Octavo, S&C Series No. 26, New York, 1911, 1 shilling 6 net. Dry Batteries, How to Make and Use Them, by a dry battery expert, with additional notes by N.H. Schneider, 30 illustrations, 59 pages, Crown Octavo, S&C Series No. 7, New York, 1910, 1 shilling 6 net. The Diseases of Electrical Machinery by E. Schultz, edited with a preface by Professor S. P. Thompson, 42 illustrations, 84 pages, Crown Octavo, 1904, 2 shillings net. Electricity Simplified by T. O. Sloan, 13th edition, 29 illustrations, 158 pages, Crown Octavo, New York, 1905, 4 shillings 6 net. How to Become a Successful Electrician by T. O. Sloan, 15th edition, 4 illustrations, 202 pages, Crown Octavo, New York, 1906, 4 shillings 6 net. Electricity, Its Theory, Sources, and Applications by J.T. Spragg, 3rd edition, 109 illustrations, 658 pages, Crown Octavo, 1892, 7 shillings 6 net. Telegraphic Connections by C. Tom and W. H. Jones, 20 plates, 59 pages, Oblong Octavo, New York, 1892, 3 shillings 6 net. Dynamo Electric Machinery by Professor S. P. Thompson, 7th edition, Demi Octavo, Finsbury Technical Manual, Volume 1, Continuous Current Machinery, with 4 colored and 30 folding plates, 573 illustrations, 984 pages, 1904, £1 10 shillings net. Volume 2, Alternating Current Machinery, 15 colored and 24 folding plates, 546 illustrations, 900 pages, 1905, £1 10 shillings net. Design of Dynamos, Continuous Currents by Professor S. P. Thompson, 4 colored and 8 folding plates, 243 pages, Demi Octavo, 1903, 12 shillings net. Schedule for Dynamo Design issued with the above, 6 each, 4 shillings per dozen, or 18 shillings per 100 net. Curves of magnetic data for various materials. A reprint on transparent paper for office use of Plate 1 from Dynamo Electric Machinery and measuring 25 inches by 16 inches, 7 net. Electrical Tables and Memoranda by Professor S. P. Thompson, 2nd edition, 15 illustrations, 8 plus 136 pages, Oblong sexagesimo quarto, Waistcoat pocket size, leather, 1913, 1 shilling net. The same in celluloid case, 1 shilling 6 net. Elements of Electroplating by J.T. Spragg, Crown Octavo, 72 pages, 2 illustrations, 1914, S&C Series No. 44, 1 shilling 6 net. Postage 2 pence. The Electromagnet by C. R. Underhill, 67 illustrations, 159 pages, Crown Octavo, New York, 1903, 6 shillings 6 net. Practical Guide to the Testing of Insulated Wires and Cables by H. L. Webb, 5th edition, 38 illustrations, 118 pages, Crown Octavo, New York, 1902. 4 shillings 6 net. Wiring Rules with extracts from the Board of Trade Regulations and the Home Office Regulations for Factories and Workshops. Issued by the Institution of Electrical Engineers. 6th edition, 42 pages, 8vo, sewed. 1911, 6 net. Foreign Exchange. English prices with Russian equivalents, at 14 rates of exchange. English prices per pound with equivalents in rubles and kopecks per pud. By A. Adiaswich. 182 pages. Foolscap tricesimo secondo. 1 shilling net. English prices with German equivalents. At 7 rates of exchange. English prices per pound, with equivalents in marks per kilogram. By St. Koksarowski. 95 pages. Foolscap. Tricesimo secondo. 1 shilling net. English prices with Spanish equivalents. At 7 rates of exchange. English prices per pound, with equivalents in pesetas per kilogram. By S. Lambert. 95 pages. Tricesimo secondo. 1 shilling net. English prices with French equivalents. At 7 rates of exchange. English prices per pound to francs per kilogram. By H. P. McCartney. 97 pages. Tricesimo secondo. 1 shilling net. Principles of Foreign Exchange by E. Matheson. 4th edition. 54 pages. 8vo, sewed. 1905. 3 net. Gas and Oil Engines. The Theory of the Gas Engine by D. Clerk. Edited by F. E. Adele. 3rd edition, 19 illustrations, 180 pages. 8mo. Boards. New York, 1903. 2 shillings net. Electrical Ignition for Internal Combustion Engines by M. A. Codd. 109 illustrations, 163 pages, Crown 8vo. 1911. 3 shillings net. Design and construction of oil engines, with full directions for erecting, testing, installing, running, and repairing, including descriptions of American and English kerosene oil engines, with an appendix on marine oil engines. By A. H. Goldingham, M.E., M.M., M.A.M., S.M.E. 4th edition. 137 illustrations. 299 pages. New York, 1914. 8 shillings 6 net. Postage, inland, 5 pence, abroad, 10 pence. Gas Engine in Principle and Practice, by A. H. Goldingham. New impression, 107 illustrations. 195 pages, 8vo. New York, 1912. 6 shillings 6 net. Practical Handbook on the Care and Management of Gas Engines, by G. Lickfield. 3rd edition. Square sextodecimo. New York, 1906. 3 shillings 6. Elements of Gas Engine Design by S. A. Moss. 197 pages. 8mo. Boards. 2nd edition. New York, 1907. 2 shillings net. Gas and Petroleum Engines, a Manual for Students and Engineers, by Professor W. Robinson, Finsbury Technical Manual. 3rd edition in preparation. Gas Lighting. Transactions of the Institution of Gas Engineers, edited by Walter T. Dunn, Secretary. Published annually. 8vo. 10 shillings 6 net. Gas Analyst Manual, by J. Abady. 107 illustrations, 576 pages, demi-8vo, 1902, 18 shillings net. Gas Works, Their Arrangement, Construction, Plant, and Machinery, by F. Collier. 31 folding plates, 134 pages, 8vo, 1884, 8 shillings 6 net. Lighting by Acetylene, by F. Dye. 75 illustrations, 200 pages, Crown 8vo, 1902, 6 shillings net. A comparison of the English and French methods of ascertaining the illuminating power of coal gas, by A. J. van Eindhoven. Illustrated, Crown 8vo, 1897, 4 shillings. Gas Lighting and Gas Fitting, by W. P. Gerard. 3rd edition, 190 pages. Octodecimo, boards. New York, 1904, 2 shillings net. A Treatise on the Comparative Commercial Values of Gas, Coals, and Cannels, by D. A. Graham, 3 plates, 100 pages, octavo, 1882, 4 shillings, 6 pence. The Gas Engineer's Laboratory Handbook by J. Hornby, 3rd edition, revised, 70 illustrations, 330 pages, Crown octavo, 1911, 6 shillings net. Electric Gas Lighting by N. H. Schneider, 57 illustrations, 101 pages, Crown octavo, S&C Series No. 8, New York, 1901, 1 shilling, 6 pence net. Historical and Biographical. Extracts from the private letters of the late Sir William Fothergill Cooke, 1836 to 1839, relating to the invention and development of the electric telegraph. Also a memoir by Latimer Clark, edited by F. H. Webb, Secretary of the Institute for Electrical Engineers. Octavo, 1895, 3 shillings. A Chronology of Inland Navigation in Great Britain by H. R. de Salis, Crown octavo, 1897, 4 shillings, 6 pence. A History of Electric Telegraphy to the year 1837 by J. J. Fahey, 35 illustrations, 542 pages, Crown octavo, 1889, 2 shillings net. Life as an Engineer, Its Lights, Shades, and Prospects by J. W. C. Haldane, new edition, 23 plates, 390 pages, Crown octavo, 1910, 5 shillings net. A Cornish Giant, Richard Trevithick, the Father of the Locomotive Engine, by E. K. Harper, 12 illustrations including 2 plates, 60 pages, octavo, sewed, 1913, 1 shilling net. Philip Rice, Inventor of the Telephone, a Biographical Sketch, by Professor S. P. Thompson, octavo, cloth, 1883, 7 shillings, 6 pence. The Development of the Mercurial Air Pump, by Professor S. P. Thompson, 43 illustrations, 37 pages, Royal octavo, sewed, 1888, 1 shilling, 6 pence. Horology. Watch and Clockmaker's Handbook, Dictionary and Guide by F. J. Britton, 11th edition, 450 illustrations, 492 pages, Crown octavo, 1915, 5 shillings net. Prize Essay on the Balance Spring and its Isochronal Adjustments by M. Mish, 7 illustrations, 50 pages, Crown octavo, 1872, 2 shillings, 6 pence. Hydraulics and Hydraulic Machinery. See also Irrigation and Water Supply. Hydraulics with Working Tables by E. S. Belassus, 2nd edition, 160 illustrations, 12 plus 311 pages, octavo, 1911, 12 shillings net. Pumps, Historically, Theoretically, and Practically Considered, by P. R. Borling, 2nd edition, 156 illustrations, 234 pages, Crown octavo, 1895, 7 shillings, 6 pence. Pump Details, by P. R. Borling, 278 illustrations, 211 pages, Crown octavo, 1892, 7 shillings, 6 pence. Pumps and Pump Motors, a Manual for the Use of Hydraulic Engineers, by P. R. Borling, 2 volumes, 261 plates, 369 pages, Royal Quarto, 1895, £1, 10 shillings net. Practical Handbook on Pump Construction by P. R. Borling, 2nd edition, new impression, 9 plates, 8 plus 86 pages, Crown octavo, 1912, 3 shillings, 6 pence net. Water or Hydraulic Motors by P. R. Borling, 206 illustrations, 287 pages, Crown octavo, 1903, 9 shillings. Hydraulic Machinery with an Introduction to Hydraulics by R. G. Blaine, 3rd edition, 307 illustrations, 468 pages, octavo, Finsbury Technical Manual, 1913, 10 shillings, 6 pence net. Practical Hydraulics by T. Box, 15th edition, 8 plates, 88 pages, Crown octavo, 1913, 5 shillings net. Pumping and Water Power by F. A. Bradley, 51 illustrations, 7 plus 118 pages, demi-octavo, 1912, 4 shillings 6 net. Hydraulic, Steam, and Hand Power Lifting and Pressing Machinery by F. Collier, 2nd edition, 88 plates, 211 pages, Imperial Octavo, 1892, 10 shillings 6 net. Pumps and Pumping Machinery by F. Collier, Volume 1, 2nd edition, 53 plates, 212 pages, Octavo, 1892, 10 shillings 6 net. Volume 2, 2nd edition, 48 plates, 169 pages, Octavo, 1900, 10 shillings 6 net. Construction of Horizontal and Vertical Water Wheels by W. Cullen, 2nd edition, 12 plates, quarto, 1871, 5 shillings. Donaldson's Poncelet Turbine and Water Pressure Engine and Pump by W. Donaldson, 2 plates, 8 plus 32 pages, demi-quarto, 1883, 5 shillings. Practical Hydrostatics and Hydrostatic Formulae by E. S. Gould, 27 illustrations, 114 pages. Octodecimo, boards, New York, 1903, 2 shillings net. Hydraulic and Other Tables for Purposes of Sewerage and Water Supply by T. Hennell, 3rd edition, 70 pages, Crown Octavo, 1908, 4 shillings 6 net. Tables for calculating the discharge of water in pipes for water and power supplies, indexed at side for ready reference, by A. E. Silk, 63 pages, Crown Octavo, 1914, 3 shillings 6 net. Simple Hydraulic Formulae by T. W. Stone, 9 plates, 98 pages, Crown Octavo, 1881, 4 shillings. A. B. C. of Hydrodynamics by Lieutenant Colonel R. de Villamil, 48 illustrations, 11 plus 135 pages, demi-octavo, 1912, 6 shillings net. Motion of Liquids by Lieutenant Colonel R. de Villamil, R. English, retired, octavo, 14 plus 210 pages, 83 illustrations, 30 tables, 1914, 7 shillings 6 net. Postage inland 4d, abroad 8d. End of A Short List of Scientific Books published by E. and F. N. Spawn Limited, Part 1. Part 2 of A Short List of Scientific Books published by E. and F. N. Spawn Limited. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Chris Pyle. A Short List of Scientific Books, published by E. and F. N. Spawn Limited, Part 2. Industrial Chemistry and Manufactures. Transactions of the American Institute of Chemical Engineers, issued annually, 30 shillings net per volume. Perfumes and Cosmetics, their preparation and manufacture including the use of synthetics, by G. W. Atkinson, Doctor of Chemistry. Demi-octavo, 32 illustrations, 344 pages, 4th edition, New York, 1915, 21 shillings net, postage inland 5d, abroad 10d. Brewing Calculations, Gauging and Tabulation, by C. H. Bader, 340 pages, sexagesimo quarto, Rhone, Gilt Edges, 1914, 1 shilling 6 net. A pocketbook for chemists, chemical manufacturers, metallurgists, dyers, distillers, etc., by T. Bailey, 7th edition, new impression, 550 pages, Royal Tricesimo Secondo, Rhone, Gilt Edges, 1912, 5 shillings net. Practical Receipts for the Manufacturer, the Mechanic, and for Home Use, by Dr. H. R. Berkeley and W. M. Walker, new impression, 250 pages, demi-octavo, 1912, 5 shillings net. A Treatise on the Manufacture of Soap and Candles, Lubricants and Glycerin, by W. L. Carpenter and H. Leask, 2nd edition, 104 illustrations, 456 pages, Crown Octavo, 1895, 2 shillings 6. A Textbook of Paper Making, by C. F. Cross and E. J. Bevan, new edition in preparation. CBS Standard Units and Standard Paper Tests by C.F. Cross, E.J. Bevan, C. Beadle, and R.W. Sindel. 25 pages, Crown Quarto, 1903, 2 shillings 6pence net. Pyrometry by C.R. Darling. 60 illustrations, 200 pages, Crown Octavo, 1911, 5 shillings net. Soda Fountain Requisites, a practical receipt book for druggists, chemists, etc., by G.H. de Belle. 4th edition, 157 pages, Crown Octavo, New York, 1911, 4 shillings 6pence net. Salt in Cheshire, by Albert F. Calvert, F.C.S., etc., author of Salt Deposits of the World, History of the Salt Union, etc. 200 illustrations, maps and plans, 992 pages, Demi-Octavo, 1914, £1 1 shilling net, postage inland 6pence, abroad 2 shillings 6pence. Spices and How to Know Them by W. M. Gibbs, 47 plates, including 14 in colors, 176 pages, Octavo, New York, 1909, 15 shillings net. The Chemistry of Fire and Fire Prevention by H. and H. Ingle, 45 illustrations, 290 pages, Crown Octavo, 1900, 9 shillings. Ice-Making Machines by M. Ladeau and others, 6th edition, 190 pages, 18mo, boards, New York, 1906, 2 shillings net. Brewing with Raw Grain by T. W. Lovabond, 75 pages, Crown Octavo, 1883, 5 shillings. The Chemistry, Properties, and Tests of Precious Stones by J. Maston, 114 pages, Fool's Cap Sextodecimo, limp leather, gilt top, 1911, 2 shillings 6pence net. Sugar, a handbook for planters and refiners, by the late J. A. R. Newlands and B. E. R. Newlands, 236 illustrations, 876 pages, Octavo, 1909, £1 5 shillings net. Principles of Leather Manufacture by Professor H. R. Proctor, 2nd edition in preparation. Leather Industries Laboratory Handbook of Analytical and Experimental Methods by H. R. Proctor, 2nd edition, 4 plates, 46 illustrations, 450 pages, Octavo, 1908, 18 shillings net. Leather Chemist Pocketbook, a short compendium of analytical methods by Professor H. R. Proctor, assisted by Dr. E. Stiasny and H. Brumwell. 4 illustrations, 14 plus 223 pages, sextodecimo, leather, 1912, 5 shillings net. Theoretical and Practical Ammonia Refrigeration by I. Redwood, 3rd edition, 15 illustrations, 146 pages, square sextodecimo, New York, 1914, 4 shillings 6pence net. Breweries and Maltings by G. Scammell and F. Collier, 2nd edition, 20 plates, 178 pages, Octavo, 1880, 6 shillings net. Factory Glaze for Ceramic Engineers by H. Rombello. Folio, Series A, Leadless Sanitary Glazes, 1908, £2 2 shillings net. Spawn's Encyclopedia of the Industrial Arts. Manufactures and Commercial Products, 2 volumes, 1,500 illustrations, 2,100 pages, Super Royal Octavo, 1882, £2 2 shillings net. Tables for the Quantitative Estimation of the Sugars by E. Wine and W. Frew, Crown Octavo, 1896, 6 shillings. The Puring, Baiting, and Drenching of Skins by J. T. Wood, 33 illustrations, 15 plus 300 pages, Octavo, 1912, 12 shillings 6pence net. Workshop Receipts for the Use of Manufacturers, Mechanics, and Scientific Amateurs, New and Thoroughly Revised Edition, Crown Octavo, 1909, 3 shillings each net. Volume 1, Acetylene Lighting to Drying, 223 illustrations, 532 pages. Volume 2, Dyeing to Japanning, 259 illustrations, 540 pages. Volume 3, Jointing Pipes to Pumps, 256 illustrations, 528 pages. Volume 4, Rainwater Separators to Wire Rope Splicing, 321 illustrations, 540 pages. Practical Handbook on the Distillation of Alcohol from Farm Products by F.B. Wright. Second edition, 60 illustrations, 271 pages. Crown Octavo, New York, 1913. 4 shillings, 6 net. Interest Tables. The wide-range dividend and interest calculator, showing at a glance the percentage on any sum from £1 to £10,000 at any interest from 1% to 12.5%, proceeding by quarter percent. By A. Stevens, 100 pages. Super Royal Octavo, 6 shillings net. Quarter Morocco, cloth sides, 7 shillings 6 net. The wide-range income tax calculator, showing at a glance the tax on any sum from 1 shilling to £10,000 at the rate of 9 pence, 1 shilling, and 1 shilling 2 pence. In the pound. By A. Stevens, on folding card. Imperial Octavo, 1 shilling net. Irrigation. Irrigation Works by E. S. Belassus. 37 illustrations, 8 plus 174 pages, Octavo, 1913, 8 shillings net. Punjab Rivers and Works by E. S. Belassus, second edition, 47 illustrations, 65 pages, folio, 1912, 8 shillings net. Irrigation Pocketbook by R. B. Buckley, second edition, 80 illustrations, 8 plus 475 pages. Crown Octavo, leather, gilt edges, 1914, 5 shillings net. The Design of Channels for Irrigation and Drainage by R. B. Buckley, 22 diagrams, 56 pages. Crown Octavo, 1911, 2 shillings net. The Irrigation Works of India by R. B. Buckley, second edition, with colored maps and plans, 336 pages. Quarto, cloth, 1905, £2, 2 shillings net. Irrigated India by the Honorable Alfred Deakin, with map, 322 pages, Octavo, 1893, 8 shillings 6 pence. Indian Storage Reservoirs with Earthen Dams by W. L. Strange, second edition, 16 plates, 59 illustrations. 24 plus 442 pages, Octavo, 1913, 21 shillings net. The Irrigation of Mesopotamia by Sir W. Wilcox, 2 volumes, 46 plates, 136 pages. Text, Super Royal Octavo, plates folio, 1911, £1 net. Egyptian Irrigation by Sir W. Wilcox and J. I. Craig, in 2 volumes, 3rd edition, 81 plates, 183 illustrations, 900 pages. Super Royal Octavo, 1913, 42 shillings net. The Nile Reservoir Dam at Aswan and After by Sir W. Wilcox, 2nd edition, 13 plates, 35 pages. Super Royal Octavo, 1903, 3 shillings net. The Aswan Reservoir in Lake Morris by Sir W. Wilcox, with text in English, French, and Arabic. 5 plates, 116 pages. Super Royal Octavo, 1904, 3 shillings net. The Nile in 1904 by Sir W. Wilcox, 30 plates, 200 pages. Super Royal Octavo, 1904, 5 shillings net. Logarithm Tables. Aldham's Pocket Folding Mathematical Tables, 4-figure logarithms and anti-logarithms, natural sines, tangents, cotangents, cosines, chords, and radians for all angles from 1 to 90 degrees, and decimalizer table for weights and money. On folding card, 4 pence net. 20 copies, 6 shillings net. Tables of 7-figure logarithms of the natural numbers from 1 to 108,000 by C. Babbage. Stereotype edition, 224 pages, medium octavo, 5 shillings net. 4-place tables of logarithms and trigonometric functions by E. V. Huntington. 9,000, 34 pages, square octavo, limp buckram, with cut lateral index. New York, 1911. 3 shillings net. Short Logarithmic and Other Tables by W. C. Unwin. 4th edition, small quarto, 3 shillings. Logarithmic Land Measurement by J. Wallace. 32 pages, Royal Octavo, 1910, 5 shillings net. ABC 5-figure Logarithms with Tables for Chemists by C. J. Woodward. Crown Octavo, 2 shillings 6 net. ABC 5-figure Logarithms for General Use with Lateral Index for Ready Reference by C. J. Woodward, 2nd edition with cut lateral index, 116 pages, duodecimo, limp leather, 3 shillings net. Marine Engineering and Naval Architecture. Marine Propellers by S. W. Barnaby, 5th edition, 5 plates, 56 illustrations, 185 pages, demi-octavo, 1908, 10 shillings 6 net. The Suction Caused by Ships and the Olympic Hawk Collision by E. S. Belassus. 1 chart and 5 illustrations and text, 26 pages, octavo, sewed. 1912, 1 shilling net. Yachting Hints. Tables and Memoranda by A. C. Franklin. Whisket Pocket Size, 103 pages, sexagesimo quarto. Roan, Gilt Edges, 1 shilling net. Steamship Coefficients, Speeds and Powers by C. F. A. Fife. 31 plates, 280 pages, foolscap octavo, leather, 1907, 10 shillings 6 net. How to Build a Speed Launch by E. W. Graff. 14 plates, 32 pages, quarto, New York, 1903, 4 shillings 6 net. Steamships and Their Machinery from First to Last by J. W. C. Haldane. 120 illustrations, 532 pages, octavo, 1893, 15 shillings. Structural Design of Warships by William Hovgard. Professor, Naval Design, Massachusetts Institute of Technology. Super Royal Octavo, with 23 tables, 6 plates, and 186 illustrations, 384 pages, 1915. 21 shillings net. Postage, inland, 6 Abroad, 1 shilling, 2 Tables for Constructing Ship's Lines by A. Hogg. 3rd edition, 3 plates, 20 pages, octavo, sewed, 1911, 3 shillings net. Tabulated weights of angle, T, bulb, round, square, and flat iron and steel for the use of naval architects, shipbuilders, etc. by C. H. Jordan. 6th edition, 640 pages, Royal Tricesimo Secondo, leather, gilt edges, 1909, 7 shillings 6 net. Particulars of Dry Docks, Wet Docks, Wharves, etc. on the River Thames. Compiled by C. H. Jordan. 2nd edition, 7 colored charts, 103 pages, oblong octavo, 1904, 2 shillings 6 net. Marine Transport of Petroleum by H. Little. 66 illustrations, 263 pages, crown octavo, 1890, 10 shillings 6 Questions and Answers for Marine Engineers, with a practical treatise on breakdowns at sea by T. Lucas, 12 folding plates, 515 pages, gilt edges, crown octavo, New York, 1902, 8 shillings net. How to Build a Motor Launch by C. D. Moore. 49 illustrations, 42 pages, quarto, New York, 1904, 4 shillings 6 net. Reed's Engineer's Handbook to the Board of Trade Examinations for Certificates of Competency as First and Second Class Engineers, 19th edition, 37 plates, 358 illustrations, 696 pages, octavo, 4 shillings net. Key to Reed's Handbook, 7 shillings 6 net. Reed's Marine Boilers, 3rd edition, 79 illustrations, 258 pages, Crown octavo, 1905, 4 shillings 6 net. Reed's Useful Hints to Seagoing Engineers, 4th edition, 8 plates, 50 illustrations, 312 pages, Crown octavo, 1903, 3 shillings 6 net. How to Build a 3-Horse Power Launch Engine by E.W. Roberts, 14 plates, 66 pages, folio, New York, 1901, 10 shillings 6 net. Materials. Practical Treatise on the Strength of Materials by T. Box, 4th edition, 27 plates, 536 pages, octavo, 1902, 12 shillings 6 net. Solid Bitumens by S. F. Peckham, 23 illustrations, 324 pages, octavo, New York, 1909, £1 1 shilling net. Lubricants, Oils, and Greases by I. I. Redwood, 3 plates, 9 plus 54 pages, octavo, 1898, 6 shillings 6 net. Practical Treatise on Mineral Oils and Their Byproducts by L. L. Redwood, 76 illustrations, 336 pages, octavo, 1914, 10 shillings 6 net. Silico-calcareous sandstones, or building stones from quartz, sand, and lime, by E. Stoeffler. 5 plates, octavo, sewed, 1901, 4 shillings net. Proceedings of the 5th Congress, International Association for Testing Materials, English edition, 189 illustrations, 549 pages, octavo, 1910, 18 shillings net. Proceedings of the 6th Congress, 1913, 30 shillings net. Mathematics. Imaginary Quantities by M. Argand, translated by Professor Hardy, octodecimo, boards, New York, 1881, 2 shillings net. Textbook of Practical Solid Geometry by E. H. D. V. Atkinson, revised by Major B. R. Ward, R.E., 2nd edition, 17 plates, 134 pages, octavo, 1913, 7 shillings and 6 . Quick and Easy Methods of Calculating and the Theory and Use of the Slide Rule by R. G. Blaine, 4th edition, 6 illustrations, 12 plus 152 pages, sextodecimo, 1912, 2 shillings 6 net. Symbolic Algebra, or the Algebra of Algebraic Numbers, by W. Kane, 12 illustrations, 131 pages, octodecimo, boards, New York, 1884, 2 shillings net. Nautical Astronomy, by J. H. Colvin, 127 pages, Crown octavo, 1901, 2 shillings 6 net. Chemical Problems by J. C. Foy, 4th edition, 141 pages, octodecimo, boards, New York, 1898, 2 shillings net. Primer of the Calculus by E. S. Gould, 5th edition, 24 illustrations, 122 pages, octodecimo, boards, New York, 1912, 2 shillings net. Elementary Treatise on the Calculus for Engineering Students by J. Graham, 4th edition, 116 illustrations, 12 plus 355 pages, Crown octavo, 1914, 5 shillings net. Manual of the Slide Rule by F. A. Halsey, 4th edition, 31 illustrations, 84 pages, octodecimo, boards, New York, 1907, 2 shillings net. Reform in Chemical and Physical Calculations by C. J. T. Hansen, quarto, 1897, 6 shillings 6 net. Algebra Self-Taught by P. Higgs, 3rd edition, 104 pages, Crown octavo, 1903, 2 shillings 6 A textbook on graphic statics by C.W. Malcolm, 155 illustrations, 316 pages, octavo, New York 1909, 12 shillings 6 net. Galvanic Circuit Investigated Mathematically by G.S. Ohm, translated by William Francis, 269 pages, octodecimo, boards, 2nd edition, New York 1905, 2 shillings net. Elementary Practical Mathematics by M.T. Ormsby, 2nd edition, 128 illustrations, 12 plus 410 pages, medium octavo, 1911, 5 shillings net. Elements of Graphic Statics by K. Van Ott, translated by G.S. Clark, 95 illustrations, 128 pages, crown octavo, 1901, 5 shillings. Figure of the Earth by F.C. Roberts, 2 illustrations, 95 pages, octodecimo, boards, New York, 1885, 2 shillings net. Arithmetic of Electricity by T.O.C. Sloan, 20th edition, 5 illustrations, 162 pages, crown octavo, New York 1909, 4 shillings 6 net. Graphic Method for Solving Certain Questions in Arithmetic or Algebra by G. L. Vose, 2nd edition, 28 illustrations, 62 pages, octodecimo, boards, New York 1902, 2 shillings net. Problems in Electricity, a graduated collection comprising all branches of electrical science by R. Weber, translated from the French by E. A. O'Keefe, 34 illustrations, 366 pages, crown octavo, 3rd edition, 1902, 7 shillings 6 net. Mechanical Engineering, Steam Engines and Boilers, etc. Engineer's Sketchbook of Mechanical Movements by T. W. Barber, 5th edition, 3,000 illustrations, 355 pages, octavo, 1906, 10 shillings 6 net. The Repair and Maintenance of Machinery by T. W. Barber, 417 illustrations, 476 pages, octavo, 1895, 10 shillings 6. The Science of Burning Liquid Fuel by William Newton Best, 100 illustrations, 159 pages, octavo, 1913, 9 shillings net. Practical Treatise on Mill Gearing by T. Box, 5th edition. 11 plates, 128 pages, crown octavo, 1892, 7 shillings 6. The Mechanical Engineer's Price Book, edited by Geoffrey Brooks. AMI Mech E. 182 pages, pocket size, 6.5 by 3.25 by 1/2 inch. Leather cloth with rounded corners, 2nd edition, 1914, 4 shillings net. Postage, 3 pence. Safety Valves by R. H. Buell, 3rd edition, 20 illustrations, 100 pages, octodecimo, boards, New York 1898, 2 shillings net. Machine Design by Professor W. L. Cathcart. Part 1, Fastenings, 123 illustrations, 291 pages, demi-octavo, New York 1903, 12 shillings 6 net. Chimney Design Theory by W. W. Christie, 2nd edition, 54 illustrations, 192 pages, crown octavo, New York 1902, 12 shillings 6 net. Furnace Draft, its production by Mechanical Methods by W. W. Christie, 5 illustrations, 80 pages, octodecimo, boards, 2nd edition, New York 1906, 2 shillings net. The Stoker's Catechism by W. J. Connor, 63 pages, limp, 1914, 1 shilling net. Treatise on the Use of Belting for the Transmission of Power by J. H. Cooper, 5th edition, 94 illustrations, 399 pages, demi-octavo, New York 1901, 12 shillings 6 net. The Steam Engine Considered as a Thermodynamic Machine by J. T. Cotterill, 3rd edition, 39 diagrams, 444 pages, octavo. 1896, 15 shillings. Fireman's Guide, a handbook on the care of boilers, by K.P. Dahlstrom. 11th edition, foolscap octavo, S&C series number 16, New York, 1906, 1 shilling 6 net. Belt Driving, by G. Halliday. 3 folding plates, 100 pages, octavo, 1894, 3 shillings 6. Worm and Spiral Gearing, by F. A. Halsey. 13 plates, 85 pages, octodecimo, boards, 2nd edition, New York, 1911, 2 shillings net. Commercial Efficiency of Steam Boilers, by A. Hansen. Large octavo, sewed, 1898, 6. Corliss Engine, by J. T. Hinthorn. 3rd edition, 23 illustrations, 95 pages, Crown octavo, S&C series, number 23, New York, 1910, 1 shilling 6 net. Liquid Fuel for Mechanical and Industrial Purposes, by E. A. Brayley Hodgetts. 106 illustrations, 129 pages, octavo, 1890, 5 shillings. Elementary Textbook on Steam Engines and Boilers, by J. H. Keneally. 4th edition, 106 illustrations, 259 pages, octavo, New York, 1903, 8 shillings 6 net. Centrifugal Fans, by J. H. Keneally. 33 illustrations, 206 pages, foolscap octavo, leather, New York, 1905, 12 shillings 6 net. Mechanical Draft, by J. H. Keneally. 27 original tables and 13 plates, 142 pages, Crown octavo, New York, 1906, 8 shillings 6 net. The ABC of the Steam Engine, with a description of the automatic governor, by J. P. Lisk. 6 plates, octavo, S&C series number 17, New York, 1910, 1 shilling 6 net. Valve Setting Record Book, by P. A. Lowe. Octavo, boards, 1 shilling 6. The Layout of Corliss Valve Gears, by S. A. Moss. 2nd edition, 3 plates, 108 pages. Octodecimo, boards. New York, 1906, 2 shillings net. Steam Boilers and Their Management and Working, by J. Peedy. 5th edition, 35 illustrations, 230 pages, Crown octavo, 1906, 4 shillings 6 net. Treatise on the Richard Steam Engine Indicator, by C. T. Porter. 6th edition, 3 plates and 73 diagrams, 285 pages, octavo, 1902, 9 shillings. Practical Treatise on the Steam Engine, by A. Rigg. 2nd edition, 103 plates, 378 pages, demi-octavo, 1894, £1 5 shillings. Power and Its Transmission, a Practical Handbook for the Factory and Works Manager, by T. A. Smith. 76 pages, foolscap octavo, 1910, 2 shillings net. Slide Valves Simply Explained, by W. J. Tinnett. Revised by J. H. Keneally. 41 illustrations, 83 pages, Crown octavo, New York, 1899, 2 shillings net. Shaft Governors, by W. Trinks and C. Husum. 27 illustrations, 97 pages, octodecimo, boards. New York, 1906, 2 shillings net. Treatise on the Design and Construction of Mill Buildings, by H. G. Terrell. 652 illustrations, 490 pages, octavo, New York, 1911, 17 shillings net. Slide and Piston Valve Geared Steam Engines, by W. H. Euland. 47 plates and 314 illustrations, 155 pages, 2 volumes, folio, half Morocco. 1882, £1 16 shillings. How to Run Engines and Boilers, by E. P. Watson. 6th edition. 31 illustrations, 160 pages. Octavo, New York, 1913, 4 shillings 6 net. Position diagram of cylinder with Meyer cutoff, by W. H. Waitman, on card, New York, 1 shilling net. Practical Method of Designing Slide Valve Gearing, by E. J. Welch, 69 illustrations, 283 pages, Crown octavo, 1890, 6 shillings. Elements of Mechanics, by T. W. Wright, 8th edition, 215 illustrations, 382 pages, octavo, New York, 1909, 10 shillings, 6 net. Metallurgy, Iron and Steel Manufacture. Life of Railway Axles, by T. Andrews, octavo, sewed, 1895, 1 shilling. Microscopic Internal Flaws in Steel Rails and Propeller Shafts, by T. Andrews, octavo, sewed, 1896, 1 shilling. Microscopic Internal Flaws Inducing Fracture in Steel, by T. Andrews, octavo, sewed, 1896, 2 shilling. Practical Alloying, a compendium of alloys and processes for brass founders, metal workers, and engineers, by John F. Buchanan, 41 illustrations, 205 pages, octavo, New York, 1911, 10 shillings, 6 net. Brass Founders Alloys, by J. F. Buchanan, 23 illustrations, 8 plus 129 pages, Crown octavo, 1905, 4 shillings, 6 net. The Molder's Dictionary, Foundry Nomenclature, by J. F. Buchanan. New impression, 26 illustrations, 8 plus 225 pages, Crown octavo, 1912, 3 shillings net. American Standard Specifications for Steel, by A. L. Colby, 2nd edition, revised, 103 pages, Crown octavo, New York, 1902, 5 shillings net. Galvanized Iron, Its Manufacture and Uses, by J. Davies, 139 pages, octavo, 1914, net. Management of Steel, by G. Eade, 7th edition, 216 pages, Crown octavo, 1903, 5 shillings. The Frodair Handbook for Iron Founders, 160 pages, 12mo, 1910, 2 shillings net. Manufacture of Iron and Steel, by H. R. Hearson, 21 illustrations, 7 plus 103 pages, octavo, 1912, 4 shillings, 6 net. Cupola Furnace, by E. Kirk, 3rd edition, 106 illustrations, 484 pages, octavo, New York, 1910, 15 shillings net. Practical Notes on Pipe Bounding, by J. W. McFarlane, 15 plates, 148 pages, octavo, 1888, 12 shillings, 6. Atlas of Designs Concerning Blast Furnace Practice, by M. A. Pavlov, 127 plates, 14 inches by 10½ inches, oblong, sewed, 1902, 1 pound, 1 shilling net. Album of Drawings Relating to the Manufacture of Open Hearth Steel, by M. A. Pavlov, Part 1, Open Hearth Furnaces, 52 plates, 14 inches by 10½ inches, oblong folio, in portfolio, 1904, 12 shillings net. Metallurgy Applied to Siderurgic Products, by H. Savoya, translated by R. G. Corbett, 94 illustrations, 180 pages, Crown octavo, 1910, 4 shillings, 6 net. Modern Foundry Practice, by J. Sharp, 2nd edition, new impression, 272 illustrations, 759 pages, octavo, 1911, 1 pound, 1 shilling net. Roll Turning for Sections in Steel and Iron, by A. Spencer, 2nd edition, 78 plates, quarto, 1894, 1 pound, 10 shillings. Metric Tables. French Measure and English Equivalents, by J. Brooke, 2nd edition, 80 pages, Foolscap Tricesimo Secondo, Rhone, 1 shilling net. A Dictionary of Metric and Other Useful Measures, by L. Clark, 113 pages, octavo, 6 shillings. English Weights with Their Equivalents in Kilograms by F.W.A. Logan, 96 pages. Foolscap Tricesimo Secondo, Roan, 1 shilling net. Metric Weights with English Equivalents by H.P. McCartney, 84 pages. Foolscap Tricesimo Secondo, Roan, 1 shilling net. Metric Tables by Sir G.L. Molesworth, 4th edition, 95 pages. Royal Tricesimo Secondo, 1909, 2 shillings net. Metric English and English Metric Lengths by G.A. Rossetti, 12 plus 80 pages. Oblong Tricesimo Secondo, 1 shilling net, giving equivalents in millimeters to 5 significant figures of all English lengths, from 1/64th of an inch to 10 feet, advancing by 64ths of an inch, and equivalents to the nearest 64th of an inch of all metric lengths, from 1 to 3,200 millimeters, advancing by millimeters. Tables for setting out curves from 200 meters to 4,000 meters by tangential angles by H. Williamson, 4 illustrations, 60 pages. Octodecimo, 2 shillings net. Mineralogy and Mining. Rock Blasting by G.G. Andre, 12 plates and 56 illustrations and text, 202 pages. Octavo, 1878, 5 shillings. Practical Treatise on Hydraulic Mining in California by A. J. Bowie, Jr., 11th edition, 73 illustrations, 313 pages. Royal Octavo, New York, 1910, 1 pound 1 shilling net. Tables for Determination of Common Rocks by O. Bowles, 64 pages. Octodecimo, Boards, New York, 1910, 2 shillings net. Fire Assaying by E. W. Buskett, 69 illustrations, 105 pages. Crown Octavo, New York, 1907, 4 shillings 6pence net. 10. Describing the Chief Methods of Mining, Dressing, etc. by A. G. Charlton, 15 plates, 83 pages. Crown Octavo, 1884, 12 shillings 6pence. Gold Mining and Milling in Western Australia, with Notes upon Telluride Treatment, Costs in Mining Practice in Other Fields, by A. G. Charlton, 82 illustrations and numerous plans and tables, 648 pages. Super Royal Octavo, 1903, 12 shillings 6pence net. Miner's Geology and Prospector's Guide by G. A. Corder, 29 plates, 224 pages. Crown Octavo, 1914, 5 shillings net. Blasting of Rock in Mines, Quarries, Tunnels, etc. by A. W. and Z. W. Daw, 2nd edition, 90 illustrations, 316 pages. Demi-Octavo, 1909, 15 shillings net. Gold Dredging by C. T. Earl, 17 maps, 78 illustrations, 16 plus 208 pages. Octavo, 1913, 20 shillings net. Handbook of Mineralogy, Determination and Description of Minerals Found in the United States by G. C. Foy, 180 pages. Octodecimo, Boards, 5th edition, New York, 1907, 2 shillings net. Our Coal Resources at the End of the 19th Century by Professor E. Hull, 157 pages. Demi-Octavo, 1897, 6 shillings. Hydraulic Gold Miner's Manual by T. S. G. Kirkpatrick, 2nd edition, 12 illustrations, 46 pages. Crown Octavo, 1897, 4 shillings. Economic Mining by C. G. W. Locke, 175 illustrations, 680 pages. Octavo, 1895, 10 shillings 6pence net. Gold Milling, Principles and Practice by C. G. W. Locke, 200 illustrations, 850 pages. Demi-Octavo, 1901, 1 pound 1 shilling net. Mining and Ore Dressing Machinery by C. G. W. Locke, 639 illustrations, 466 pages. Super Royal Quarto, 1890, 1 pound 5 shillings. Miner's Pocketbook by C. G. W. Locke, 5th edition, 233 illustrations, 624 pages. Foolscap octavo, leather gilt edges, 1908, 10 shillings, 6pence net. Chemistry, Properties and Tests of Precious Stones by J. Maston, 114 pages, foolscap sextodecimo, limp leather gilt top, 1911, 2 shillings, 6pence net. Tests for Ores, Minerals, and Metals of Commercial Value by R. L. McMahon, 152 pages, duodecimo, New York, 1907, 5 shillings, 6pence net. Practical Handbook for the Working Miner and Prospector and the Mining Investor by J. A. Miller, 34 illustrations, 234 pages, Crown octavo, 1897, 7 shillings, 6pence. Theory and Practice of Centrifugal Ventilating Machines by D. Merg, 7 illustrations, 81 pages, octavo, 1883, 5 shillings. Examples of Coal Mining Plant by J. Poovey Harper, 2nd edition, 40 plates, 26 inches by 20 inches, 1895, 4 pounds, 4 shillings net. Examples of Coal Mining Plant, 2nd series, by J. Poovey Harper, 10 plates, 26 inches by 20 inches, 1902, 1 pound, 12 shillings, 6pence net. Models and Model Making. How to Build a Model Yacht by H. Fisher, 45 illustrations, 50 pages, quarto, New York, 1902, 4 shillings, 6pence net. Model Engines and Small Boats by N. M. Hopkins, 50 illustrations, 8 plus 74 pages, Crown octavo, New York, 1898, 5 shillings, 6pence net. Theory and Practice of Model Airplaning by V. E. Johnson, 61 illustrations, 16 plus 148 pages, Crown octavo, 1910, 3 shillings, 6pence net. The Model Vaudeville Theater by N. H. Schneider, 34 illustrations, 90 pages, Crown octavo, S&C Series number 15, New York, 1910, 1 shilling, 6pence net. Electric Toy Making by T. O. Sloan, 20th edition, 70 illustrations, 183 pages, Crown octavo, New York, 1914, 4 shillings, 6pence net. Model Steam Engine Design by R. M. de Vignier, 34 illustrations, 94 pages, Crown octavo, limp, S&C Series number 9, New York, 1907, 1 shilling, 6pence net. Small Engines and Boilers by E. P. Watson, 33 illustrations, 8 plus 108 pages, Crown octavo, New York, 1899, 5 shillings, 6pence net. Organization, Accounts, Contracts, and Management. Organization of Gold Mining Business, with specimens of the Departmental Report Books and the Account Books, by Nicole Brown, 2nd edition, 220 pages, Foolscap folio, 1903, 1 pound, 5 shillings net. Cost-Keeping and Management Engineering, a treatise for those engaged in engineering construction, by H. P. Gillette and R. T. Dana, 184 illustrations, 346 pages, octavo, New York, 1909, 15 shillings net. Handbook on Railway Stores Management by W. O. Kempthorne, 268 pages, demi-octavo, 1907, 10 shillings, 6pence net. Depreciation of Factories, Municipal and Industrial Undertakings and Their Valuation by E. Matheson, 4th edition, 230 pages, octavo, 1910, 10 shillings, 6pence net. Aid Book to Engineering Enterprise by E. Matheson, 3rd edition, 916 pages, octavo, Buckram, 1898, 1 pound, 4 shillings. Office Management, a Handbook for Architects and Civil Engineers, by W. K. Perry, new edition in preparation. Commercial Organization of Engineering Factories by H. Spencer, 92 illustrations, 221 pages, octavo, 1914, 10 shillings, 6pence net. Physics, Color, Heat, and Experimental Science. The Entropy Diagram and Its Applications by R. G. Bulvin, 38 illustrations, 82 pages, demi-octavo, 1914, 5 shillings. Physical Problems and Their Solution by A. Burgoyne. 224 pages, 18mo, boards, 2nd edition, New York 1904, 2 shillings net. Heat for Engineers by C.R. Darling, 2nd edition, 110 illustrations, 430 pages, 8vo, Finsbury Technical Manual, 1912, 12 shillings, 6pence net. Boehme and Specific Gravity Tables for Liquids Lighter Than Water by Nat E. Freeman, 27 pages, Crown 8vo, 1914, 2 shillings, 6pence net. Post free, 2 shillings, 8pence. Engineering Thermodynamics by C.F. Hirschfeld, 22 illustrations, 157 pages, 18mo, boards, 2nd edition, New York 1910, 2 shillings net. Liquid Drops and Globules, Their Formation and Movements by Charles R. Darling. Lecture at the City and Guilds Technical College, Finsbury, being 3 lectures delivered to popular audiences. Crown 8vo, 10 plus 84 pages, 43 illustrations, 1914, 2 shillings, 6pence net. Postage, 3pence. The Dynamics of Surfaces, An Introduction to the Study of Biological Surface Phenomena by Professor, Dr. of Medicine, Leonore Michaelis, Privet Docent in the University of Berlin, translated by W. H. Perkins, Demi 8vo, 118 pages, 8 illustrations, 1914, 4 shillings net. Postage, inland, 3pence. Abroad, 6pence. Experimental Science, Elementary, Practical, and Experimental Physics by G. M. Hopkins, 27th edition, 920 illustrations, 1,100 pages, 8vo, New York 1911, £1, 1 shilling net. Reform in Chemical and Physical Calculations by C. J. T. Hansen, Demi 8vo, 1897, 6 shillings, 6pence net. The Gyroscope, An Experimental Study by V. E. Johnson, 34 illustrations, 40 pages, Crown 8vo, S&C Series No. 22, 1911, 1 shilling, 6pence net. The Gyroscope by F. J. B. Cordero, author of The Atmosphere, etc., etc., 19 illustrations, 8 plus 105 pages, Crown 8vo, New York 1913, 6 shillings, 6pence net. Introduction to the Study of Color Phenomena by J. W. Lovibond, 10 colored plates, 48 pages, 8vo, 1905, 5 shillings net. The Energy Chart, Practical Application to Reciprocating Steam Engines by Captain H. R. Sankey, 157 illustrations, 170 pages, 8vo, 1907, 7 shillings, 6pence net. Price Books. The Mechanical Engineer's Price Book by G. Brooks, 200 pages, pocket size, 6½ inches by 3 3/4 inches by ½ inch thick. Leather cloth with rounded corners, 4 shillings net. Approximate Estimates by T. E. Coleman, 4th edition, 481 pages, oblong, trisesimo secondo, leather, 1914, 5 shillings net. The Civil Engineer's Cost Book by Major T. E. Coleman, 12 plus 289 pages, pocket size, 6½ inches by 3 3/4 inches, leather cloth, 1912, 5 shillings net. Railway Stores Price Book by W. O. Kempthorne, 290 pages, Demi 8vo, 1909, 10 shillings, 6pence net. Spawn's Architects and Builders Pocket Price Book, edited by Clyde Young, revised by Stanford M. Brooks. 41st edition, 8 plus 308 pages, green leather cloth, published annually. Size 6½ inches by 3 3/4 inches by ½ inch thick. 2 shillings, 6pence net. Handbook of Cost Data for Contractors and Engineers by H. P. Gillette, 1,854 pages, Crown 8vo, leather, gilt edges, 2nd edition, New York 1914, £1, 1 shilling net. Railway Engineering and Management, Practical Hints to Young Engineers Employed on Indian Railways by A. W. C. Addis, 14 illustrations, 154 pages. Duodecimo, 1910, 3 shillings 6 net. Up-to-date Air Brake Catechism by R.H. Blackall, 27th edition, 5-color plates, 96 illustrations, 305 pages, Crown octavo, New York 1914, 8 shillings 6 net. Prevention of Railroad Accidents or Safety in Railroading by George Bradshaw, 64 illustrations, 173 pages, Square Crown octavo, New York 1912, 2 shillings 6 net. Simple and Automatic Vacuum Brakes by C. Briggs, GNR, 11 plates, octavo, 1892, 4 shillings. Permanent Way Material, Plate Laying and Points and Crossings, with a few remarks on signaling and interlocking, by W. H. Cole, late Deputy Manager, East Bengal and Northwest State Railways, PWD, India. Crown octavo, 288 pages, 44 illustrations, 7th edition, 1915, 2 shillings 6 net. Postage inland, 3 pence, abroad 6 pence. Railway Engineer's Field Book by Major G. R. Hearn, R.E., Associate of the Institute for Civil Engineers, and A. G. Watson, C.E. Duodecimo, leather, 230 pages, 33 illustrations, 1914, 21 shillings net. Postage, inland 3 pence, abroad 6 pence. Statistical tables of the working of railways in various countries up to the year 1904, by J. D. Diacomitis. 2nd edition, 84 pages, small folio, sewed, 1906, 16 shillings net. Locomotive Breakdowns, Emergencies and Their Remedies by George L. Fowler, M.E., and W. W. Wood. 7th edition, 92 illustrations, 266 pages, duodecimo, New York 1911, 4 shillings 6 net. Permanent Way Diagrams by F. H. Frere, mounted on linen and cloth covers, 1908, 3 shillings net. Formulae for Railway Crossings and Switches by J. Glover, 9 illustrations, 28 pages, Royal Tricesimo Secondo, 2 shillings 6 pence. Setting Out of Tube Railways by G. M. Halden, 9 plates, 46 illustrations, 68 pages, Crown quarto, 1914, 10 shillings, 6 pence net. Railway Engineering, Mechanical and Electrical by J. W. C. Haldane, new edition, 141 illustrations, 20 plus 583 pages, octavo, 1908, 15 shillings. The Construction of the Modern Locomotive by G. Hughes, 300 illustrations, 261 pages, octavo, 1894, 9 shillings. Practical Hints for Light Railways at Home and Abroad by F. R. Johnson, 6 plates, 31 pages, Crown octavo, 1896, 2 shillings 6 pence. Handbook on Railway Stores Management by W. O. Kempthorne, 268 pages, demi-octavo, 1907, 10 shillings 6 pence net. Railway Stores Price Book by W. O. Kempthorne, 490 pages, demi-octavo, 1909, 10 shillings 6 pence net. Railroad Location Surveys and Estimates by F. Lavis, 68 illustrations, 270 pages, octavo, New York 1906, 12 shillings 6 pence net. Pioneering by F. Shelford, 14 illustrations, 88 pages, Crown octavo, 1909, 3 shillings net. Handbook on Railway Surveying for Students and Junior Engineers by B. Stewart, 55 illustrations, 98 pages, Crown octavo, 1914, 2 shillings 6 pence net. Modern British Locomotives by A. T. Taylor, 100 diagrams of principal dimensions, 118 pages, oblong octavo, 2nd edition, 1914, 4 shillings 6 pence net. Locomotive Slide Valve Setting by C. E. Tully, illustrated, octodecimo, 1 shilling net. The Railway Goods Station by F. W. West, 23 illustrations, 15 plus 192 pages, Crown octavo, 1912, 4 shillings 6 pence net. The Walshart Locomotive Valve Gear by W. W. Wood, 4 plates and set of movable cardboard working models of the valves. 193 pages, Crown Octavo, 3rd edition, New York, 1913. 6 shillings, 6pence net. The Westinghouse E.T. Air Brake Instruction Pocketbook by W. W. Wood. 48 illustrations including many-colored plates. 242 pages, Crown Octavo, New York, 1909. 8 shillings, 6pence net. Sanitation, Public Health, and Municipal Engineering. Valuations by Samuel Scrimshire, FSI. A textbook on valuation applied to the sale and purchase of freehold, lifehold, copyhold, and leasehold property, assessments to duties under the Finance Act of 1910, the enfranchisement of copyhold estate, assessments for rating purposes, compensation on compulsory purchase, and valuations for advances on mortgage. Demi-octavo, 200 fully worked examples. 460 pages, 1915, 10 shillings, 6pence net. Postage, inland, 5pence, abroad, 10pence. Engineering Work in Public Buildings by R.O. Alsop. 77 illustrations, 9 plus 158 pages, demi-quarto, 1912, 12 shillings, 6pence net. Public Abattoirs, Their Planning, Design, and Equipment by R.S. Ailing, 33 plates, 100 pages, demi-quarto, 1908, 8 shillings, 6pence net. Sewage Purification by E. Bailey Denton, 8 plates, 44 pages, octavo, 1896, 5 shillings. Water Supply and Sewerage of Country Mansions and Estates by E. Bailey Denton, 76 pages, Crown Octavo, 1901, 2 shillings, 6pence net. Sewerage and Sewage Purification by M. N. Baker, 2nd edition, 144 pages, octodecimo, boards, New York, 1905, 2 shillings net. Bacteriology of Surface Waters in the Tropics by W. W. Clemetia, 8 plus 161 pages, octavo, Calcutta, 1912, 7 shillings, 6pence net. Housing and Town Planning Conference, 1913, being a report of a conference held by the Institution of Municipal and County Engineers at Great Yarmouth, edited by T. Cole, 42 folding plates, 227 pages, octavo, 10 shillings, 6pence net. Housing and Town Planning Conference, 1911, report of a conference held by the Institution of Municipal and County Engineers at West Bromwich, edited by T. Cole, Secretary. 30 plates, 240 pages, octavo, 10 shillings, 6pence net. Sanitary House Drainage, Its Principles and Practice by T. E. Coleman. 98 illustrations, 206 pages, Crown Octavo, 1896, 3 shillings, 6pence net. Stables, Sanitation, and Construction by T. E. Coleman. 183 illustrations, 226 pages, Crown Octavo, 1897, 3 shillings net. Discharge of Pipes and Culverts by P. M. Crosthwaite. Large folding sheet in case, 2 shillings, 6pence net. A Complete and Practical Treatise on Plumbing and Sanitation by G. B. Davis and F. Dye. 2 volumes, 637 illustrations and 21 folding plates, 830 pages, quarto, cloth, 1899, £1, 10 shillings net. Standard Practical Plumbing by P. J. Davies. Volume 1, 4th edition, 768 illustrations, 355 pages, Royal Octavo, 1905, 7 shillings, 6pence net. Volume 2, 2nd edition, 953 illustrations, 805 pages, 1905, 10 shillings, 6pence net. Volume 3, 313 illustrations, 204 pages, 1905, 5 shillings net. Conservancy, or Dry Sanitation versus Water Carriage, by J. Donkin. 7 plates, 33 pages, octavo, sewed, 1906, 1 shilling net. Sewage Disposal Works by W. C. Easdale. 160 illustrations, 264 pages, octavo, 1910, 10 shillings, 6pence net. House Drainage and Sanitary Plumbing by W.P. Gerard, 11th edition. 6 illustrations, 231 pages, 8mo, boards. New York, 1905, 2 shillings net. The Treatment of Septic Sewage by G.W. Rafter, 137 pages, 8mo, boards. 3rd edition, New York, 1913, 2 shillings net. Reports and Investigations on Sewer Air and Sewer Ventilation by R. H. Reeves, 8vo, sewed, 1894, 1 shilling. Sewage Drainage Systems by Isaac Schoen, 27 folding plates, 47 illustrations, 440 pages, 8vo, 1914, 25 shillings net. Drainage and Drainage Ventilation Methods by Isaac Schoen, C.E. 7 folding plates, 36 pages, 8vo, leather, 1913, 6 shillings net. The Law and Practice of Paving Private Street Works by W. Spinks. 4th edition, 256 pages, 8vo, 1904, 12 shillings, 6pence net. Structural Design, C. Bridges and Roofs. Telegraph Codes. New Business Code, 320 pages, narrow 8vo. Size 4 3/4 inches by 7 3/4 inches and 1/2 inch thick, and weight 10 ounces. New York, 1909, 1 pound, 1 shilling net. Miners and Smelters Code, formerly issued as Master Telegraph Code. 448 pages, 8vo, limp leather, weight 14 ounces, New York, 1899, 2 pounds, 10 shillings net. General Telegraph Code, compiled by the Business Code Company, 1,023 pages, small quarto, with cut-side index for ready reference. New York, 1912, 63 shillings net. Postage inland 6pence, abroad 1 shilling 4pence. Billionaire Phrase Code, containing over 2 million sentences coded in single words. 56 pages, 8vo, leather, New York, 1908, 6 shillings 6pence net. Warming and Ventilation, Hot Water Supply by F. Dye. 5th edition, new impression, 48 illustrations, 8 plus 86 pages. 8vo, 1912, 3 shillings net. A Practical Treatise upon Steam Heating by F. Dye. 129 illustrations, 246 pages. 8vo, 1901, 10 shillings net. Practical Treatise on Warming Buildings by Hot Water by F. Dye. 192 illustrations, 319 pages. 8vo, 1905, 8 shillings 6pence net. Charts for Low-Pressure Steam Heating by J. H. Keneally, small folio, New York, 4 shillings 6pence. Formulae and Tables for Heating by J. H. Keneally, 18 illustrations, 53 pages, 8vo, New York, 1899, 3 shillings 6pence. Centrifugal Fans by J. H. Keneally, 33 illustrations, 206 pages, foolscap 8vo, leather, New York, 1905, 12 shillings 6pence net. Mechanical Draft by J. H. Keneally, 27 original tables and 13 plates, 142 pages, crown 8vo, New York, 1906, 8 shillings 6pence net. Theory and Practice of Centrifugal Ventilating Machines by D. Merg, 7 illustrations, 81 pages, 8vo, 1883, 5 shillings. Mechanics of Ventilation by G. W. Rafter, 3rd edition, 143 pages, 8mo, boards, New York, 1912, 2 shillings net. Principles of Heating by W. G. Snow, new edition, 59 illustrations, 12 plus 224 pages, 8vo, New York, 1912, 9 shillings net. Furnace Heating by W. G. Snow, 4th edition, 52 illustrations, 216 pages, 8vo, New York, 1909, 6 shillings 6pence net. Ventilation of Buildings by W. G. Snow and T. Nolan, 83 pages, 8mo, boards, New York, 1906, 2 shillings net. Heating Engineer's Quantities by W.L. White and G.M. White. 4 plates, 33 pages, folio, 1910. 10 shillings, 6 net. Water Supply. See also Hydraulics. Potable Water and Methods of Testing Impurities by M.N. Baker. 97 pages, 18mo. Boards. 2nd edition, New York, 1905. 2 shillings, net. Manual of Hydrology by N. Beardmore. New impression, 18 plates, 384 pages, 8vo, 1914. 10 shillings, 6 net. Boiler Waters. Scale, Corrosion, and Fouling by W.W. Christie. 77 illustrations, 235 pages, 8vo. New York, 1907. 12 shillings, 6 net. Bacteriology of Surface Waters in the Tropics by W.W. Clemisha. 12 tables, 8 plus 161 pages, 8vo, Calcutta, 1912. 7 shillings, 6 net. Water Softening and Purification by H. Collett. 2nd edition, 6 illustrations, 170 pages, Crown 8vo, 1908. 5 shillings, net. Treatise on Water Supply, Drainage and Sanitary Appliances of Residences by F. Collier, 100 pages, Crown 8vo, 1899. 1 shilling, 6 net. Purification of Public Water Supplies by J. W. Hill. 314 pages, 8vo. New York, 1898. 10 shillings, 6. Well Boring for Water, Brine, and Oil by C. Eisler. 2nd edition. 105 illustrations. 296 pages, 8vo. 1911. 10 shillings, 6 net. Method of Measuring Liquids Flowing Through Pipes by Means of Meters of Small Caliber by Professor G. Lang. 1 plate, 16 pages, 8vo, sewed, 1907, 6 net. On Artificial Underground Water by G. Rickert. 16 illustrations, 33 pages, 8vo, sewed, 1900, 1 shilling, 6 net. Notes on Water Supply in New Countries by F. W. Stone. 18 plates, 42 pages, Crown 8vo. 1888, 5 shillings. The Principles of Waterworks Engineering by J. H. T. Tudsbury and A. W. Brightmore. 3rd edition, 13 folding plates, 130 illustrations, 447 pages, demi 8vo, 1905, £1, 1 shilling net. End of A Short List of Scientific Books published by E. and F. N. Spawn Limited. Part 2.
Chapters 2, 3, and 4 of the Library Assistance Manual. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Christina Bowie. The Library Assistance Manual by Theodore W. Koch. Chapter 2. Organization of a Library. The organization of the average library consists of the following component parts. Number 1. Board of Trustees. The main function of the Board of Trustees is to look after the financial interests of the library, to see that the buildings and equipment are properly cared for, and to decide broad questions of policy. Trustees should be, but are not always, elected from the elite of the community. It is expected that in them will be found a genuine culture, an appreciation of things pertaining to the arts and sciences, combined with the advantages of education, travel, and sufficient leisure to look after public interests. Cultivated men, says Edward Edwards, familiar with books from childhood, have usually a very inadequate perception of the toil and thought which have to be given to the good arrangement, the accurate cataloging, and the ready service of a library. What, then, is to be expected if a dominant share in the management of a library be placed in the hands of men with just enough of elementary education to bring into broad daylight the intensest ignorance in union with the most stolid self-conceit. A little bookishness in a committeeman, said Justin Windsor, may be as dangerous as a sip from the poet's Pierian spring, particularly if there is no deeper learning in any of his associates. He knows just enough of books not to know that he knows nothing of libraries. Number 2. The librarian. A librarian, said Henry Bradshaw, is one who earns his living by attending to the wants of those for whose use the library under his charge exists, his prime duty being, in the widest possible sense of the phrase, to save the time of those who seek his services. The librarian has been variously compared to the commissariat in the Republic of Letters, whose business is not to fight himself but to put others in fighting trim, or to the host at the banquet of knowledge, who is assiduous in securing the comfort of the guest and in placing before each one just the kind of food he likes and requires. He knows that what is one man's meat is another man's poison. Enthusiasm for the work is a prime requisite in the librarian. Even a good staff cannot overcome the deadening influence of daily contact with a chief lacking in enthusiasm. To the librarian should be left the details of administration. The librarian is the executive officer of the Board of Trustees, and the latter, if wise, will look to the librarian for getting the results desired, and will allow that officer as free a hand as possible. If the librarian is not capable of administering the library or worthy of the fullest confidence, the sooner one is secured who measures up to this standard, the better. Number 3. The library staff. The duties of the staff vary with the size of the library. In the smallest libraries, the librarian may be the only one engaged in the actual work of the library. But in such cases, the library hours must be restricted to such as one person can take care of. The next step in growth is to have someone relieve the librarian at the desk and to do the more clerical work. Next comes special assistants to look after special tasks, like cataloging and classifying, desk work, and so on. The staff, whether large or small, should consider itself responsible to the librarian and should not, except in extraordinary cases, go directly to the Board of Trustees with petitions. The librarian should always be the spokesman for the staff. Going over his head indicates a lack of sympathy and cooperation between the librarian and the staff that argues badly for the welfare of the institution. Qualifications for library work. The best preparation for library work is a thorough, systematic, general education. To this should be added a special preparation secured either through apprenticeship, a training class, or a regular library school. Different positions call for different qualities in assistants, but library service in general demands tact, perseverance, adaptability, habits of precision, and accuracy, with a fair amount of speed, ability to distinguish between essentials and non-essentials, and a strong desire to be of service. A certain familiarity with books and famous characters in history and in fiction is expected of everyone in a library. Personal neatness, good temper, and a sense of humor are valuable assets in this as in other lines of work. No one will succeed in library work who goes into it merely for the money that can be got out of it. Loyalty to the institution and its officers is essential to efficient service. If the assistant cannot feel this sense of loyalty,
The sooner a new position is secured, the better for all concerned. Dignity, self-possession, and self-reliance are valuable qualities in any part of the library, but are especially needed by assistants at the reference desk. Qualities that unfit one for library work in general are physical weakness, deformity, poor memory, a discontented disposition, egotism, a lack of system in one's method of work, an inability or unwillingness to take responsibilities, a tendency to theorize, criticize, or gossip, inability to mind one's own business, fussiness, and long-windedness. One librarian advocates listing the virtues and personal qualities of the staff and apprentices by having a questionnaire like the following filled out for each assistant. Has she tact? Has she enthusiasm? Has she method and system? Is she punctual? Is she neat? Is she kind? Is she a good disciplinarian? Is she sympathetic? Is she quick? Is she willing to wear rubber heels? Is she a good worker? Is she accurate? Has she a pleasing personality? Has she a sense of responsibility? Is she patient? Is she courteous? Has she self-control? Is she cheerful? Has she a knowledge of books? Are her vibrations pleasant? Has she executive ability? Can she speak French, German, Spanish, Italian, Yiddish? Has she social qualifications? Can she keep a petty cash account? What are her faults? Mr. Herbert Putnam, Librarian of Congress, gives the following advice to aspirants for library positions. First, secure the best possible general education, including, if possible, a college course or its equivalent. Second, acquire a reading knowledge of at least French and German. Third, add to this training in a library school. Fourth, if a choice must be made between the special training in a library school and a general course in a college, choose the general course, but make every effort to supplement this by the special course, if only for a brief period. Fifth, if an opportunity occur for foreign travel, utilize it. Sixth, if you had not been able to contrive either a thorough general education or special training, your best opportunities in library work will be in a small library where your personal characteristics may be such as to offset these other deficiencies. Seventh, without at least a fair reading knowledge of French and German, you cannot progress beyond the most subordinate positions in a large library. Chapter 3. Book Selection and Buying. Book selection makes the greatest demand on the knowledge and administrative judgment of librarians, and is the question that produces the most friction between librarians and library communities. If the trustees define the general policy of the library, determine the amount to be expended on books, and approve purchases out of the ordinary run, the librarian should be considered as the one person best posted on the needs of the library, and as purchasing agent for the institution should be allowed to buy where he can do so to the best advantage. Of course, the problem is quite different in an academic library from what it is in a public library. Especially in the latter should the librarian be granted the utmost freedom in the selection of the general run of books. We are often asked who seeks the books for purchase and how this is done, says Dr. A.E. Bostwick in the annual report of the St. Louis Public Library for 1911-12. About 10,000 volumes are issued from American presses yearly, not to mention those of England and other European countries. Of these, we can purchase only about 2,000 titles. Of the remainder, some are eliminated by their heavy cost, as in the case of editions deluxe, and most works intended for wealthy collectors. Some because of their class, such as technical works on law and medicine, which we are leaving to the special local libraries devoted to these subjects, and some because they are obviously below standard, being either untrustworthy, trivial, or objectionable. There remains a very considerable number, any one of which we might purchase, but only a certain proportion of which we can buy with the funds at our disposal. From these we try to select the best, judging from the standpoint of a high-grade public library. Some of the considerations that affect our decision are, first, public demand, to which we always give heed unless it is obviously uninformed. Secondly, a desire to strengthen our collection in weak points. And thirdly, expert advice, oral or printed, volunteered or specially asked. Here in St. Louis, we are profiting by the services of numerous experts in special subjects, which are freely given as a public service, and we scan carefully every bit of expert testimony regarding the availability of books contained in the bulletins of other libraries and in other current lists and bibliographies. Trade lists and catalogs of all kinds are checked up with our own to see what we lack, and the result is the assemblage of a list of wants far larger than we can purchase. The final selection from these is apt to leave behind some things that we ought to buy, but it is unlikely to include anything that could well have been left out, considering our special conditions and needs. The final word in selection rests with the committee of the board, but for ordinary current purchases, and unless some point involving the larger policies of selection is to be settled, this committee usually allows the librarian to exercise his own judgment. Besides the sources of selection already mentioned, books on approval are received in considerable quantities, sometimes being sent voluntarily by dealers or individuals, sometimes requested by the library. The librarian must develop a sense of proportion and beware of the library patron with a hobby, and of the trustee who is interested in building up only one side of the library, and of the scholar who thinks that only solid reading for the immortal mind should be placed before old and young. In buying for an average public library, the aim should be to choose general treatises rather than those covering only special phrases or special subjects. The special treatises would be the more desirable for a university library, where they would be in demand both by faculty and students, as authorities on detailed points, as aids, or as sources in further investigation. Too much money should not be locked up in expensive volumes that will be seldom used. The librarian should estimate the average cost of his books per volume and, except in the case of reference books, should not go too far beyond this average cost. He should avoid partisanship and develop catholicity of taste and breadth of sympathy. He should try to have something on his shelves for every patron in town, real or potential, but should not allow the library to be drawn into any sectarian propagandist movement. He should avoid controversial works, sensationalism, and the latest fad, and put off the purchase of the book of the hour until he feels fairly sure that the demand for it will not die within the hour. The efficient librarian does not think too much of the sum of total accessions, but is mindful of the fact that it is quality, not quantity, that counts. It doesn't matter how many, but how many good books you have. This was said by Seneca, but the same truth has been stated by many modern librarians. I should as soon tell how many tons the books in the Astor Library weigh as to tell how many volumes there are, was a sage remark of Dr. Joseph G. Cogswell. Strength does not lie in mere numbers. This fact is as true of books as of soldiers, said Mr. W. E. Foster. 1,000 carefully picked are worth 2,000 assembled at random. Aids in book selection. The chief aid in book selection for the average small public library is the ALA catalog. The first edition was issued in 1893 for the World's Columbian Exposition. It was planned as a guide for book buyers as well as for readers and as a manual for librarians in the matter of book selection. To a certain extent, it was hoped that it would take the place of a printed catalog in some of the smaller public libraries. By checking in the margin the titles of the books owned, it forms a convenient partial catalog of best books for any library. In 1904, a classified and annotated edition, thoroughly revised and brought down to date, was prepared for the St. Louis Exposition. This included 7,520 volumes adapted to public libraries, as contrasted with 5,000 titles included in earlier edition. A supplementary class list of 3,000 titles covering the books issued between 1904 and 1911 was issued by the ALA in 1912. The ALA Book List, a guide to the best new books, has just completed its 9th annual volume. Various state library commissions have issued helpful lists. Wisconsin's suggestive list of books for a small library is a good specimen. The Fiction Catalog, published by H.W. Wilson Co., Minneapolis, is useful as a checklist and contains many excellent titles. In the same way, the lists of the 100 and of the 1,000 best novels issued by the Free Library of Newark, New Jersey, are worth studying. Various lists of best books, like Sir John Lubbock's famous 100 Best Books, or Dr. Eliot's 5-Foot Library, are to be found in a pamphlet, The World's Best Books, which is to be had free of charge from the Globe Wernicke Co., Cincinnati. For additional titles, see Aids in Book Selection by Alice B. Kroeger and Sarah W. Cattle, ALA Publishing Board, 1908. Book buying. If it is desired to buy a special list of books already selected, it is usually best to place the order with one of the large houses which make a specialty of library trade, or with a local dealer if the proper service and discounts are assured. Cost of carriage may total up high enough to offset a special discount, and so should be considered in comparing prices offered by two different dealers. In scanning a list of books to be bought, attention should be paid to Number 1. Those titles which are to be had in reinforced bindings. Number 2. Titles which are to be had in special editions, as in Everyman's Library. Number 3. Titles which are to be had from dealers in remainders and are likely to be offered at bargain prices. The list of editions selected for economy in book buying, compiled by Leroy Jeffers and published by the American Library Association, 25 cents, is well worth studying. The selection of books to be bought at any one time will be determined by the prices at which they can be secured, and consequently it is desirable to constantly study dealers' catalogs. Worn copies of popular titles or copies that are loose in their bindings are not ordinarily wise purchases, as they soon require rebinding, and thus make the total cost exceed the first cost of a copy in reinforced binding. Subscription books are rarely worth anything like the money asked for them. If wanted, they can frequently be bought from dealers in second-hand books or from jobbers in remainders and surplus stock. Books should not be bought from traveling agents. There are only a few publishing houses who employ them who would not supply their books through their regular channels of trade. Editions deluxe are now generally understood to be for looks only, and library editions are frequently so called because they are for the private and not for the public library, being put up in a way not warranted to withstand wear and tear. Accession book. The accession book, which corresponds to the invoice book of a business house, is the first of all records to be made of a book after it has been acquired by a library. The accession book aims to show the editions of each day in the exact order of their reception, without classification of any kind. One turns it to learn what price was paid for a book, when and where it was bought, how much was paid for binding it, if it was bound after being acquired by the library, how much was paid for replacement if lost, etc. Each volume is entered on a separate line and secures a separate accession number. By means of this number, the history of any particular book can be traced. The accession book is the most permanent of the library records. Entries cannot disappear as from a card shelf list, and it is of the greatest value in case of books lost or destroyed by fire. Each book should be entered immediately after it is collated and found to agree with the order and bill. The entries must be kept up to date in order to avoid loss and confusion. An accession number should be given each separate volume. Giving a single accession number to a set leads to endless confusion. A numbering machine will save time and help to prevent errors. Chapter 4. Classification. Definition. Classification consists of putting like things together. We do this every day, and the classification of books is only one special phase of this general process. Thus, a man who owns a hardware store does not place his goods helter-skelter, a stove, a box of nails, some saws, and then a furnace, but he runs over his stock and classifies it, putting stoves in one place, nails in another. By this classification, he gains two things. First, he can find any one thing he wants more quickly. Secondly, he can tell how much of any one article he has on hand, and so decide whether he must lay in a new supply. Likewise, the zoologist classifies all members of the animal kingdom, so that he can learn what the different kinds of animals are, and study the relationship between them. Without the help afforded by classification, he would be overwhelmed by the immense number of facts brought before him, and without the aid of classification he would never have known of evolution, the guiding star of modern investigation. First principles. In our everyday life, we lose much time hunting for things which we have no definite place. We have put them in the place which was most convenient for us at the moment when we put them away. Think for yourself how it is with your knowledge. From observation, from conversation, from reading, you learn little about many subjects like electricity, botany, astronomy, or politics. But in this desultory way, you do not learn very much about any one of these subjects. Therefore, you do not feel any special need of classifying your information. But when you take up any of these subjects and pursue it seriously, you learn thousands of facts and relations, and then is the time that you feel the need of some plan of arrangement of your knowledge. Private versus institutional libraries. One has the same experience in regard to books. A person having a library from 50 to 300 books does not feel the need of classifying them. The ordinary arrangement is based upon size, color, or convenience. The books in the average house are so placed as to look their best. The classification, as far as it exists, is an aesthetic one. The owner knows the exact appearance of every volume in his library, and when he wants Longfellow's poems, he can tell at a glance where it is. In a small public library, there is no occasion for all the history being in one place, or all poems in another. As the library grows, the aesthetic principle of classification can be followed until the owner can no longer readily remember how each book looks. But our institutional libraries contain so many books that the librarian cannot know them in the same way that he knows the books in his own private library. And consequently, he has to study the question of classification and devise a method by which not only he, but his assistants, and also such readers as have access to the books, can readily find them as wanted. Classification, the putting of like things together, would, therefore, mean in a large library putting histories together in one place, the medical books together in another place, and so with all other distinctive subjects. Each of these large classes will, however, have to be subdivided. Thus, histories of Greece are put together in one place, histories of Rome in another, histories of the United States in still another. The subdivision in the larger libraries is carried still farther, and books on the period of the discovery of America are put first, followed by books on the colonial period of the United States, the Revolutionary War, etc. United States history, if well represented, is classified geographically. This process of subdivision into separate groups of books on each state can be carried still farther if necessary. Advantages of classification. The following questions may arise. What advantages come from the classification, and who are benefited? The advantages come to those having access to the books. If one goes to a library to get a volume by Arnold Bennett, it makes no difference to the individual whether the library is classified or not, if he cannot go to the shelves and pick out the book for himself. Likewise, if he wants Young's Astronomy, he will probably get the book more quickly if he asks the attendant to get it than if he tries to get it himself, supposing he does not have access to the shelves. But the time when the reader gets the most help from the classification is when he wants to examine a number of books on astronomy and can go to the shelves and find the books on the subject all in one place. Then he can easily find what different writers have to say about the habitability of Mars, or he can find what book appeals to him as being the most interesting and can borrow it for home use. Any investigator finds access to the shelves of a well-classified library an immense help. An aid to the librarian. Another person who is greatly benefited by the classification is the librarian, and it is just as important that he be helped as that the reader be helped. He is, however, helped in a different way. He knows what the system of classification in use in the library is, and with the outlines of this scheme in mind, he goes through the library and finds out where it is strong and where it is weak, and can plan future purchases accordingly. If, for example, he finds on the shelves of little value on photography, he will make a note of it and buy more books on that subject when funds are available. If he finds that there is an undue supply of travel on hand, he will note that also and buy fewer books in that class in the future. Without the help of classification, the librarian would overlook many such irregularities. In an unclassified library, they would be discovered only through a long and tedious investigation. His only resource would be the catalog, and that is not so well adapted to answer such questions. Basis of classification. The next question is, what shall be the basis of classification? It is obvious that this basis should be sought in the character of the books themselves, and should be applied with constant reference to the reader and his needs. In regard to the first point, character of books, we know that books have been written on all kinds of subjects, religion, law, history, medicine, etc., and that those subjects form the only rational basis for classification. A classification based on these distinctions is the only one that helps the reader. If a man comes to the library to investigate a particular point in medicine, it is clear that it will help him if he finds all the medical books together, rather than all the books grouped according to their date of purchase by the library. Present tendency. Many schemes have been devised for the classification of books, some very simple, others extremely elaborate. The present tendency is to adopt the more elaborate classification. Formerly, most libraries were not classified at all, but the books were arranged in the order in which they were received, the only grouping of the books being in such cases as based on size, folios in one place, quartos in another, in order to save shelf room. Assuming that the books in the library were numbered according to the date of their accession from 1 up to, say, 20,000, it is clear that the reader could find a book by a particular writer quickly enough by looking up its number in the catalog, but if he had wished to consult 30 books on one subject, it would be a very tedious operation, and most readers would not take the time for it. Simple forms of classification. The most common plan in English libraries is a modification of this scheme. The books are divided into about 10 classes, and the books in each class are arranged in the order in which they are received. The classes are distinguished by capital letters. An example said to be very common in England is as follows: A. Theology and philosophy. B. History and biography. C. Travel and typography. D. Law, politics, commerce. E. Arts and sciences. F. Fiction. G. Philology. H. Poetry and drama. J. Juvenile. K. Miscellaneous and magazines. An illustration of the way a book is marked in this scheme, B2574, might be Green's History of the English People. This book is marked B because it is a history. It is marked 2574 because there were already 2573 books in this class at the time this book was added. This mark, B2574, is a very simple one and to that extent satisfactory. The scheme is a great advance over the preceding one because it brings the books of a kind together. Since there are 10 classes in this scheme, it is evident that if a reader wishes to see all the books on one subject, he will have to examine only 1/10 of the library instead of the whole of it. But even this is not felt to be minute enough. If the library contains 200,000 volumes, one class would contain, on the average, 20,000 volumes, which is altogether too great a collection to search through. If Green's History of the English People were marked B2574, The next book might be Robinson's History of Peru, marked B2575, which is of course a very different subject. The case is still worse in Class E, which includes fine arts, useful arts, and all the sciences, so that a book on chemistry might stand between a book on medicine and one on Raphael. This would not satisfy the reading public of today, nor the modern librarian. The classes F, fiction, and J, juvenile, are not so bad. There is not so great a difference between the books in these classes. They are used more by people seeking recreation rather than by those looking for definite titles. Jacob Abbott wrote some 200 juvenile books, and many of these might be scattered among the large Class J. In Class F, fiction, the English, French, and German authors would be all thrown together. This would be a disadvantage for anyone desiring to read along a particular line. Open versus closed classification. The question of open versus closed classification is an important one. By open classification, we mean one without minute subdivisions. An illustration of open classification is the scheme of 10 classes described above. As an extreme case of open classification, mention may be made of the theological library in which only 2 classes were used. The one classes containing the books that were sound in their theology, the other the books that were unsound. At the present time, the tendency is towards closed classification. It is a necessity in large libraries and an advantage in small ones. In this country, the 2 great authorities on classification are Charles A. Cutter and Melville Dewey. Both have devised and published schemes of classification which are generally recognized as having many excellent features. In both schemes, the classification admits of very minute subdivisions. Dewey says that if the library has only one book on a certain subject, that book ought to be put in its own special class. It does not matter if there is no other book in the class. No one can fully understand what is meant by closed classification until he has had considerable experience in classifying books. You can pick up the printed scheme of classification and run your eye through the numbers, but you will get comparatively little from them until you try to apply them. Minute bibliographical classification. The following is a very important distinction in regard to close classification, which should be carefully noted. It is one thing to classify books, but it is quite a different thing to classify articles in magazines for the bibliography of a subject. Magazine articles may be classified far more minutely than books can be. Take, for example, the Bibliographia Geologica, in which references are made to articles in geological magazines and publications of geological societies. Here the articles are classified according to Dewey. Dewey's class, 551, means physical geology. In this bibliography, there is a particular article marked 551, 795,513,111,044. That is to say, the general subject of physical geology is subdivided in 1/1,000,000,000 parts, and this article is assigned to one of those parts. If one should apply for a library position and be told that he should have to classify the books as closely as this, he would probably never get the position. If he were given this article to classify, he would just as likely as not put it 10 billion points out of the way. As a matter of fact, this bibliography is compiled by a number of experts in geology. There are similar bibliographies of botany, zoology, and other natural sciences, all minutely classified and all compiled by experts. The reason that books cannot be as closely classified as magazine articles is that they generally deal with broader topics. In the average library, it does not pay to classify books more minutely than is warranted by the general run of books in the class in which these books are to be assigned. In this regard, a distinction must be made between libraries. The Library of Congress has devised a classification of its own, which is very minute, and a number of classifiers are employed to look after the different fields in which they are more or less expert. In this way, classification can be carried to the extreme limit of closeness. Nothing keeps one more modest than classifying, for one is continually brought face to face with things that one does not know, and so many things of which one knows so little. The Dewey Decimal System. The decimal classification is used in this country and in Europe. It is suitable for both large and small collections of books and for indexing. In many schemes of classification, letters are used to denote the classes, in others a combination of letters and figures. Dewey uses only figures. Dewey developed his system in 1873 and published it in 1876. Numbers of 3 figures were used to denote the classes. Since then, it has been found desirable to subdivide much more minutely, and this has been done with increasing minuteness. In the 7 editions that have followed the one of 1876, a general outline of Dewey is here given. 000 General Works, 100 Philosophy, 200 Religion, 300 Sociology, 400 Philology, 500 Science, 600 Useful Arts, 700 Fine Arts, 800 Literature, 900 History. Each of these is divided into 10 sections. 500 Science, 510 Mathematics, 520 Astronomy, 530 Physics, 540 Chemistry, 550 Geology, 560 Paleontology, 570 Biology, 580 Botany, 590 Zoology. Each of these is divided into 10 sections. 530 Physics, 531 Mechanics, 532 Hydraulics, 533 Pneumatics, 534 Sound, 535 Light, 536 Heat, 537 Electricity, 538 Magnetism, 539 Molecular Physics. These sections are still further subdivided until the requisite degree of minuteness is reached. The system has various pneumatic features which are helpful. Every figure has a meaning. An alphabetical list of all these meanings is appended to the classification. Thus, after the word hydraulics is 532, showing where to look in the classification for this subject. All books on hydraulics receive the number 532 and are together on the shelves. This fact illustrates one great advantage of the Dewey system, that as the library grows, the new books can be placed with the corresponding old ones without remarking the old ones, while in the fixed location system, the books are marked to certain localities, and when moved by reason of growth of the library have to be remarked. This remarking includes not only the books, but also the cards referring to the books. The remarking is very costly and very unsatisfactory. In Dewey's system, the books in any one class are arranged according to some method. In most classes, an alphabetical arrangement by the names of the authors is simplest and best. In some scientific classes, some librarians prefer the chronological arrangement. In any case, it should be clear and simple. Relative location. With the movable location, all new books fall at once into their proper places like the cards which are added to a card catalog, and the newcomers push the other books along on the shelf, just as new cards push the others along in the drawer. The consequence is that a book which is here today may be on the next shelf in a month, or in the next alcove in a year, and the local memory, which is a great help in finding books quickly, is disturbed. The only remedy that I can see for this is to substitute a subject memory for a local memory, to get a habit of thinking of a book as belonging to a certain class instead of as on a certain shelf. A much more rational memory, by the way. And then to make it very easy to find the classes. This last is not hard to accomplish. A class memory can be cultivated and may be assisted by local memory, which will find books by their position relative to other books, instead of by their position relative to alcoves and shelves, or doors and windows. C.A. Cutter. End of chapters 2, 3, and 4 of the Library Assistance Manual by Theodore W. Koch. Recording by Christina Bowie.
Chapters 1 and 2 of the Toronto Cookbook. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Toronto Cookbook by Mrs. E.J. Pyle. Bread. The following instructions have been generously donated to me by the E.W. Gillette Company Limited, which are thoroughly correct as to making and baking yeast bread. Mrs. E.J. Pyle. To make liquid yeast with royal yeast. Use 2 cups of flour and blend with a little cold water until smooth. Then pour over this 4 quarts of boiling water, and stir the flour and water together thoroughly. Add 1 quart finely mashed potatoes and 1/2 cup of salt, and same quantity of sugar. Let this liquid cool until it is lukewarm, and add 2 royal yeast cakes that have been soaked previously for a few minutes in tepid water. Then put this mixture in a warm, not hot place, well covered for a few hours. Use a vessel sufficiently large to allow the liquid to rise. The liquid referred to above could be used 4 or 5 hours after making, but to get best results it should be allowed to stand overnight, or about 12 hours before using it. It will keep for 2 weeks in a moderately cool place. Above quantity of liquid yeast is sufficient to make 10 or 12 large loaves of delicious bread. To make 2 loaves of bread, warm 2 quarts of flour and knead in 2 pints of liquid yeast. Mix well and turn out on bake board and knead again for a minute or 2, or until smooth and even. Cover and set in a moderately warm place, away from draughts, until the bulk has about doubled. If the liquid yeast has stood overnight, the bread sponge should rise enough in an hour and a half, or very little more. Then knead again and divide into 2 loaves. Put loaves into greased pans and cover and set to rise again until bulk is doubled in size, which will probably be in about 1 hour. Supposing the liquid yeast is made at noon, and it is desired to set bread at night, follow the same directions, except that the dough should not be divided into loaves until following morning, thus giving it more time to rise. If liquid yeast is made the day before, the bread can be set and baked before noon. 1 quart of flour and 1 pint of liquid yeast will make 1 good-sized loaf. If dough is too dry, add a little more liquid yeast, or if too moist, add a little more flour, so that it will not stick to pans or board. To bake, have the oven very hot for 15 to 20 minutes at first, and then allow it to cool a little. Bake the bread 1 hour or a little longer. Take out of pans as soon as baked and cover with a towel or napkin. To ensure even baking, it is advisable to reverse the pan and oven after first half hour. Rolls. To make light, delicious rolls, set as for bread and add 1 beaten egg and 2 tablespoons of melted shortening to each pint of liquid yeast. 2 pints of flour and 1 pint of the liquid will make about 15 rolls. E.W. Gillette Company, Limited, Toronto, Ontario, Winnipeg, Montreal. Bread. 5 pounds rainbow flour, 1/2 tablespoon salt, 1 tablespoon sugar, 1/2 tablespoon ginger, 1 cake royal yeast. Set sponge with yeast, ginger, sugar, and salt at 2 o'clock. Add 1 quart of water. Make dough at 10 o'clock at night, adding water to make stiff dough. Bread. Take 2 cups boiling water and 1 tablespoon each of salt, sugar, and lard. Add 1 cup each of water and milk. Then break into the mixture 1 compressed yeast cake. Mix in enough rainbow flour to make a stiff dough. Let stand and rise to twice its size. Knead into loaves and put into pans. Let rise again to twice its size. Bake in moderate oven 3/4 of an hour. Parker House Rolls. 2 cupfuls of scalded milk, 1 yeast cake, 1/2 cupful of lukewarm water, 2 tablespoonfuls of sugar, 1 teaspoonful of salt, 1/4 cupful of butter, and flour. Make a sponge of the milk, scalded and cooled. The yeast cake softened in lukewarm water, and 2 cupfuls of flour. Beat thoroughly, cover and set aside until light, then add sugar, salt, melted butter, and flour to knead. Knead about 20 minutes. Let rise until double in bulk, then shape into balls. Cover closely, and when light, press the handle of a small wooden spoon across the center of each biscuit without dividing it. Brush the edge of 1/2 with butter. Fold the 2 halves and press together lightly. Place in buttered tin some distance apart. Cover, and when light, bake from 12 to 18 minutes. This makes enough for 8 people. Mrs. William R. Hudson, Boston, Massachusetts. Mixture for Parker House rolls, cloverleaf rolls, salad rolls, etc. Add 3 tablespoons butter, 2 tablespoons sugar, and 1 teaspoon salt to 2 cupfuls scalded milk. When lukewarm, add 1 yeast cake dissolved in 1/4 of a cup lukewarm water and 3 cupfuls of flour. Beat thoroughly, cover, and let rise until it is light. Cut down and add enough flour to knead. About 2 1/2 cups will be required. let rise again, toss on a slightly floured board, knead and shaped as desired. Parker House Rolls. Shape into small round biscuits, place in rows on a floured board, cover and let rise 15 minutes. With the hand of a large wooden spoon, roll through the center of each biscuit. Brush the edge of the lower halves with melted butter. Fold, press lightly. Place in a buttered pan, a ½ inch apart. Cover, let rise, and bake. Breadsticks. Add 1/4 cup butter, 1 1/2 tablespoon sugar, and ½ teaspoon salt to 1 cup scalded milk. When lukewarm, add 1 yeast cake dissolved in 1/4 cup lukewarm water, and white of 1 egg, well beaten, and 3 3/4 cup of flour. Knead, let rise, shape, let rise again, and start baking in a hot oven, reducing the heat so that the sticks may be crisp and dry. To shape the sticks, first shape as small biscuits. Roll on a board where there is no flour, with the hands until from 5 to 8 inches in length, as desired, keeping of uniform size and rounded ends. Raised cake. 5 cups flour, 2 1/2 cups sugar, 1 1/2 cups butter, 1 cup milk, 2 eggs, 3 tablespoons molasses, 1 cup yeast, raisins, and spice. Let it raise a day or two. Put into pans, raise again, and bake. Baking bread to be used first thing in morning. Take 4 to 5 quarts flour, sift flour thoroughly into bread pan with small teaspoon salt, 1 tablespoon lard. Lard is better than butter for making bread, as it makes it much whiter. Make a hole in the center, forming a well, then put in yeast or sponge, whichever you are using. Then take 1 to 3 pints lukewarm water, pouring into the well a little at a time and mixing constantly. Then knead well for about ½ an hour. When ready to cover, you can always tell if bread has been sufficiently kneaded by its not sticking to the hands or bread pan. Set away in a warm place, free from drafts and well covered. Allow this to remain overnight. In the morning make into rolls, set to rise, and when ready, place in a hot oven and bake from 15 to 30 minutes. Note: if any housewife will follow the above directions, they will have, by taking about ½ an hour in the evening and 3/4 of an hour the next morning, the most delicious hot rolls or bread, as preferred. Mrs. E.J. Pyle. Another way of making bread quickly, without yeast. 1 quart sifted flour, 1 teaspoon salt, 3 teaspoons baking powder. Mix thoroughly together, then add sweet milk or water to make soft dough, and bake at once in bread pans. Graham bread, without yeast. 2 cups graham flour, 1 egg, ½ cup brown sugar, 2 teaspoons baking powder, 1 small teaspoon salt. Mix quite soft with milk and bake in bread pan in moderately low oven. Nut loaf. 3 cups flour, ½ cup sugar, 1 cup milk, 1 cup nuts, 4 teaspoons baking powder, 1 egg. Let stand for 20 minutes. Bake for 40 minutes. This is Mrs. H.C. Tomlin's recipe for her famous nut loaf. Delicious fruit biscuit. Take 2 cups sifted flour, 3 teaspoons baking powder, a little salt, 2/3 cup milk, 1/2 cup seeded raisins, 1 dessertspoon citron, chopped very fine, 1 teaspoon chopped nuts, 2 tablespoons sugar, a dash of cinnamon. Mix together gently, place on board, and roll 1/4 inch thick. Spread over with melted butter. Sprinkle with fruit sugar and a little cinnamon. Roll as for jelly roll. Cut into pieces of ½ inch thickness and bake in quick oven about 12 to 15 minutes. Raised nut loaf. Place mixing bowl on table. Put in yeast cake or prepared yeast sponge with 1 quart lukewarm water, 1 tablespoon sugar, 1 tablespoon salt, 2 tablespoons melted lard. All these ingredients should be lukewarm. Then add 2½ quarts sifted whole wheat flour, or the same quantity of white bread flour. Mix together, and lastly add 1 cup of English walnuts. Mix and knead same as when making white bread. Raised cake, generally made for Christmas. 5 cups flour, 2½ cups sugar, 1½ cups butter, 1 cup milk, 2 eggs, 3 tablespoons molasses, 1 cup yeast or 1 yeast cake, raisins and spice. Mix well together and let raise for a day or two. Put into pans, raise again, and bake. Mrs. J. Harrington, Boston. Rye bread. 2 cups rye meal, 4 cups flour, ½ cup yeast, or half of a yeast cake, 1 tablespoon sugar, 1 hot mashed potato, 1 teaspoon baking soda, salt, and mix with warm water. Cover and let rise. Nut bread. 1 egg, 1½ cup sweet milk, 4 cups flour, 1 teaspoon melted butter, ½ cup sugar, 1 cup chopped walnuts, 1 teaspoon salt, 4 teaspoons baking powder. Mix all well together. Place in a loaf tin and set to raise for ½ an hour. Then bake in good oven for 3/4 of an hour, or until done. Swedish buns. Take 1 pound light bread dough, add 1/2 cup butter. Roll out about ½ an inch thick. Spread with butter, sugar, cinnamon, currants. Fold as for jelly roll. Cut in ½ inch slices. Lay ring side up in pan. Let rise to double their original size. Bake, and when cold, ice. It is very little trouble to make these buns when making a batch of bread. Swedish coffee bread. Put 2 cups milk on to scald. When lukewarm, add 1 yeast cake, ½ a teaspoon salt, 1 egg, 3/4 cup sugar, butter size of an egg. If desired, a few walnuts may be added by putting through meat chopper and pounding well after, then mixing with little sugar. This really improves this bread. Add enough flour to knead. It is better to set this bread in the morning, but if set at night, just make a sponge of flour, milk, yeast, and salt, and add the other ingredients in the morning. The reason for setting in the morning is that it holds the goodness, while at night it raises out on account of standing so much longer. Raised nut bread. If sponge is set early in morning, bread can be baked before dinner. Scald 1 cup milk and allow to stand till it becomes lukewarm. Add yeast and 1 tablespoon sugar, ½ a cup sifted flour, and beat very thoroughly. Cover and put in warm place. Let rise till it doubles its original quantity. Cream 2 tablespoons lard with 1/3 cup sugar. Stir into the sponge together with white of 1 egg, well beaten, 3/4 cup chopped walnuts, 1½ cups flour, lastly adding 1/3 teaspoon salt. Mix well, knead on board for 20 minutes. Always have flour handy to use more while kneading, if necessary. Put in a greased pan or bowl and let rise to double its quantity. Butter or flour the hands. Take out enough dough to make a loaf. Knead into shape without using any more flour. Place in bread pan. Let rise to not quite double the quantity, as it rises when placed in oven. If allowed to rise too long, the loaves become very coarse. If milk is not handy, a very good substitute is potato water in place of milk. Here is something worth knowing. Take a few peeled potatoes, put them in enough water to cook, drain off, and save this water to make bread. This will be found splendid for any kind of bread. Note: if you wish to make 2 or 3 loaves of this bread, double the quantity of ingredients and use 1 whole egg. All measurements must be level when making this particular bread. GDS from Boston. Raisin bread. Take 1½ cups warm milk, add 2 yeast cakes, 1 teaspoon sugar, set in warm place until yeast rises to surface. Add 2 cups flour, mix to a batter. Pour 1/4 cup warm milk over the dough. Cover and put in a warm place until double its size. Then stir in ½ cup sugar and mix until creamy. Add the grated rind of 1 lemon, 2 eggs well beaten, a little salt. When batter is light, mix all together, adding sufficient flour to make a firm dough. Knead on breadboard. Put back in bowl and let rise till double its size. Place on board again and roll out until about 1 inch in thickness. Sprinkle with 1½ cup seeded raisins. Roll and fold dough together and knead. Put in baking pan and let rise till double its size, and bake in loaves. Peanut bread. 1 quart flour, sifted, 1 cup salted peanuts, shelled and put through meat chopper. Take 1 teaspoon salt, 1 cup sugar, 4 teaspoons baking powder, 1 egg, 1½ cups milk. Beat well, pour into long high cake tin. Let stand 20 minutes. Bake 45 to 50 minutes in a moderate oven. Bread should not be used for a day or 2 after baking. This is especially nice and most delicious for bread and butter sandwiches. Graham bread. 2 1/2 cups hot liquid, water or milk and water. 1/3 cup of molasses. 1 1/2 teaspoons salt. 1 yeast cake dissolved in 1/4 of a cupful lukewarm water. 3 cups graham flour and 3 cups white flour. The bran remaining in the sieve after sifting the graham flour should be discarded. Oak Hill bread. Add 2 cups boiling water to 1 cup rolled oats and let stand 1 hour. Add ½ cup molasses, ½ teaspoon salt, 1/2 of a yeast cake dissolved in ½ cup of lukewarm water, and 4 1/2 cups flour. Let rise, beat thoroughly, turn into buttered bread pans. Let rise again and bake. By using ½ cup less of flour, the dough is better suited for biscuits, but being soft is difficult to handle. To make the shaping of the biscuits easy, take up the mixture by spoonful, drop into a plate of flour, and have the palms of the hand well covered with flour before attempting to shape the dough. Cloverleaf rolls. Shape into tiny biscuits and put 3 into each tin of buttered individual round cake tins. Cover, let rise, and bake. Brush over with melted butter just before taking from oven. Salad rolls. Shape into small biscuits. Place in rows on a floured board covered with a cloth and pan, and let rise until light and well puffed. Flour the handle of a wooden spoon and make a deep crease in the middle of each biscuit. Take up and press the edges thus made together. Place closely in parallel rows in a buttered pan. Cover, let rise, and bake 12 to 15 minutes in a hot oven. Horseshoe rolls. Shape as for small biscuits. Roll on a board to 6 inches in length. Twist together in pairs and shape in the form of a horseshoe. Cover, let rise, brush over with the yolk of an egg, slightly beaten, and dilute it with 2 teaspoons of cold water, and bake in a hot oven. Raised donuts. 3 pints flour, 2/3 cup butter, 1 1/2 cup sugar, 1 cup yeast or half a yeast cake, salt and spice. Mix and let rise overnight. In morning, mix thoroughly and drop in small balls into the hot fat. Raised donuts. 3 pints of flour, 2/3 of a cup of butter, 1 1/2 cup sugar, 1 cup yeast, 1 cup milk, salt and spice. Boston baked beans and brown bread. You will find a number of different ways to bake beans and make brown bread in the following recipes, which have been given me by a number of my friends, and each pronounced as being really excellent. As it is rather difficult to locate these particular recipes in most of our cookbooks, I consider it a wise idea to have these recipes set up together in a way that they may be easily found when needed. Pork and beans. Put 1 pound of beans to soak overnight. Boil in morning till soft. Put into baking pan 2 tablespoons of molasses, 1 small onion, 1 pound fat pickled pork, and a dash of pepper. Cover with water. Put in moderate oven and bake all day, adding a cup of water every little while to keep from burning. Boston brown bread. 1 cup gram flour, 1 cup white flour, 1 cup Indian meal, 2 tablespoons brown sugar, 1 teaspoon salt, 1 cup of sweet milk, 1 cup sour milk with 1/2 teaspoon baking soda, and half a cup of blackstrap. Stir all together and steam 4 hours. Mrs. Rufus Skinner. Boston baked beans. Soak 2 cups of pea beans overnight. Boil them until the skin of the bean cracks when you blow on it. Put into bean pot 2 tablespoons of molasses and a small onion. If wanted, salt and a dash of pepper, a little mustard, and half a pound of salt pork. Fill up with water and keep covered with water while cooking to prevent burning. Mrs. William R. Hudson, Boston, Massachusetts. Steamed graham bread, or as called in Canada, brown bread. Mix and sift 3 cups graham flour, 1 cup white flour, 2 teaspoons baking soda, 1 teaspoon salt, 1 small cup molasses, 2 1/2 cup sour milk. Beat thoroughly and turn in a buttered mold. Cover and steam 3 hours. Please be careful and tie top of mold down securely before putting in kettle, tying lengthwise, crosswise, and around center of can, if can is used. New England brown bread. To waste not is to want not, as the old saying goes. Never allow 1 bit of your stale bread, neither the crust nor the trimming ends taken from pieces when making sandwiches, to be thrown away. Place in dish and cover with cheesecloth, and when thoroughly dried, put through meat chopper, and thus always have on hand breadcrumbs for use whenever required. Soak 1 1/2 cups breadcrumbs in 2 cups cold water overnight. Next day rub through a colander. Add 3/4 cup molasses, 1 1/2 cups each of rye meal, corn meal, and graham flour. If rye meal cannot be obtained, take a cup of dry breadcrumbs, which is equal. Mix and sift with 3 teaspoons soda, 1 1/2 teaspoons salt, 1 1/4 cups cold water. Stir until well mixed and steam 3 or 3 1/2 hours. Boston brown bread. Mix and sift 1 cup rye meal, 1 cup granulated corn meal, 1 cup graham flour, 1 teaspoon salt, 3/4 tablespoon soda. Add 3/4 cup molasses, 2 cups sour milk. Stir until well mixed. Turn into well buttered mold or tins. If you have a 5-pound lard pail in house, it is excellent in which to steam brown bread. Never allow your mold or tin to be more than 2/3 full. Have cover well buttered and tie down securely by crossing top and bottom 4 times and twice around center. This will hold it securely. Then place any kind of ring or stand that will set in bottom of kettle and place mold on same, allowing water to come halfway to top. Cover closely, wrapping around edge of cover an old towel if kettle is not securely covered. In this recipe, buttermilk, sour milk, sweet milk, or water may be used. Boston baked beans. 1 quart beans, pick, wash, and soak overnight in pot they are to be baked in. Strain in morning through colander. Sprinkle tablespoon each of salt and molasses. Add 1 pound salt pork, scored in squares on top. Fill pot with cold water. Put in oven at 9 a.m. Keep pot well filled with water hourly until just before taking up at 6 p.m. Brown bread. 3 3/4 cups of Indian cornmeal. 2 1/2 cups rye meal, not flour. 2/3 cup molasses. 1 quart water, either sweet or sour. 2 even teaspoons soda, dissolved in the milk. Steam in tin pudding boiler 5 hours. Take off cover and set in the oven with the beans until served. E. L. McManus, 78 Elm Street, Charleston. Brown bread. 3 cups Indian meal, 1 cup rye, 1 cup flour, 3 cups milk, 1 teaspoon baking soda, 1 cup molasses, 1 egg. Steam 3 hours and bake 1/2 hour. Breakfast and tea cakes. Behold, his breakfast shines with reputation. The following recipes have been in use in my family for over 35 years, and I feel confident that anyone trying them will be very pleased with them. Georgie D. Pyle. Note: the only change in the ingredients in these recipes is in the name of the baking powder. Congress rolls. 1 quart flour, 4 teaspoons baking powder, 1 scant teaspoon salt, 1 large tablespoon lard and butter mixed. Milk to moisten. Mix flour, baking powder, and salt. Rub in the lard and butter. Mix with milk as soft as can be handled. Roll thin, cut into round the size of a small saucer. Spread with softened butter. Fold over, press the edges together, put them some distance apart in the baking pan. Brush over with milk and sugar. Bake in a hot oven. Vienna rolls. To 1 quart of sifted flour add 4 teaspoons baking powder and a little salt. Place in a bowl with a tablespoon of soft warm butter and mix thoroughly. Add sweet milk enough to form a soft dough. Roll out full 1/2 inch thick and cut with a large round cutter. Fold over to form a half round, pressing the fold down with the palm of the hand. Place on buttered pans so as not to touch, and wash them over on top with milk to give them a gloss. Then bake immediately in a hot oven. Breakfast rolls. 1 egg, 1 tablespoon sugar, 1 cup sweet milk, 3 teaspoons baking powder, a little salt, enough flour to mix. Bake in hot gem pans. Egg rolls. 2 eggs well beaten, 1 small teacup milk, 1 tablespoon lard or melted butter, 2 teaspoons baking powder, and enough flour to make stiff as biscuit. Roll out, cut the desired size, and bake in hot oven. Baking powder biscuits. 1 quart flour, 1 level teaspoon salt, 4 teaspoons baking powder, 2 tablespoons butter or lard, milk or milk and water to mix, about 1 to 2 cups. Graham rolls. 1 pint graham, 1 pint white flour, 1 teaspoon salt, 1 teaspoon lard, 3 teaspoonfuls baking powder, 3/4 pint of milk. Sift together graham, flour, salt, and powder. Rub in the lard cold. Add the milk and mix the whole into a smooth dough that can be handled, not too soft. Flour the board, turn it out, and form into rolls the shape and size of large fingers. Moisten top with brush dipped in milk to glaze them. Bake in nice hot oven from 10 to 12 minutes. French rolls. 1 quart of flour, 1 teaspoon salt, 4 teaspoonfuls baking powder, nearly 1 pint milk. Sift flour, salt, and baking powder together thoroughly. Rub in lard cold. Add the milk and mix into a rather firmer dough than ordinary. Flour the board, turn out dough, and immediately give it 1 or 2 quick vigorous turns to complete its smoothness and quality. Now divide it into pieces the size of an egg, and each piece in half. which you form under the hands into the appearance of short, thick rolls tapering sharply at each end. Put 2 of these pieces together side by side, pinching the ends together a little. Lay them on a greased baking tin, wash over with milk, and bake in hot oven 15 minutes. Parker House Rolls. Rub 1 tablespoon of lard or butter into 2 quarts of flour. Scald 1 pint of milk. Let it cool, then add a half cup of yeast with 1/4 cup of sugar, and pour into the middle of the flour without stirring, and let stand overnight. In the morning knead well and set them in a warm place until warm. Then knead again and roll them out 1/2 inch thick. Rye bread. 2 cups rye meal, 4 cups flour, 1/2 cup yeast, 1 tablespoon sugar, 1 hot mashed potato, 1 teaspoon soda, salt, and mix with warm water. Rye drop cakes. 1 pint of sweet milk, 2 eggs, 2 1/2 cups rye flour, 1 1/2 cups of flour, 1/2 teaspoon saleratus, 1 teaspoon cream of tartar, 2 tablespoons sugar, a little salt. Popovers. 1 cup milk, 1 cup flour, 1 egg, a little salt. Graham puffs. 2 cups graham flour, 1 cup flour, 2 cups milk, 2 teaspoons cream tartar, 1 teaspoon soda, 2 teaspoons sugar, 1 teaspoon salt. Blueberry cake. 4 cups flour, 1 cup milk, 1 cup sugar, 2 eggs, 1/2 a cup melted butter, 1 1/2 teaspoons cream tartar, 1 teaspoon baking soda, 1 pint of berries rubbed in a dish of flour. Tea cake. 2 eggs, 2 tablespoons of melted butter, 2 tablespoons sugar, 1 pint flour, 1 cup milk, 2 teaspoons cream of tartar, 1 teaspoon soda. JSP. Buns. 1 cup sugar, 1 cup yeast, 3 cups milk, flour for batter overnight. Add in the morning 1 cup butter, 1 1/2 cup sugar, spice to taste. Knead, cut, and put into pans and raise 4 or 5 hours. Add 2 cups currants. Dip cake. 1 pint of milk, scant pint of flour, 3 eggs, a little salt. Bake 3/4 of an hour in a quick oven. Currant biscuit. Sift 3 pints flour, 1 teaspoon salt, 2 heaping teaspoons sugar, 4 teaspoons baking powder together. Rub in 1 tablespoon each of lard and butter, 1 small cup currants. Mix to a soft dough with sweet milk. Roll out 1 inch thick, cut with small biscuit cutter. Bake in hot oven 20 minutes. A delicious baking powder biscuit. 3 cups flour, 3 heaping teaspoons baking powder, 1 teaspoon salt. Sift all together into mixing dish, and with a silver knife or the tips of the fingers, rub in 1 teaspoon lard. Add cold water a little at a time until flour is all absorbed. Roll out, cut and place in pan to bake 20 to 25 minutes. If not accustomed to making biscuits with water, milk may be used. Riced roll cake. Take 2 cups hot boiled rice, make into balls, dip into beaten egg and then into Indian meal till thoroughly coated. Fry in lard, serve them with sauce, butter, or cream and sugar. Sandwich biscuit. Make as biscuit dough, roll out 1/2 inch thick, cut and spread half the biscuit with butter, then a thick layer of chopped cold meat, well seasoned. Press the other round on top and bake in quick oven. Spiced tea biscuit. Break 2 eggs into cup, melted butter size of an egg. Fill cup with milk and turn into mixing dish. Add 1 cup sugar. Sift 3 times with 2 cups flour with 1 teaspoon cream tartar and half a teaspoon baking soda, half a teaspoon each of allspice, cloves, and cinnamon, a little nutmeg, raisins de suit. Bake in gem tins and ice when cold. Spiced muffins. 1 cup molasses, 1 teaspoon soda, half cup sugar, 1 cup boiling water, half a teaspoon cinnamon, half a teaspoon cloves, 1 egg well beaten, 2 cups flour well sifted. Dissolve soda in boiling water and stir into molasses. Then take rest as in order written. These ingredients make 1 dozen. Puffs. 3 eggs, 3 cups milk, 4 cups flour, a little salt. Rye biscuit. 3 cups rye meal, 2 cups sour milk, 1/3 cup molasses, 2 tablespoons of lard, 2 tablespoons baking soda, a little salt. Cream tartar biscuit. 1 quart sifted flour, butter size of an egg, a little salt, 1 1/2 teacups milk, 2 teaspoons cream of tartar. Put into the flour 1 teaspoon soda dissolved in a little water. Roll out, cut the biscuit, and bake in a quick oven. Brighton biscuit. 4 pounds of flour, 2 pounds white sugar, 1 pound butter, 10 eggs, juice and pulp of 2 oranges, half teaspoon soda. Roll out quite thin and cut in any shape desired. Waffles. Make the same as muffins, only much thinner. Heat the irons well, fill, and bake very quickly. Cream toast. Put a piece of butter the size of an egg into 1 pint of boiling milk. Stir 1 tablespoon flour into 1 cup of cream, and add some of the boiled milk to this. Beat gradually, then put it into the boiling milk and cook a few minutes. Add salt to taste. After taking from fire, pour over a well-beaten egg. Strain the mixture over buttered toast. Bread crisp brown. Take a loaf of stale bread, slice it thin, place on a pie plate in the oven to dry. When entirely dry, close the door and brown. This is mostly used in cases of stomach affections. French cinnamon toast. Beat 2 eggs, add 2 cups sweet milk and a little salt. Sugar may be added to the milk, as it helps to brown it nicely. Dip slices of bread into the mixture, allowing them to absorb it. Then brown the sides on a hot, well-buttered frying pan. Sprinkle with cinnamon, butter, and serve very hot. Buttered toast. Toast bread which is about 2 days old until crisp and a rich brown on both sides. Butter when hot and serve. Breakfast gems. 1 cup sweet milk, 1 1/2 cups flour, 1 tablespoon sugar, 2 teaspoons baking powder. Bake in quick oven. Graham gems. 2 cups graham flour, half cup white flour, 1 egg, 3 teaspoons baking powder, half cup sugar, a little salt, and sweet milk to mix. Rye gems. 1 egg, 1 cup sweet milk, 1/4 cup sugar, 2 teaspoons baking powder, 1 cup flour, 1 cup rye meal. Hominy gems. Take 1 cup well-cooked hominy, add 1 well-beaten egg, 3 tablespoons melted butter, and 2/3 cup milk. Stir into it 2 cups flour, 2 teaspoons baking powder. Mix all together and bake in gem pans 20 minutes in a quick oven. For these gems, either fresh boiled hominy or some which have been set aside cold may be used. Gems. 1 egg, half a cup sugar. Beat together 1 cup milk, 1 heaping teaspoon baking powder, 1 heaping cup graham flour, 1 tablespoon melted butter, pinch of salt. Bake in gem pans. Rhode Island Puffs. Half a cup butter, 2 eggs, 2 teaspoons baking powder, 2½ cups flour, 1 cup sugar, a pinch of salt, 1 cup milk. Cream the butter and sugar. Add the well-beaten eggs and milk, then the flour, salt, and baking powder. Sift it together. The mixture should be a little stiffer than cake. Bake in shallow, well-greased pans about half an hour. Split, butter, and serve. Boston Oddities. 2 cups of flour, 1 teaspoon baking powder, yolk of 1 egg, pinch of salt, 1 tablespoon butter, about half a cup of water. Sift together the flour, salt, and baking powder. Rub in the butter and mix to a stiff paste with a yolk of egg and water. Knead 2 minutes, then roll out very thinly and cut into rounds. Fry in hot fat, and when golden brown, drain and sift sugar over them. Biscuits. 1 sifterful of flour, 2 tablespoons of lard, 2 teaspoons baking powder, 1 teaspoon salt. Muffins. Cream 1/3 cup butter, add 1/4 cup sugar, 1/4 teaspoon salt, 1 egg beaten light, 3/4 cup milk, 3 cups sifted flour, 4 level teaspoons baking powder. Bake in hot buttered gem tins for 25 minutes. Graham muffins. 1 small cup flour, 1/2 cup graham flour, 1/2 cup sugar, 2 teaspoons baking powder, 1 cup milk. Mix all ingredients together, and just before ready to put in gem pans, add melted butter size of an egg. Bake 20 minutes in hot oven. GDP. Mrs. Langston's Muffins. Cream 1/3 cup butter, add gradually 1/2 cup sugar and 1/4 teaspoon salt, 1 egg beaten light, 3/4 cup milk, 3 cups sifted flour, 4 level teaspoons baking powder. Bake in hot buttered gem tins for 25 minutes. Lovely Muffins. 1½ cups flour, pinch of salt, 1 tablespoon butter, 2 eggs, 2 teaspoons baking powder, 1 tablespoon sugar, 1 cup milk. Sift the flour, salt, and baking powder together. Rub in the butter. Add sugar and mix to a batter with the yolk of eggs and milk. Last of all, add the whites of eggs beaten to a stiff froth. Bake at once in a quick oven. Squash Muffins. 2 well-beaten eggs, 1 cup cooked and strained squash, 1 cup milk, a little salt, 2 cups flour, 2 teaspoons baking powder, 1 tablespoon melted butter. After all the ingredients are mixed together, add melted butter last. Bake 30 minutes in a slow oven, having oven very hot when first put in. Mrs. E.J. Pyle. Rye Muffins. 1 pint of rye meal, 1 pint of flour, 1 pint sweet milk, 1/2 cup sugar, 1 teaspoon salt, 3 teaspoons baking powder, 2 eggs. Bake 20 minutes. This quantity makes 24 muffins. Congress Muffins. 3 cups flour, 2 cups sweet milk, 1 egg, 1/2 cup sugar, piece of butter size of a walnut, 3 tablespoons baking powder. Corn Muffins. 1 cup Indian meal, 2 cups white flour, 1/2 cup sugar, 3 teaspoons baking powder, 2 cups milk, 2 eggs well beaten. Scones. 1 egg well beaten, 1 scoop sugar, 1 piece of butter size of an egg, 1 pint milk, 1/2 teaspoon salt, 1 scoop currants, 1 1/4 sifter of flour, 4 teaspoons baking powder. Shortbread. 1 pound flour, 10 ounces butter and lard, 1/4 pound brown sugar, 1 egg. Mix all together on board till firm enough to roll, then cut in squares and bake in moderate oven. Potato scones. Take 1 tablespoon well-mashed potatoes and work into it a small handful of flour until it feels firm and sticks close together. Roll out and cut. Potato cake. Boil a saucepan of good floury potatoes. Peel while hot and set aside until cool enough to handle. Then break them with your hands, and as they become sticky and moist, dredge a little flour over your fingers. Do not use more flour than is necessary. Knead well, adding a little salt. Then form it into the round of frying pan and have it about 2 inches thick and let cook on top of stove, turning frequently. When done, which will be in half an hour, cut in quarters. Slit these in butter while hot. Potato balls. To 1 pint mashed and seasoned potatoes, add part of an egg, well beaten. Mix thoroughly and roll into balls. Brush these over with remaining egg. Dip in cracker or bread crumbs and bake in buttered pan until brown. Apple Johnny cake. 1 pint white meal, 2 tablespoons sugar, 1/2 teaspoon salt, 2 teaspoons baking powder, milk enough to make quite soft, 3 apples pared and sliced. Bake in shallow cake pans 30 minutes. Sponge corn cake. 1 cup Indian meal, 1/2 cup flour, 1/2 teaspoon salt, 2 tablespoons of baking powder, 1 tablespoon sugar, 1 tablespoon melted butter, yolks of 2 eggs and white of 1 egg, beaten separately. 1 1/4 cups milk. If desired, quantity of cornmeal and flour may be reversed. Suet Johnny cake. Take 1 cup beef suet, chopped fine, 1 heaping cup maple sugar, 1 1/2 cups Indian meal, 1 1/2 cups flour. Mix with the flour 1 teaspoon baking powder. After mixing the above ingredients, add 2 tablespoons melted butter and 1 cup milk. Mix thoroughly. Pour into baking pan and bake in quick oven. Note: if maple sugar cannot be had, common brown sugar may be used, but to make the cake perfect there is no substitute for maple sugar. Corn cake. 1 quart of flour, 4 teaspoons of baking powder, 1 teacup Indian meal, 2 eggs, 1/2 cup flour, 2 tablespoons butter. This makes 2 sheets. Corn cake, one of the best. 2 cups flour, 1 cup Indian meal, 1/2 cup sugar, 2 heaping teaspoons baking powder. Mix all together thoroughly and rub in piece of butter the size of an egg. Add 2 eggs well beaten and mix up with sweet milk so that the mixture will just run. Bake at once. Rhode Island Johnny cakes. White bolted meal or cornmeal, white preferred. 1 teaspoon sugar, salt, use judgment as to quantity. Scald with madly boiling water, stir it. The hot water cooks the meal and swells it. Thin to the right consistency for frying with cold milk. Fry in cakes. Mrs. W.R. Hudson. Johnny cake. 2 eggs, 2 tablespoons melted butter, 3/4 cup sugar, 2 cups cornmeal, 2 cups flour, 1 teaspoon baking soda dissolved in hot water, 1 teaspoon salt. Southern Johnny cake. Mix 1 teaspoon salt with 1 cup white cornmeal. Scald it with just enough hot water to dampen it. Then add enough cold milk to form a very stiff batter, almost a dough. Stir it well and drop in cakes about 3/4 of an inch in thickness on a buttered pan. Bake in a hot oven for 25 minutes. Split open and butter while hot. Serve with syrup. Corn cake. Take 1 tablespoon sugar and 1 egg beaten 5 minutes, 1 cup milk, 1 cup Indian meal, 1 cup flour, 2 teaspoons cream of tartar, 1 teaspoon baking soda, Dissolve in a little hot water. Corn cake. 2 cups Indian meal, 1 teaspoon molasses, 3 cups milk, 1 cup of flour, ½ teaspoon soda, a little salt. Hominy cakes. 2 tablespoons fine hominy, 1/2 teaspoon salt, 1 tablespoon butter, 1/2 cup boiling water. Place this over the tea kettle or on the back of the stove until the hominy absorbs all the water. Pour 1 cup of boiling milk on 1 scant cup of cornmeal. Add 2 tablespoons of sugar and the hominy. When cooked, add 2 eggs, yolks and whites beaten separately, and 1 heaping teaspoon of baking powder. Bake in hot buttered gem pans about 20 minutes. Spider corn cake. Mix 1½ cups cornmeal, 1/2 cup flour, 2 tablespoons sugar, 1 teaspoon salt, 4 teaspoons baking powder. Beat 2 eggs and add 2 cups milk. Mix with the dry ingredients. Put 2 tablespoons butter into a spider, and when melted, pour in the mixture. Add 1 cup milk, 1 tablespoon at a time. Bake 20 minutes in a hot oven. Rye cake. 1 cup flour, 1 cup rye meal, 1 cup Indian meal, 1 cup milk, 2 teaspoons baking powder, a small piece of butter, 2 eggs, a little salt. Bake in gem pans. Batter cake. 1 quart flour, 3 teaspoons baking powder, 3 eggs, whites and yolks beaten separately, 1 quart sweet milk, 1 tablespoon melted butter, a little salt. Add whites last. Bake at once. German breakfast cake. 1 quart flour, 2 teaspoons baking powder, 2 tablespoons sugar, 1 tablespoon butter, 1 teaspoon ground cinnamon, a little salt. Mix all the dry ingredients together. Rub in the butter and add enough sweet milk to make a soft dough. Roll into 2 sheets. Put in pie tins, allowing to come up on the side a little, and sprinkle with sugar, cinnamon, and bits of butter. Bake and serve hot. Coffee cakes. 1 cup sweet milk, 1/2 cup of sugar, 1/2 cup of butter, 2 eggs, 2 teaspoons baking powder. Work in enough flour to make a stiff dough. Roll out and sift on the whole sheet some ground cinnamon and roll up. Cut from the roll slices and place on tins. Before baking, sprinkle with sugar. Coffee cake. 2 cups brown sugar, 1 cup butter, 4 eggs, 1 cup cold coffee, 1 teaspoon baking soda, 3 cups flour, 1/4 teaspoon cinnamon, cloves, allspice, mace, ginger, and small nutmeg. Sally Lunn. 1 quart of flour, 4 eggs, 1 cup milk, 1 cup of lard and butter mixed, 2 teaspoons of baking powder, 1 teaspoon of salt. Beat the eggs very light, yolks and whites separately. Melt the shortening, sift the baking powder into the flour, add the whites the last thing. Bake steadily 3/4 of an hour, or until a straw thrust into it comes up clean. Eat while hot. Mount Hoare tea cake. 1 quart flour, 3 teaspoons baking powder, 1 teaspoon salt, 2 eggs, 1 cup sugar, 1 pint milk, 1/4 cup melted butter. Mix the baking powder and salt with the flour. Beat the eggs till thick and creamy. Add the sugar, then the milk. Stir this into the flour, add melted butter last, and beat it well. Bake in a shallow pan. Break and eat it hot. Sally Lunn. 1 pint of flour, 2 teaspoons of baking powder, 1 saltspoon of salt, 2 eggs beaten separately, 1/2 cup of milk, 1/2 cup of melted butter. Scotch scones. 1 quart flour, sifted with 2 teaspoons baking powder, 1 tablespoon sugar, 1/2 teaspoon salt, 1 tablespoon lard, 2 beaten eggs, and a pint of sweet milk, to be eaten hot with butter. Bake in muffin rings in hot oven. Popovers: 2 cups flour, 2 cups milk, 1/2 cup sugar, 2 eggs, butter the size of an egg, 1 teaspoon baking powder, a little salt. Rusks: 1½ pints of flour, 1/2 teaspoon salt, 3 tablespoons sugar, 2 tablespoons baking powder, 2 tablespoons of lard, 3 eggs, 1 teaspoon each nutmeg and cinnamon, 3/4 pint of milk. Stir together flour, salt, sugar, and powder. Rub in the lard cold. Add the milk, beaten eggs, and spices. Mix into a dough soft enough to handle. Flour the board. Turn out the dough. Give it a quick turn or two to complete its smoothness. Roll them under the hands into balls the size of a small egg. Lay them on a greased shallow cake pan. Put very close together. Bake in moderately heated oven 30 minutes. When cold, sift sugar over them. Snowballs: 1 cup of sugar, 1 cup of flour, 2 tablespoons sweet milk, 1 teaspoon baking powder, 3 eggs. Flavor with lemon. Put 1 tablespoon in a powdered cup and steam 20 minutes. Roll in white sugar while hot. Apple rolls: 1 cup of sweet milk, 1/2 cup sugar, 1/4 cup butter, 2 cups flour, 1½ cups chopped apple, 2 teaspoons baking powder. Put in the apple the last thing. Put gem pan on stove and grease with lard, leaving just a little lard in bottom of each pan. Have the pan sizzling hot and let the batter stand in pans about 1 minute on top of the stove. Then put in a hot oven and bake quickly. This amount makes 8 or 9 rolls. Very nice for tea. Crumpets: melt 1 small tablespoon lard. Add to it 1 egg and 1½ gills milk. Beat well, then add 1/2 teaspoon salt, 1 teaspoon sugar, 1½ teaspoons baking powder. Sift it with 2 1/2 gills flour. Bake in muffin rings in a very hot oven at once for 5 minutes. This quantity makes 6 crumpets. The secret of success is quick making and quick baking. Rice waffles: 1 cup boiled rice, 1 pint of milk, 2 eggs, lard the size of a walnut, 2 teaspoons baking powder, 1 teaspoon salt, flour for a thin batter. Oatmeal crackers: 3 cups oatmeal, 3 cups flour, salt, 2 eggs, 1 cup brown sugar, 2 teaspoons baking powder, 1 piece butter or lard, size of an egg. Milk to moisten it. Roll thin and bake in a quick oven. Graham crackers: 1 quart best graham flour, 1 tablespoon sugar, 1/2 teaspoon salt, 1 teaspoon baking powder, 2 tablespoons butter, little more than 1/2 pint milk. Sift together graham, sugar, salt, and powder. Rub in the lard, cold. Add the milk and mix into a smooth, consistent dough. Flour the board, turn out the dough, and knead it well for 5 minutes. Roll it with a rolling pin to thickness of 1/4 inch. Cut it with a knife into small envelope-shaped crackers. Bake in rather hot oven with care, as they burn readily, for 10 minutes. Handle carefully while hot. When cold, store for use. Gem crackers: 1½ pints flour, 1/2 pint cornmeal, 1 teaspoon salt, 1 teaspoon baking powder, 1 tablespoon butter, little more than 1/2 pint milk. Sift together flour, cornmeal, salt, and powder. Rub in the butter cold. Add the milk. Mix into a smooth, rather firm dough. Flour the board. Turn out the dough. Give it a turn or two quickly. and roll it to the thickness of 1/4 inch. Cut out with a small oval cutter. Prick each cracker with a fork. Lay them on a greased baking tin. Wash over with milk and bake in hot oven 8 to 10 minutes. When cold, store for use. Fruit crackers. Prepare a dough as described for gem crackers. Divide it in half. Roll it each half exceedingly thin. On one half spread a close layer of well-washed, pickled, and dried currants. Sprinkle thoroughly with milk, and cover with the other half. Allow it to stay thus prepared, covered with a cloth, 5 minutes. Then cut with a knife into square crackers, not too large. Lay on a greased baking tin and bake in good hot oven 15 minutes. When cold, store for use. Griddle cakes. In making griddle cakes, the flour, meal, salt, baking powder, and other dry ingredients should be thoroughly mixed together. Then the milk or water added to form a smooth, consistent batter that will run from the mouth of a pitcher in a thick stream. Pour upon a hot griddle, greased with a small piece of fat pork, and bake to a brown color, turning them so that both sides will be a rich brown. Serve with sugar, molasses, or maple syrup. Griddle cakes. 3 cups flour, 2 teaspoons baking powder, 1 teaspoon salt. Mix well and add 2 well-beaten eggs. Add enough sweet milk to make a soft batter and bake at once. Buckwheat cakes. 2 teaspoons buckwheat flour, 1 teacup wheat flour, 4 teaspoons baking powder, 1 teaspoon salt. Mix all together and add sufficient sweet milk or water to make a soft batter. Bake on grill at once. Economical griddle cakes. 1 quart stale bread, soaked to a pulp in milk or water. Add 1 beaten egg, pinch of salt, and 1 teaspoon baking powder. Sift into 1/2 cup flour. Indian griddle cakes. 2/3 quart cornmeal, 1/3 quart flour, 1 teaspoon brown sugar, 1/2 teaspoon salt, 3 teaspoons baking powder, 2 eggs, and 1 pint milk. Rye griddle cakes. 1 pint rye flour, 1/2 pint graham, 1/2 pint flour, 1 tablespoon sugar, 1/2 teaspoon salt, 3 teaspoons baking powder, 1 egg, and 1 pint milk. Graham griddle cakes. 1 pint graham flour, 1/2 pint cornmeal, 1/2 pint flour, 1 teaspoon sugar, 1/2 teaspoon salt, 3 teaspoons baking powder, 1 egg, 1/2 pint each of milk and water. Apple griddle cakes. 1/2 pint cold stewed apple, 1/2 pint graham flour, 1/2 pint cornmeal, 1/2 teaspoon salt, 2 teaspoons baking powder, 2 eggs, 1/2 pint milk. The apple should be free from lumps. Add to it the beaten eggs and milk, then the graham, cornmeal, salt, and baking powder, after they have been thoroughly mixed together. Squash griddle cakes can be made the same as above, using 1/2 pint sifted squash in place of the apple. Squash griddle cakes. 1 cup sifted squash, 1 cup boiling milk, 1 tablespoon sugar, 1 tablespoon butter, 1/2 teaspoon salt, 1 egg, 2 teaspoons baking powder, and 1 cup of flour. The milk should be poured into the squash, the butter, sugar, and salt added. When cool, add the beaten egg, then the flour into which the yeast powder has been well mixed. If too thin, add more flour. If too thick, add milk. Berry griddle cakes. 1/2 pint berries, 1½ pints flour, 1 teaspoon salt, 1 tablespoon sugar, 3 teaspoons baking powder, 2 eggs, 1 pint milk. The griddle should be hot enough to form a crust as soon as the batter touches it, and the cake should be turned quickly so as to form a crust on both sides to confine the juice of the berries. Indian pancakes. 1 pint of Indian meal, 1 teaspoon salt mixed with enough boiling water to make a little thinner than mush. When cool, add the yolks of 4 eggs, half a cup of flour sifted with 3 teaspoons baking powder, enough sweet milk to make batter as for griddle cakes, and the beaten whites of 4 eggs added just before baking. Pancakes. 2 eggs, 2 ounces of butter, 4 ounces of flour, 1 pint of sweet milk, and 1 teaspoon of baking powder. Bake on jelly cake tins or on a griddle. Serve with cut lemon and sifted sugar, or pile the pancakes high on a dish with preserves or marmalade between them. French pancakes. 1 egg, 1 cup of milk, pinch of salt, 1 teaspoon baking powder, and about 2 tablespoons of flour. It needs to be very thin so it will run over the griddle. When done, spread with jelly and roll up. Sprinkle with powdered sugar, to be used as a side dish. Trifles. 1 quart flour, 1 cup sugar, 2 tablespoons melted butter, 1 egg, 2 teaspoons baking powder. Sift it with flour and enough sweet milk to make stiff as crullers. Roll into thin sheets and cut in pieces about 2 by 4 inches. Make as many cuts across the short way as possible. Pass 2 knitting needles under every strip. Spread the needles as far apart as possible, and with them hold the trifles in the fat until a light brown. Fried muffins. 1 egg, 1/2 cup sugar, 3/4 cup milk, 1 teaspoon baking powder, 1 saltspoon salt, flour. Beat the egg very light, add the sugar and beat again. Add the milk and then 2 cups of flour into which baking powder and salt have been mixed. If needed, add more flour to make a stiff batter. Drop from a spoon into hot fat. Fried rye muffins. 3/4 cup rye meal, 3/4 cup flour, 2 teaspoons baking powder, 1 tablespoon sugar, 1 saltspoon salt, 1 egg, 1/2 cup milk. Drop from a spoon into hot fat and cook until they will not stick when tried with a fork. Congress crullers. 2 cups sugar, 1 of milk, 4 eggs, 2 tablespoons butter, nutmeg or other spice to taste, 3 teaspoons baking powder, flour enough to roll out. Fry in hot lard. Cream crullers. 1½ cup sugar, 2 cups cream, 2 eggs, 2 teaspoons baking powder mixed in enough flour to roll out soft. Cut in desired shapes and fry in very hot lard. Pancakes. 1 cup Indian meal, scald it very soft, 1 cup rye meal, or 1 cup flour, ½ cup yeast, cinnamon, and a little molasses. Buckwheat cakes. 1 quart buckwheat flour, 1 teaspoon salt. Stir in water to make a thin batter. Beat thoroughly 4 tablespoons yeast. Set batter in a warm place. Let it rise overnight. Add 1 teaspoon of soda in the morning, also 2 tablespoons of molasses. End of chapters 1 and 2 of the Toronto Cookbook by Mrs. E.J. Powell.